So let's dive right on into Google Cloud Platform. Google Cloud is basically just a set of physical assets, such as computers, hard disk drives, and which you can turn into virtual resources, such as virtual machines. These are contained in Google's data centers, and these are all around the globe. So each data center location is in a region. These regions are Asia, Europe, Australia, North America, and South America. Each region is a collection of zones. So these zones are isolated from each other within a region. So if one zone were to go down, it wouldn't affect the other zones because they're isolated from each other. Each zone is identified by a name that combines a letter identifier with the name of the region. So East Asia would be Asia East 1-A. So why should we use Google Cloud? So Google is different from other cloud providers in a lot of ways. First of all, big data. Right? Google's big data technology has innovations like MapReduce, Dremel, and Bigtable. It does billing by the second, so your compute instances are charged in 1 second increments with a 1 minute minimum. So you're not paying for compute minutes that you're not using. It's environmentally friendly. Google Cloud, the data centers themselves run on half the energy of a typical data center and run on 100% renewable energy where that is available. You get the Google grade security that you're always used to using, and you have access to the global network. So Google's backbone network has advanced software-defined networking and edge caching services, and it will deliver a fast, consistent, and scalable performance. So the Google Cloud Platform, and what makes up a Google Cloud Platform? First of all, global resources. So some resources you can access globally. So these could be pre-configured disk images, snapshots, and your virtual networks. These are all what we consider global resources. They can be reached from any region. You also have regional resources. Things like static IPs are regional resources, right? Some resources can only be accessed by resources in that same region, and that would be an example of a regional resource. And then you have zonal resources. So things like VM instances would be a zonal resource. So these resources can only be accessed by resources that are in the same zone. So any Google Cloud resources that you want to use, it must belong to a project. So think of a project as an entity for what you're building. The project is made up of settings, permissions, metadata. It's the whole kitchen sink with regards to your applications. So each Google Cloud project has a project name that you can provide, and it should be kind of meaningful so you can look at the project name and see what you want to accomplish. A project ID, which you can provide or Google Cloud can provide for you, and a project number which is automatically assigned by Google Cloud. Client libraries and the Google Cloud. So the Cloud SDK has some client libraries enabled that you can use to automatically and easily create and manage your resources. The Google Cloud Client exposes APIs for two main purposes. It exposes an app API to provide access to services. So these libraries are designed around surface metaphors. So you can work with the services more naturally and you can write less code. And you also have admin APIs that offer functionality for resource management. So if you want to build some tools, you can use the admin APIs. Google Cloud Platform checklists. So they offer you a launch checklist, which gives you the best practices before you start launching your applications in the Google Cloud Platform. So the launch checklist itself defines some best practices and is designed for enterprise developers. So developers who are making enterprise applications and want to ensure security, budgeting, and those type of things. So it gives you those best practices. You can also get service-specific launch checklists. So depending on what service you're using, you can get detailed guidance on that specific service using a service-specific launch checklist. One of these checklists that you should really use in the early stages is the architect design and development checklist. So it's broken down by the software architecture work. So try and include an overall architectural diagram so you can see everything that you're creating and see how it all interacts with one another. List and describe how each Google Cloud Platform service is used. You want to establish points of contact. So who is your contact for VM related issues? Who is your contact for database related issues? Next is provisioning. So you want to provision Google Cloud Platform projects in your development environment or your test environment or your prod environment. Right? You can provision domains and certificates for your security needs. And finally, launch plans and traffic estimates. So calculate your traffic estimates because that's going to be a big thing in deciding whether your application is going to handle the load or not. Create a launch plan. On the day of launch, how do we launch our application? What should we do if we need to roll back? Some other platform checklists that we can use is the alpha testing checklist. So when you're just about finished coding and you want to get some initial metrics about your application, this is a checklist that you want to use. We have a soft launch checklist. So prior to the application's launch, we want to test the readiness. We have a final launch checklist. So shortly before launch and during our launch, we will use that to make sure all of our team members are available in this case, because if we got any issues, we're going to have to resolve them. And of course, our post-launch checklist. So what lessons have we learned? And what post-mortem document can we create to kind of document everything that went right, everything that went wrong, and what we can do going forward next time we launch an application in Google Cloud. Now let's look at how we interact with Google Cloud services. So in cloud computing, you might be used to thinking of as software or hardware products, and these are services. But these services have access to underlying resources. So how do we interact with these services using Google Cloud? First, we can use the Google Cloud Console. So that's a web-based graphical user interface, and we can manage all our Google Cloud projects and resources. If you're so inclined, you can use the command line interface. So if you like to work at the command line interface, you can perform most of the Google Cloud tasks by using the gcloud command line tool. And finally, client libraries. So the Cloud SDK includes client libraries that enable you to easily create and manage your resources. So what are the computing and hosting services offered by Google Cloud Platform? You have a serverless option. So you can take advantage of, say, functions as a service, and that'll provide serverless executions for building and connecting cloud services. Great for microservices. You can use application platform if you don't want to worry about the underlying hardware and the infrastructure, and you just want a development environment, somewhere to host your application. The application platform is a great option for you. If you're using container-based applications, you can use Google Kubernetes, which is built on the open source Kubernetes platform, to build and host your container-based applications. And of course, you have virtual machine options as well. And you can spin up multiple different types of virtual machines with different operating systems depending on your use case. Storage services. So whatever your application or your workload is going to be, you're going to need to store some files. So Google Cloud offers you regular cloud storage with maximum availability. You have persistent disks that live on the compute engine. So these are primary storage for your instances. These can either be hard disks or solid state persistent disks. And you have file store. So a fully managed NFS file server with file store. So whatever your use case can be, there are storage services available for you. Google Cloud also offers database services. So you can get a SQL database in the cloud using Cloud SQL. So that's either a MySQL or PostgreSQL database. You can have a fully managed mission-critical relational database service in Cloud Spanner. So you don't have to worry about any of the underlying infrastructure. Your replication is already created for you for high availability. And you can use NoSQL data storage in Firestore or in Cloud Bigtable. So if you want a NoSQL solution, there are options there for you as well. So how do we tie it all together? And that really comes down to networking services. We're going to create a virtual private cloud, and that provides a set of networking services such as firewalls and routes, load balancing, a built-in cloud domain name system, so we don't have to go outside the cloud to deal with our DNS and to route our traffic to our applications, and advanced connectivity. So if you have an existing network on-premise, you want to connect it to the cloud. Google Cloud offers you products like Google Interconnect, Cloud VPN, and direct peering to connect your on-premise to your cloud environment. There's big data services. So if you want data analysis, you can use BigQuery. You can use SQL-like commands to query massive data sets. Data flow allows for batch and streaming. So it's a managed service and a set of SDKs that you can use to perform batch and streaming on your data processing. And asynchronous messaging. So PubSub is an asynchronous messaging service. This is great for tying in microservices or applications when they want to speak to another. They can send messages as JSON data structures. And machine learning service APIs. So things like Cloud Vision allows us to integrate vision detection features and facial recognition. Cloud Natural Language allows us to add sentiment analysis. So if we want to view the sentiment of or reviews of our products, for example. Cloud Translation lets us quickly translate source text into any of over 100 supported languages. Dialogflow lets us build conversational interfaces or chatbots for websites and mobile applications. Speech to text is used to convert audio to text. And video intelligence that allows us to use video analysis technology and provides label detection, explicit content detection, shot change detection, and regionalization features. So there's a lot of good options for AI and machine learning as well in the Google Cloud Platform. In this video, I want to demonstrate how you can choose the correct compute option for your application or your workload in the Google Cloud Platform. So when you start a project in GCP, one of the first decisions you have to make is what computing service to use. Will it be Google Compute Engine? Will it be Google Container Engine? Will it be App Engine? Or even Google Cloud Functions and Firebase? So the range of compute services go from giving you full control. So the compute engine will give you full control of the compute. Or you can have highly abstracted versions like Firebase and Cloud Functions, where Google takes care of all the management of the compute and you only have to worry about development. So there's a Google Cloud Platform decision tree that allows you to kind of pine down what you're trying to use Google Cloud Platform for, and it will give you the best compute options for you. So if you look, the first thing it asks us is, are you a mobile or HTML5 developer? So if you're building a thick client and it only relies on backend or synchronization, then Firebase would be a good option. So if you choose yes, then you may want Firebase. That allows you to store complex NoSQL documents, and you can use an easy API, and there's a client available for iOS. But if you're not, or if you're developing an event-driven app, you may be looking for something more based on events rather than user interactions. So you're building an application that'll respond to uploaded files or maybe logins. So if you are, Google Cloud Functions can be great for you. That's a serverless function. It's a function as a service and allows you to write JavaScript functions that run on Node.js, and it can call any one of the APIs like Cloud Vision or Translate. And with Cloud Functions, you can build complex individual functions that get exposed as microservices. But if you're not developing an event-driven app, you can choose no. And then you get asked, is your application any of the following. So are you using a specific OS or kernel? Does that solution exist somewhere else? Do you need licensed software, right? So if we ask, do we need a specific operating system or kernel, or if we're using GPUs, then the Google Compute Engine may be for you. But if you're not, then are you using licensed software? Are you using a hybrid or multi-cloud environment? If you're not, then Google App Engine may be what you need to take advantage of. But if you're going to be using containers, or if you are using licensed software or an already existing app, then you've got to ask yourself, are you using containers? If you're not, Google Compute Engine may work perfectly for you. If you are, you may want to use the Kubernetes. So are you going to use Kubernetes as your container orchestrator? If you are, you can use the Google Container Engine. If you're not, you can use the Google Compute Engine. So this kind of gives you a whole look into the whole flow chart. And this is not a comprehensive decision tree, but each product meets your needs a little bit better. So by using this cloud platform tree, you can get a good look at what you should start using. Is it containers? Am I using something where I just need something like Firebase, where I can put my application and host it and develop it? Do I need something where I need a little bit more access to the underlying operating system? If that's the case, maybe Google Compute Engine. Or if I want to go serverless, then I've got Google Cloud Functions. So this is a good decision tree. Again, it's not a comprehensive list, but it gives you a good decision on where you want to focus your efforts when starting with the compute options in Google Cloud Platform. In this video, I'm going to demonstrate how to sign up for a Google Cloud Platform account. So the first thing we need to do is fire up our web browser and go to cloud.google.com. Once we're here, you'll see the Google Cloud page. I'm going to full page my screen so we can see it a little better. First thing you see is new customers get $300 in free credits to spend on Google Cloud. So that's a great way to get in and learn about the cloud. So I'm going to go ahead and click Get Started for free. It opens up the Google Cloud page. Once it all fires up, now I have to provide my account information. I already have a Gmail account, so I can use that account. So I could switch account if I wanted to use another Gmail account, but you have to use a Gmail account to sign in. So I'm going to use my richspencer@gmail.com account. I'm going to give the country of Canada, and I'm going to put in my phone number so I can get a text message sent. So I'll put in my phone number, and I'll click Send Code. Now I wait for the code to come in on my phone. So my code came in. I put in my two-step verification code. I click Verify. Make sure I put in my code. Phone number has been verified. So now I can agree to the terms of service. And if I would like any email updates, I can go ahead and click this box. I'm going to go ahead and click Continue. You'll see that it starts spinning. It's doing something. Now it needs some payment information verification. So even though you've got $300 in credit, the payment information is to help stop the abuse and the fraud. So it comes up with my name, my address, how I want to pay. So do I want to pay monthly automatic payments? And my payment method. So I'm going to go ahead and use PayPal. But here you could add different payment methods like Visas or different credit cards or debit cards. So I'm going to go ahead and click Start My Free Trial. It sets up. You can see it's finished setting up the project. And now I brought in the Google Cloud Platform. So your free trial includes $300 in credit to spend over the next 90 days. So now it wants to ask you 4 questions to kind of figure out why you're using Google Cloud. So what best describes your organization's needs? I'm just helping clients use the cloud. Depending on what you want the cloud for, you can change this. What brought you to Google Cloud? I'm evaluating the technical capabilities of Google Cloud. Click Next. What are you interested in? So could be any of these. I'm going to say I'm not sure because we still got a lot to learn, and we're going to learn about a lot of these things. So click next, and what best describes your role. I'm going to go down and say academic or educator. Again, yours will be different. So I go ahead and click done, and now I am in the Google Cloud Platform. You'll see our checklists are here, so I can go to the checklist. You can see I've created a billing account, I've created a project, and now I got to start looking at products and APIs and actually implementing that in my project. So if I go back, everything we see is here inside the console. So I hope this video showed you how to get started with Google Cloud and how to get in and start looking at some of the services and resources that we'll use to build applications and or run workloads in the cloud. In this video, I'm going to demonstrate how to navigate the Google Cloud Platform console. So once we're at cloud.google.com, we'll see a page that says Go to Console. So go ahead and click that big blue button, and let's go into the Google console. You can see it loading up, and we're brought right into the main page of the console itself. And once it fires up, you can see everything right at one glance. So under Dashboard, you have project info. So my project name is here, my first project, my project ID, and my project number. I can add people to this project. I can go to project settings. I also have APIs here on my main dashboard, the Google Cloud Platform status. So if there's any services undergoing any issues, I would see those here. I can do monitoring from my dashboard, create a new dashboard, set up alerting policies, and create uptime checks. I can look at my resources that are assigned to the project. I can set up traces to see what's going on in my applications over the last 7 days. And I have a getting started area where I can look at the APIs, I can deploy a pre-built solution, deploy a Hello World app, and so on. So it's really good to get you in and get you started. You'll also notice under activity. So if I click under activity, we'll see all the activity that has happened in my account. So I can break it down by categories. So what types of activities? Billing, configuration, development. I can also break it down by resource type. So it can be load balancers, it can be a SQL database, right? And it takes a little time to load up. But when it loads up, you can see the user email address and you can see what they had done. There's also recommendations. So if we were to have an application deployed, it would give us recommendations on it, whether it would be security recommendations, performance recommendations. You would find these here. On the left-hand side, you see in our main section under dashboard, but you see new stuff like identity and access management, security, and then you see compute. So you're going to start seeing categories now on the left-hand side. This is the easy way to get to our specific services. So compute engine is here, Kubernetes is here. Each time I hover over one, it gives me another pop-out list of options. We've got serverless options like Cloud Run and Cloud Functions, storage options like File Store and Cloud Storage. We've got databases, and we've got application integration. So API gateway, workflows, cloud tasks, it's all here. And then networking. So we can create our networking VPCs. All of our testing is here. Any connectivity through on-premise is done here as well. We have an operations section for monitoring, debugging, and logging. And then we get into development tools for continuous integration and continuous deployment. So cloud build, container registry, and specific source repositories that you may use. We've got tools like Deployment Manager, and then we get into big data tools like Composer, PubSub, IoT Core. And then finally, the artificial intelligence area, where you can see all your AI tools, like document AI, data labeling, vision. So this is your console, and this is how we navigate the console. You can also search for products and resources up here. So if I wanted to search for something like Kubernetes, it'll find it for me. And it'll also find stuff in the marketplace if it applies. I can change projects here. So if I had multiple projects, I can just click the drop down right here by my first project, and I can change into a specifically different project. Over here, we've got our free trial status. So how much money we have left in credit and days. And you have the Cloud Shell. So you can activate a shell inside the cloud to manage your infrastructure right from the console. So if you click deactivate the shell and click OK, now you'll see on the bottom we have a terminal, and we can interact with all of our resources using the Cloud Shell terminal inside the console. So we're going to use this console a lot more, but I hope this video gave you some insight on how to get in, look around, and see the key areas and key features of the Google Cloud Platform console. In this video, I'm going to demonstrate how to create and manage a billing account in the Google Cloud Platform. So once we're signed into Google Cloud, we'll be brought to our main dashboard page. We want to go to the billing section, so let's come over to the navigation menu on the left, click the navigation menu, and you'll see a pop-out. From here, we want to choose billing. So I'm going to go ahead and click billing, and I'll be brought into the billing statement area. So here's my billing account overview. So my billing account has been created from when I created my account, but you can also add more billing accounts. Especially good for organizations. If you have multiple people using it or multiple projects, you can assign to different billing accounts. So I'm going to come over to billing account, and I'm going to click manage. So once I'm in here, you can see my billing account. I can add new members to the billing account. Any projects that are linked to the billing account are here. But if I want to add more to my billing, I come back up here and just click billing. I can come over to the drop down, and under billing account, where it says my billing account, I can come down and click manage billing accounts. So if I click manage billing accounts, here's where I can create another billing account. So let's say we want to create another account. I'm going to call it development account. So all of our development work will go in there. The country is Canada. I click continue. And now you'll see I have a billing profile called development account. You have to choose a payments profile. So what is the payment profile that's going to be associated with this account? In this case, it's me. The account type is individual. My name and address is there. And then how do you pay? So monthly automatic payments through my payment method of PayPal. I could expand here. I could use Visa. I could use an add credit or debit card or another PayPal account. So this is good if you got multiple people inside your Google Cloud platform and they're all using a lot of different resources and maybe different projects. So I'm going to go ahead and submit and enable billing. Now I've got another billing account. So I've got two billing accounts, the development account and my billing account, which was the default one. So from here, I can take projects and assign them to each individual billing account as needed. So I can come back now and you'll see there's reports. So reports will break down how much used, right, for each billing account. There's a cost table, there's a cost breakdown, right? And this is for my development account. If I switch over to my billing account, I can see the exact same things, right? But you can just change what billing account is being viewed by the dropdown. So I hope this video showed you how to create a billing account, how to manage billing accounts, and to create up payment policies, and really why you would want to create multiple billing accounts. And again, it's great when you have multiple users and multiple projects. In this video, I'm going to show you how to create cloud billing budgets and alerts in your Google Cloud platform. So budgeting allows you to track your Google Cloud spending against your actual planned spending. After you set a budget, you can set budget threshold rules that are used to trigger email alerts. So if you go over your budget, you'll be notified very quickly. And it allows you to stay informed about how your money is being spent across your budgets. So with the cloud billing budgets, we can define the scope of the budget. We can set the budget amount to a total that we specify, or we can base the budget amount on the previous month's spend. We can set threshold rules to trigger email alert notification, so when our costs exceed a percentage of our budget, and we can specify who we want to send these emails to. So let's look at how to actually set up this budgeting and alerting. So once we're in the Google Cloud Console, we want to come over and navigate to Billing. So let's click Billing and you'll be brought in. You'll see if you have multiple billing accounts. If you want to manage both billing accounts, you can go to a linked billing account, or you can manage billing accounts one by one. So I'm going to click Manage Billing Accounts. You'll see I have 2 billing accounts here. So I'm going to go ahead and click my development account. I'm brought into my development account. And on the left-hand side, we want to select budgets and alerts. So I'm going to click budgets and alerts. And I'm going to create a budget. So I'm going to click create budget. And here's where we see the scope and the amount and all the settings that we can change. So about the scope, a budget can be applied to a specific scope focused on a specific set of resources. So I'm just going to call this development billing. And I'm going to set my scope as all services. I want to make sure that anything that's being used, I want to be included in this scope. You can select credits that are applied to the total cost, and then the budget will track the total cost minus any of your discounts, any of your promotions. So I'm happy with this. I'll go ahead and click Next. You'll see the specified amount. So set a monthly budget amount. Budgets begin on the first of the month and reset at the beginning of the month. So if I want to set a target amount of $100 a month, spread out over all resources. So I'll click Next. Now we get our email threshold alerts. So when do we want to be triggered? So 50% of the budget, do we want to be triggered on the actual 50% of the budget, or do we want to be triggered if the forecast looks like we're going to be at 50% of our budget? I'm going to leave it on actual. I want an alert when we're 50% of our budget is used. I want an alert when 90% of the budget is used. And I want an alert when 100% of the budget is used. I could also add more thresholds. So if I click Add Threshold, and if I wanted to be alerted when 75% of the budget, then I can do that as well. And you can see it already automatically fills in your amount based on the total amount you want to spend. So I'm happy with these percentages. Now I need to manage my notifications. So I leave this setting clicked, email alerts to billing admins and users. So your account would be a billing admin if you set up Google Cloud under your email. I can also link monitoring email channels to budget, and I connect to a pub subtopic. So I can select a project and use a pub subtopic, and anyone who can view the budget will be able to view the project ID and the topic name. I'm just going to leave it as email alerts to billing admins and users, and I'm going to click Finish. So now you'll see it's done. Under Budgets and Alerts, I have a budget name, I have a budget type. This applies to, so the scope applies to this billing account, right, the development account. Here are my triggers, and here are my spends. So right now I haven't used anything, so I'm well under the triggers. But as it continues to build, we should start seeing this bar fill up. So I hope this video showed you how to create budgets and alerts in your billing account. And you can always know how much of your money is being spent on Google Cloud. So there's no surprises come bill time. In this video, I'm going to show you how to export your cloud billing data to BigQuery. So being able to export our billing data to BigQuery allows us to be able to automatically throughout the day update our usage and cost estimates and pricing data. We can access our cloud billing data from BigQuery for detailed analysis, or we can use tools like Google Data Studio to actually visualize our data. So what do we need to do to actually set up cloud billing data export to BigQuery. There's a few steps we need to take. So we need to create a project where the cloud billing data will be stored. In this case, we're going to use the project we already have, my first project. We have to configure permissions on the project and on the cloud billing account. We need to enable the BigQuery Data Transfer Service API, create a BigQuery data set to store our data, and then enable cloud billing export of cost data and pricing data so that we can write it to the data set. So with regards to resources, we are a billing administrator. So when we set up our account, we're a billing administrator. So we have the proper permissions to perform what we need to do right here. So our next step is to enable cloud billing data export to BigQuery. So we're selecting our project. Our project is my first project with the ID of Sigma Smile 311516. Yours will be different. I'm going to go ahead and click cancel. We still know that this is the project we're working on because it is the drop-down bar up here on the main platform console page. So we want to enable the BigQuery Data Transfer Service API. So we need to come over to APIs, and we want to click Go to APIs Overview. Up on the top, you'll see Enable APIs and Services. So let's go ahead and click Enable APIs and Services and search for an API library called BigQuery Data Transfer API. So go ahead and click the BigQuery Data Transfer API and click to enable this API. So let's go ahead and enable the API in this project. So once this is enabled, you'll see it is now enabled because you have an option of disabling it. So now let's click Create Credentials. So to use this API, we need to click Create Credentials. So I'm going to create credentials. Which API are you using? So we're going to use the BigQuery Data Transfer API. And it says this Google Cloud Platform API is usually accessed from a server using a service account. So to access on behalf of a user, which is common in some tasks, create an OAuth client, but we're fine using it just as service account. So are you planning to use this API with App Engine or Compute Engine? No, I'm not using them. So what credentials do I need? I need a service account name. So I'm going to give it billing. I'm going to select the role of a project billing manager, and I'm going to give it BigQuery admin. I'm going to go and click continue. JSON is fine. And now I can download my key, and the service account has been created. So now we need to create a BigQuery data set. So we want to come up under Search Products and Resources and type in BigQuery. We'll see the BigQuery products and pages. So let's go ahead and click BigQuery, and we're brought into the BigQuery platform. So you'll see your project here is a pin project. Let's click our three dots here, and let's click Open. So we've opened this project now. Now we need to actually create the data set. So let's click plus button to create a data set. And now we have to give it a data set ID. So we can give it something like all billing data, and the data location is set to default. We want to make sure our default table never expires, and the encryption is a Google Managed Key. So come down and click the blue Create Dataset button, and it has been now created. And now our last step is to enable the cloud billing export to the BigQuery dataset. So let's come back over to our main navigation menu, and let's click Billing. Now we have two billing accounts, so we can go to the link billing account or we can manage billing accounts. So let's click Go to the link billing account to manage the cloud billing for the current cloud project. And now in the billing navigational menu, you see Billing Export. So let's click Billing Export. Now under the BigQuery Export tab, we need to enable two types of data we want to export, the daily cost detail and the pricing detail. So go ahead and click Edit Settings. Our project is my first project. We want to export the daily cost detail, and we want to load it to the data set we created earlier called All Billing Data. So when we're happy here, we click Save, and our daily cost detail is now enabled and it's being sent to the All Billing Data dataset. And we can edit our pricing, and we can also send our pricing data to the same data set. And we go ahead and click Save. And now we've successfully enabled our daily cost data and our pricing data to be sent to BigQuery. So our daily cost detail is saved and our pricing detail. Now we can take that data in BigQuery and visualize it and run some advanced analysis on it. So I hope this video showed you how to export your billing data to BigQuery for further analysis and visualization. In this video, I'm going to demonstrate how to change the billing account for a project. So once we're in the Google Cloud Platform main page, we can click the blue button to go to the console. So I go ahead and click the blue button, and then I'm brought into the console. So we have multiple projects, and we may have multiple billing accounts. So how do we change billing accounts for our projects? How do we add a billing account or replace a billing account for our project? So once we're in the project, you can see my first project. It's Sigma Smile 311516. I can come over and click the navigational menu, and I can go under billing. So let me go ahead and click billing. Then you see your page. You have multiple billing accounts. Do I want to go to the linked billing account for this project, or do I want to manage my billing accounts? So in this case, I'm going to select go to linked billing account. So I click go to linked billing account, and I'm brought into this billing account, as you can see over here, right? So I can change my billing account if I want to, right? Because I have two using the drop down. I'm going to leave it on my billing account. And then I'm going to come down to the bottom, and you'll see the gear that says account management. Go ahead and click account management. And now you'll see project linked to this billing account. So here's where I can change the projects that are linked to this billing account. So as we can see, my first project is linked to this billing account. So if I go ahead and click the three dots, I can disable billing here, but I can also change the billing. So if I go ahead and click change billing, you'll see set the billing account. So I want to change the billing account. This project pays for both the Google Cloud Platform and the Maps platform. So I want to change my billing account. I can click the drop down here, and I can use the development account or my billing account. So right now it is using my billing account. I'm going to go ahead and change it to development account. So maybe this project now is part of the development team and it gets billed a different way. So I'm going to go ahead and click set account. It comes back. Now you can see that there's no projects linked to this billing account because I just changed it. We're not using the My Billing account anymore. So if I come up under the drop down and change it from My Billing account to development account, now you'll see the projects are linked to this billing account. So if I click the three dots, I can change it back again, or I can just leave it on this development account. And that's how I'm going to leave it. You can also add members here. So you can add members to edit or delete permissions. And you can always see your billing account administrator. So that's who I'm logged in as. That's my account. So I'm the billing account administrator. And that allows me to change the billing accounts that are associated with projects. So I hope this video showed you how to do just that and how to change and associate different billing accounts to different projects as needed in your organization. In this video, I'm going to demonstrate how to use the Google Cloud Platform pricing calculator. So this is a great tool to kind of estimate your charges before you actually start to provision your resources. So once we're at the Google Cloud main page, we can click Go to Console, and we'll be brought into our main console. So this is a great tool because you don't get any surprises. If you accurately put in what you want to provision, then the prices and the charges that you can expect should be very accurate as well. But it really depends on how accurate your information is going in will determine how accurate your estimates are coming out. So once we're in the Google Cloud Platform, come up to Search Products and Resources and just type in Pricing Calculator. And you'll see under Documentation, the Google Cloud Platform Pricing Calculator. So let's go ahead and click that link. And we're brought into the Google Cloud Pricing Calculator. First thing you'll notice, our prices are up to date. So let's say we're going to create a LAMP stack. So Linux, Apache, MySQL, and PHP. We're going to use 2 instances and we're going to put a load balancer in front of them. So using the Google Cloud Pricing Calculator, I can determine how much this may cost a month. So I want 2 instances. What are these instances for? I'm just going to say LAMP stack. So here I can choose my operating system. So I want Linux. You get a free Debian, CentOS, CoreOS, Ubuntu, or other user-provided OS. And there's also paid ones as well. So I'm going to use the free Debian. The machine class is going to be regular. And the machine family, I'm going to choose general purpose. I don't need compute optimized or accelerated. So I'm going to use general purpose of an E2 type. My machine type is E2 standard, and I'm using it in US Central 1. I don't need a public IP in this case, so I'm going to add this to the estimate. You can see it comes up $97 a month. That's because I'm running it 24 hours a day, 7 days a week. So we've got our compute engine. Next thing we need is a load balancer to put in front of it. So we want a load balancer. We're going to have one forwarding rule. And our ingress data processed could be 10 gigs. And this is important because once you're estimating traffic, and that can be a bit difficult, that may be an area where you want to really make sure your estimate is correct. So my load balancer is going to cost me about $18.33 a month. So the next thing I want to look at is Cloud SQL, right? Because this is my LAMP stack. So I'm going to come up and I'm going to say I want 1 instance. This is for my LAMP stack. I want SQL Server 2017. It's a small application, so I'm going to take 2 virtual CPUs and 8 gigs of RAM. Not a high-end machine by any means. I'm going to leave it in the same location. Now, how much storage do I want to provision? So I'm going to provision 100 gigs of storage and 100 gigabytes of backup size. My committed usage, so if I wanted to bring my price down, I could commit to 1 year or 3 years. I'm not going to commit right now. And it's going to be running 24 hours a day, 7 days a week. So I'm going to add my database to my estimate. And now you can see we're getting up to about $621. So my SQL Server is going to cost me $500 a month. So now I got my compute instances, I've got my load balancer, and I've got my SQL Server. You should also kind of estimate for data transfer as well. So if we look at network egress, for example, maybe we're sending out 25 gigs of egress, premium tier to North America. So we got to add that to the estimate as well. So it's important to kind of get everybody on board to see how much bandwidth we are going to actually use so we can accurately estimate that. So my estimate now, I have a compute engine, I have my load balancing, I have my Cloud SQL for SQL Server, and I've got my internet egress. And I'm looking at about $624.50 a month. So I can email this estimate. I could save this estimate. I can go back and make changes to this estimate by clicking the Edit button, or I can remove resources by clicking the Delete button. So there's different options for data store, BigQuery, PubSub, Cloud Table, Cloud Translation, DNS. So whatever you want to use and incorporate, you can find it in the Google Cloud Pricing Calculator. So in this course, we've examined the Google Cloud Platform, the different services available by matching them to business needs. We did this by exploring how to align Google Cloud Platform services to business needs, signing up for Google Cloud Platform and navigating the GCP console, creating a billing account, establishing budgets, and setting billing exports. And we used the Google Cloud Platform Pricing Calculator and linked the billing account to a project. In our next course, we'll move on to learn about how to configure using the Google Cloud Shell. In this video, I'm going to demonstrate the use of the Google Cloud Shell. So Cloud Shell, it comes with Cloud SDK already installed. So we can run gcloud commands and we don't need to set anything else up. We can do it right from our browser, right? So we can run gcloud command line commands right away. So all we have to do is come up to our title bar on the right-hand side, and you'll see a button to activate the Cloud Shell. So let's go ahead and click Activate Cloud Shell, and you'll see it come up on the bottom, and it provisions your Google Cloud Shell machine, and then you're given a Cloud Shell terminal. From inside this terminal now, you'll see that our Cloud Platform project in this session is set to Sigma Smile 311516, which corresponds to our project up here. We can change a project to a different project using the gcloud config set project command. So now that we're in the Cloud Shell terminal, let's look at a couple of commands that we can run. So do we want to fire up an instance using the gcloud command? We can do just that. So we're going to create a compute instance with the generated gcloud command. And I'm going to show you this because it'll give you a way to kind of create these scripts that you can use down the road and over and over and over. So the first thing we want to do is come up to our navigational menu, click it, and come down to Compute. And then under Compute Engine, we want to select VM instances. So I'm going to create a VM instance. Once it fires up, I can put in what I want. So I come up to the top and I click Create Instance. And now I'm given all the options that I'm going to set. So I'm going to leave the name as Instance 2. I'm going to leave it in US Central 1. It's going to be a general purpose E2. And then I'm going to come down. I'm going to leave everything the same. Right? Our goal here is just to get the script that we can run in the command line. So if I come all the way down below the Create button, you'll see equivalent REST or command line. So go ahead and click the command line. And now you see the Google Cloud command line with the parameters we selected. So I can just copy this, or I can just click to run it in the Cloud Shell. And the reason this is good is that we can now start to create some resources and get the gcloud command line commands for that. So we don't have to do it inside the console anymore. We can do it right in the shell if we wish. So I'm going to click Run in Cloud Shell. You'll see the command then populate in the shell itself. And I'll just go ahead and click Enter. And the command is now running in the shell and it's creating that instance for me. So it may take a few minutes for the instance to be created. In the meantime, I can cancel this create up here and I'll just come back to my VM instances. And as I did that, you can see the instance has been created. It gives you the name, the zone, the machine type, the internal IP, and the external IP. So now, if I want to look at my instances and how many are running, now all I need to do is refresh my instances page, and now you'll see I have 2 instances running. So if I come back down in the shell again, I can still run a few more commands. I can run stuff like gcloud compute instances list to get a list of all my instances. Right, so whatever I can do up in the console, I can do mostly in the shell itself. All right, so once you're done with the shell, we can close it. We can also open it in a new window if we wish to have it in a full window without being part of the screen. From here, we also have some terminal settings. So any terminal preferences, or we can change our colors, our text sizes, our fonts. And we can also send key combinations through the browser itself. So once I want to go back, I can close the terminal and I go back to my regular portal page. And now you'll see that there is no terminal window anymore because I transferred it to the new screen. But if I want to bring it back up again, I just click Activate Cloud Shell, it provisioning again, and it brings me back to the exact same screen I had before. So from here, I can continue to put in any commands or keep provisioning resources using the shell. So I hope this video showed you how to get into the Google Cloud Shell, how to run some commands, how to create some instances, and just do some cosmetic changes like opening it in a new window, changing colors, and changing keyboard inputs. In this video, I'm going to demonstrate how to install the Google Cloud SDK. So the Google Cloud SDK is great that you can orchestrate your virtual machines from your command line. It's available in a lot of different languages like Node.js, .NET, PHP, Python, and you can manage all your networks, your compute engines, all your storage right from the command line tool or your application. So this software developer kit is for you if you're creating stuff on your local machine or if you want to interact with the cloud services without being in the console itself. So we want to go to the Google Cloud SDK webpage. That's located at cloud.google.com/SDK. So once we're here, you'll see a big blue button that says Get Started. So let's go ahead and click the Get Started button. And we want to install the SDK. And Google Cloud makes it very simple to get started with the SDK and downloading it and installing it. So you'll come across a headline that says Installing the latest Cloud SDK version. And at the time of this recording, it was version 339.0.0. You can scroll down and then you can find exactly what version you want. So for Linux, it tells you exactly how to download it. And it gives you the Linux 64-bit and the 32 bits. Or it gives you commands that you can download it from the command line and run it. Debian Ubuntu. So if you are using Debian or Ubuntu, you have instructions here and commands on how to bring that in and install it. Same thing with Red Hat, Fedora, and CentOS. Complete installation instructions. Mac OS and Windows. So for our demonstration, I'm going to use Windows. And there's two ways. We can download the SDK installer, or we can open a PowerShell terminal and run these PowerShell commands. So if this command is run, new object, net.web client, download file, and then we go to the download and download the SDK, save it to our temp, and then just run it and install it. So for our video today, I'm going to do just that. So I'm going to copy this code sample. I'm going to come down and I'm going to open up PowerShell. So you'll notice now that PowerShell is open. I ran it as administrator. This is important. We need administrative rights. So I'm going to paste in the command that I copied from the web page, and almost instantly you get your Google Cloud SDK set up. So I'm going to go ahead and click Next. Here's the agreement, so you can read the agreement. If you agree, go ahead and click I agree. Now we have to select the install type. So for a single user or for all users, I'm going to go all users. I'm going to leave the destination folder, the default settings. So I click Next. And now you're asked what components do you want to install. So Cloud SDK, core libraries, and tools automatically comes installed. But you can get the bundled Python. So if Python's not installed, it'll install it for you. So I'm going to leave that checked. And Cloud Tools for PowerShell. So that's a set of commandlets for PowerShell that you can interact with Google Cloud with. I'm going to leave that on as well. And there's also beta components for Google Cloud Tools. So some commands that are in beta mode for testing. I'm going to leave that on check. And I'm go ahead and click Install. It downloads the Google Cloud SDK core. You can click Show Details if you want to see the output folder and exactly what's happening during this install. So it downloaded the application. It's extracting the application. Now you can see it created a batch file. It's installing the components. Now I get my welcome message as it's getting near the end of the installation. So not much longer now. Installation should be complete. As you can see, when it's done, it lets you know the update is done. You can go ahead and click Next because the Google Cloud SDK has been installed. When it's done, you'll be given options to create a Start menu shortcut, to create a desktop shortcut, to start the Google Cloud SDK shell, and to run the Google Cloud init to configure the Google Cloud SDK. Right now, I'm going to uncheck these, and I'm just going to finish this installation. And stay tuned because in the next few videos, I'm going to show you how to enable the GCP SDK in Visual Studio and to set the default project. and how to do the same with the Google Cloud CLI and to set the default project in the Google Cloud CLI. So I hope this video showed you using PowerShell how to install the Google Cloud SDK and some of the advantages it provides you as a developer or an administrator of a Google Cloud environment. In this video, I'm going to show you how to use cloud tools for Visual Studio. So Visual Studio is the IDE for Windows and .NET developers, and Cloud Tools for Visual Studio is a plugin to build and test Windows and .NET applications locally, then deploy them to the Google Cloud Platform directly from Visual Studio. So in this video, we're going to install Cloud Tools for Visual Studio and authenticate it to our Google Cloud Platform and set our default project. So I'm assuming you already have Visual Studio installed. If not, pause this video and go install Visual Studio. And if you do have Visual Studio installed, I want you to go to cloud.google.com/visual-studio. So from here is where we're going to download our plugin. So you'll see a big blue button that says download. Let's go ahead and click download to download the Google Cloud Tools for Visual Studio. So you'll get a marketplace pop up. Go ahead and click the green download button to download the Google Cloud Tools for Visual Studio. You'll get a download. I'm going to go ahead and save it. It's called Google Cloud Extension.vsix, so it's a Visual Studio extension. Go ahead and click save, and you'll see the file get saved down in your download spot. So once it's completely saved, you can go ahead and double click it. So you get your Visual Studio installer fire up. It begins to initialize. It asks you, do you want to install Google Cloud Tools for Visual Studio? And where do you want to install the extension? I want to install it Visual Studio Community 2019. And you do need Git for Windows installed on your machine as well. So once I know I have Visual Studio 2019 and Git, I'm going to go ahead and click install. And it's going to install the Google Cloud Tools for Visual Studio. So once it's complete, you'll see the green checkbox. Visual Studio Community 2019 has had the Google Cloud Tools for Visual Studio installed. I can go ahead and click close now. And now I can come down to my start menu and I want to open Visual Studio 2019. Once this fires up, I can go into a workspace. And the first thing we need to do is authenticate to the Google Cloud Platform. So even before we can use any cloud tools, we've got to authenticate. So up under Tools, you'll see Google Cloud Tools now. This is our Google Cloud Tools that we're going to interact with our cloud resources. First thing we need to do is come over to Manage Accounts. It asks you if you want to help improve Google Cloud Tools by reporting usage statistics. It's going to ask you to choose your account. So I'm going to choose my account. And I'm going to hit close. If you wanted to add a new account, you could go Google Cloud Tools, Manage Accounts, and click Add Account. And you would get a Google sign-in where you can click a new account. And then you can use that account to log into Visual Studio and use the Google Cloud Tools. I'm going to leave my current account on mine and go ahead and click close. So at this point now we're authenticated. Now we're ready to use the Google Cloud Explorer to manage our resources. So let's go to Tools again. Let's go to Google Cloud Tools and show Google Cloud Explorer. This opens up a new window. And at the top, here's where we can choose our project. So I can select the project here. I can work on my web app, and you'll see it change over here. Or I can change a different project and call it my first project. And now you'll see it change over there. So in this case now, we have set up the Google Cloud Explorer, and we can do things like create and manage Google Compute Engine instances. So if I wanted to, I can go under Google Compute Engine. I can see the instances that I have, instance 1 and instance 2. I can configure firewall options. I can stop the instance from here. I can open it on the console. And I can do the exact same thing with instance 2. I can also create a new instance. So a new ASP.NET instance or just a new instance. I can also do things with the Google App Engine here as well. So I'd have to enable the admin API, but I can do that as well. So I hope this video showed you how to download the Cloud Tools for Visual Studio, how to install Cloud Tools for Visual Studio and authenticate with Google Cloud, and then use the Google Cloud Explorer to view your resources and make changes to your resources in the Google Cloud from Visual Studio 2019. In this video, I'm going to show you how to use the gcloud CLI and how to set the default project. So the Google Cloud CLI or the gcloud CLI is installed when you install the Google Cloud SDK. I have a link on my desktop to the Google Cloud SDK shell. You may have one on your desktop. It may be on your start menu. Depends where you put an icon when you install the SDK itself. So let's double click the Cloud Shell SDK and it brings us in a new shell window. You can see that we're working out of the program files Google Cloud SDK directory. And right out of the bat, it shows you if you want to run the gcloud-h command, it'll show you some list of available commands. So -h being help. So when I run that command, I get a list of commands that I can use. Things like billing, source, schedule, config. Okay, so I'm going to clear the screen and now I have a new command window. So the first thing I want to do is list all my projects. So if I do gcloud config list project and click enter, I get a list of the project that is now my default project. So right now my default project in the gcloud CLI is my web app -312916. But what if I wanted to change my default project? I can run the gcloud projects list command to get a list of all my projects in my account. And I see I have two. So I have my web app and I have Sigma Smile. So I'm going to go ahead and change my default project in the command line from my web app to Sigma Smile. So I can do this by just typing in gcloud config set project, and then I have to specify the project ID, not the name, but the project ID. So I type in Sigma Smile 311516 and I click enter, and you can see it updated the property core/project. So there's a couple other things we can do in the Google Cloud CLI. One of these things can get a list of all our zones. So if I do gcloud compute zones list, I'm going to get a list of all the compute zones where I can provision compute resources. So if I want to change mine, I can type in gcloud config set compute zone. So as you can see, we're going to set our compute zone now to something different. So I can say US West 2B. And I go ahead and click enter. And now it updates the property of the compute zone. So everything in this project now will be launched in US West 2B. We can do another couple things, like if we want to disable prompting for scripting, we don't want to be prompted when our scripts run, we can run gcloud config set disable _ prompts true, and that'll turn off the prompts for us. Now I'll clear my screen and I'm brought back to a clear screen again. And I can do things like, say if I want to set a proxy, I can do gcloud config set proxy type HTTP, and you'll see an updated property of proxy type. So that's just some of the things we can do when we get in and start to initialize our Google Cloud CLI, right? Things like setting a default project, turning off prompts, setting a zone for your compute instances, and setting up proxies. So I hope this video showed you that, and now you can get into the gcloud CLI, do all these things, and really get started with the SDK and the command line and start building in Google Cloud. In this video, I'm going to show you how to enable Cloud Tools for PowerShell, authenticate with the Cloud SDK, and run PowerShell commandlets. So the first thing we need to do is open up a Windows PowerShell terminal and make sure we're running as administrator because we're going to need those administrator rights. So the first thing we need to do after that is run the commandlet install module and then say Google Cloud because we want to install the Google Cloud module. So we use install-module Google Cloud. Go ahead and click enter. The script is running. Once it's complete, I'll get my prompt back. At this point now, I should have the Google Cloud module installed. But first, I need to authenticate with the Cloud SDK because the Cloud Tools for PowerShell uses our credentials that are stored in the Cloud SDK. So to use these commandlets, we first got to log in using the SDK. So I'm going to open up a command prompt window, and I'm going to type in gcloud init. So it gives me three options. I can reinitialize this configuration, I can create a new one, or I can switch to and reinitialize another configuration. I'm going to reinitialize this configuration. It runs through some diagnostic checks, make sure everything is fine. Then it asks me what account. So here's my authentication. I want to use richspencer@gmail.com. If I wanted to use a different one, I could just click 2 and I'll be prompted with a new browser window and I'd have to choose a new Gmail account. I'm going to go ahead and click 1 for richspencer@gmail.com and I hit enter and I get logged in. Next, it asks me what cloud projects do I want to use. So I can see all the cloud projects I have. In this case, I'm going to choose 2 for Sigma Smile. Hit enter. Then it asks me, do I want to configure a default compute region and zone? I'm going to go ahead and click no and exit out of the command prompt. I've authenticated at this point. So now I'm going to run some commandlets. So the first thing I can run would be get GCE instance. And once I run that get GCE instance commandlet, it brings me back both of my instances. So instance 1, instance 2 shows you the CPU platform, the machine type, the zone, and the time created. I can also do configurations here as well. So if I want to create an instance, I can use commandlets like new GCE instance, right? Or if I come back from instance and I just have new-GCE and I hit tab button, I can see all the options available to me. So new GCE attached disk, new GCE firewall, instance config, right? So this follows the PowerShell commandlets that always have been, right? Verb now. We're going to get instances, or we're going to set instances, or new network. So I hope this video showed you how to install and use the cloud tools for PowerShell, how to authenticate, and how to run some simple PowerShell commandlets inside your Google Cloud environment. Now let's discuss some of the Cloud SQL features. So if you're using MySQL or PostgreSQL or SQL Server and you want a cloud-based alternative for them, Google Cloud SQL is worth exploring for you. Google Cloud SQL is a fully managed relational database that is designed to help you set up, maintain, and administer your MySQL, Postgres, or SQL Server databases in the Google Cloud platform. This service ensures your relational databases are reliable, scalable, and secure in the cloud. So what are some features for Cloud SQL for MySQL? First of all, you get MySQL Community Edition databases, Cloud SQL instances. It comes with Cloud SQL instances that support MySQL 8.0, 5.7, and 5.6. They also provide 624 gigabytes of RAM and 30 terabytes of data storage. You get data encryption, so customer data encrypted on Google's internal network. There's support for external connections with the Cloud SQL authentication proxy, and you can also use SSL and TLS protocol. There's support for private IP addresses. You can make use of data replication between multiple zones, and then you can implement automatic failover. You can import and export databases using MySQL dump, or you can use CSV files. And you can take advantage of the MySQL wire protocol and standard MySQL connectors. And you always have on-demand and automated backups and point-in-time recovery. And finally, instance cloning. So there's support to be able to clone your instances as well. And this is great for high availability and ease of deployment. So Cloud SQL runs MySQL with a specific set of options. So there's some options that may impact you. One of these are the skip name resolve option. So this flag will impact how host names are resolved for client connections. So the skip name resolve directive lets MySQL avoid DNS lookup responses. And this way, your MySQL server will only use IP addresses and not host names. The log bin flag reports whether binary logging is enabled. So if the log bin option is used, then the value of this variable is on, otherwise it's off. And the MySQL 8.0 authentication flag. So MySQL 8.0 for Cloud SQL uses the MySQL native password as the default authentication plugin for any new users. So the MySQL native password plugin is the default for MySQL 5.6 and 5.7. Let's take a look at Cloud SQL for Postgres. So this gives you a fully managed Postgres SQL database in the cloud. You get that same customer data encrypted on Google's internal networks. You get the same data replication that you're used to between multiple zones. And again, you can implement this for automatic failover. You get support for the Postgres client server protocol and standard Postgres SQL connectors, automatic and on-demand backups, and you also get instance cloning with Postgres SQL as well. Connect Cloud SQL for Postgres SQL instances. So you can connect to a Cloud SQL instance for Postgres from a PSQL client, external applications. If you're using App Engine applications, you can connect to Postgres from these App Engine applications. Any applications running on Cloud Functions, any applications that are running in Cloud Run, and applications running on the Kubernetes engine and the Compute engine. You can also use third-party tools to connect to your Postgres instance in the cloud as well. Now let's look at Cloud SQL for SQL Server. So we've got fully managed SQL Server databases in the cloud with custom machine types of up to 624 gigabytes of RAM and 96 CPUs. You get data encryption, so we can encrypt our data all over Google's internal networks and in the database tables, in the temporary files, and even in our backups. We have secure external connections. We can use SSL or TLS, or we can use the Cloud SQL authentication proxy. We have the option to import and export our databases. We can import using BAC files and SQL files. And we can also export our databases using the BAK files. We have on-demand and automated backups, and we can also do instance cloning with SQL Server as well. So if we want to connect to the Cloud SQL instance for SQL Server, we have a few options we can use. So we can use the SQL Server Management Studio, we can use a client, or we can use the SQL CMD command line utility. In this video, I'm going to show you how to use Google BigQuery, how to load data and export data. So BigQuery is Google Cloud's fully managed petabyte scale, cost-effective data warehouse, and you can run your analytics on huge amounts of data in real time. There's no infrastructure for you to set up, so you can just focus on finding meaningful insights in your data using SQL and taking advantage of the flexible pricing models that it offers. So once we're in the Google Cloud Platform, we want to come up and in the search bar, we can type in BigQuery. So I'll go ahead and I'll type in BigQuery, and you'll see a product and page, and it says BigQuery. So let's go ahead and click BigQuery, and we'll be brought into the BigQuery console page. So you can see as soon as you're brought in, you've got some pin projects. I've got a few pin projects. You may not if this is your first time in there. So what we want to really look at first is to somehow get your data in the pin projects. So let's click Add Data, and you'll see Pin a Project. So if you go over and click Search for Project, you'll find your projects, and you can just click whatever project that you want to bring in. So I'm going to click My Web App, and now you'll see my web app is pinned. So all my projects are now pinned into the BigQuery Explorer. So we want to add some data or load some data, and we kind of got two ways that we can do this. So let's come up and click the Add Data button, and you can explore public data sets, or you can explore external data sources. So if I wanted to bring in data from my SQL Server and I had vast amounts of data in my SQL Server, I can click External Data Source, and then I'm brought over to a page where I specify my connection and give a connection to my SQL database. That way, I create a connection, and now BigQuery is connected to my SQL database, and I can bring in the data and I can run all my queries on that data. Another good feature is the ability to add data from a public data set. So if I click Explore Public Data Sets, and this is a great way to get your hands wet in the BigQuery console itself. So click Explore Public Data Sets. Once it opens up, you'll be brought to a page, and you can see all kinds of data sets that you can use. So it could be advertising, analytics, big data, right? Databases, education, economics is here as well. You can go into healthcare, maps, machine learning, right? So let's take a look at climate. So I'm going to click the climate data sets, and I can see all kinds of data sets that I can use. And again, it's great if you need that kind of data for your projects, or you just want to get some hands-on experience with BigQuery. So I'm going to click Cloud to Ground Lightning Strike data. This is the aggregated data of all cloud to ground lightning strikes in the United States. So once I click that data set, it'll load up that data set console. It'll give me information. So aggregated lightning strike data from 87 to 2018. Gives me an overview of the data. And there's also some samples. So there's sample queries that I can run that are already given to me with this data set. So which US zip codes see the most lightning strikes? What day in the year 2000 saw the most US lightning strikes? So I'm going to scroll back up, and I'm going to click View Data Set. And you'll see it brings that data set and loads it right into BigQuery for me. You can see it's here. It's BigQuery-public data, NOAA lightning. And now at this point, I can start to query my data. So I can click Compose New Query. You'll see a query editor come up. And once the query editor is up, I can just come in here and I can paste in a SQL query. So I'm just doing a select the zip code, city, state, and the number of strikes from the BigQuery public data utility US zip code area dataset and the NOAA lightning 2018 dataset. So if I go ahead and click Run, you'll see the query is pending up on the side here. All my results are down on the bottom. So I can see my results. I can see how many times Canton, Ohio has been hit by lightning, how many North Houston, Texas has been hit by lightning. This is a big data set, so I limited it to 100 rows. So once I'm happy with this, whether it's demo data or my data or public data, I can explore it with Data Studio, or I can save the results. So I can save it to Google Drive on a CSV. I can save it locally as a CSV. I can save it as a JSON, either on Google Drive or a local file, or I can save it as a BigQuery table or Google Sheets, or copy up to 16,000 rows to the clipboard. So I'm going to export it as a CSV, a local file. I click Save. I get my results, and I just click Save and save it to the local file. So that's just one example of what you can do with BigQuery and public data. You could do the exact same thing if you brought your data over from your own SQL server somewhere. So I hope this video showed you how to get into BigQuery, start playing around with some of the public data or import your own data, and really start to analyze your data and make some crucial decisions for your organization. In this video, we're going to talk about Google Cloud Spanner. So Google Cloud Spanner is a fully managed relational database in the cloud. It has your schemas, SQL queries, and ACID transaction, and is ready to scale globally. You get automatic sharding. So it'll optimize your performance and automatically shard the data based on the request load and the size of the data. So you don't have to spend a bunch of time scaling your databases. You just have to worry about operations of your business. You get strong transactional consistency. So it's built for external, strong global transactional consistency, regional and multi-regional configurations. So no matter where your users are scattered all over the globe, Cloud Spanner can read and write up-to-date, strongly consistent data all over the world. And when you're running in a multi-region instance, your database can survive a regional failure and has 99.999% availability. You get a Cloud Spanner online schema, so you can make changes with no downtime. So if you're adding a column or adding an index, you can do all that without having to take your database down. You get the security you're always accustomed to with Google, because Cloud Spanner is built on Google's dedicated network, which provides you with enhanced security. You get your backup and restore. So you can do on-demand backup and restore for all your data protection needs. And it's available in multiple languages. So C#, Go, Java, Node.js are just some of the languages that you can use in Google Cloud Spanner. So what are some Cloud Spanner best practices? So first of all, when we talk about bulk loading, right, we need some ways to really implement bulk loading in the best practices. So you got several options for loading data in bulk. First is the insert rows. So you can insert rows using data manipulation language. You can insert rows using mutations through client library. You can also use the data flow connector. So if you're importing data using the data flow connector, you want to make sure that you check with the data flow best practices as well. And you can also import a database. So you can import a database using an AVRO file. And if you're importing data from AVRO files, again, you should also reference the best practices for implementing and importing databases using the AVRO files. Some bulk loading best practices. So first thing we want to do is ensure that we avoid pushback. So if we send Cloud Spanner more transactions than it can handle, it will start aborting transactions, and this is called pushback. So a best practice for write-only transactions, we want Cloud Spanner to automatically retry the transaction. In those cases, the pushback will then show up as high latency. So during heavy loads, pushback can last up to a minute. During severely heavy loads, it can last up to a couple minutes. So to avoid pushback, you want to make sure that you throttle your write requests and keep your CPU within reasonable limits. You only want to commit between 1 meg and 5 megs of mutation at a time, because every time we write to Cloud Spanner, there is some overhead. So we want to maximize our throughput. So a good technique is for each commit to mutate hundreds of rows. When writing relatively large rows, a commit size of 1 meg to 5 megs usually provide the best performance. You want to take advantage of secondary indexes. So if your database has a secondary index, you have to choose between adding the indexes to the database schema before or after loading the table data. Adding the index before data allows the schema change to complete immediately. However, adding the index after loading the data means each write is efficient. So however you do the schema change, be mindful that each index backfill can take a long time. So as a rule of thumb, if your database has less than 40 indexes, add them after you load the data. If they have more than 40 indexes, you want to do that before you load the data. And finally, you want to test and measure throughput. It's hard to predict traffic, it's hard to predict throughput, but if you test your bulk loading strategy before running that final load, you'll have a good idea of the throughput that you're going to use and the resources that you're going to need. If you go about using the data manipulation language, there are also some best practices for data manipulation language as well. Some of these best practices are to use a where clause to reduce the scope of locks. So you execute these DML statements inside read-write transactions. When Cloud Spanner reads that data, it acquires shared read locks on limited portion of the row ranges that you read. Therefore, it acquires these locks only on the columns you access. So if you use where clauses, you can reduce the scope of these locks. Shared read locks. You can use shared read locks on columns you access. And the DML statements and mutations shouldn't be used in the same transaction. So be mindful of that as well, because that can have some effect on your performance. Some DML best practices. So you want to use the pending commit timestamp function to write commit timestamps. You want to use partition DML and the date and timestamp functions. So partition DML will use one or more transactions that might run and commit at different times. So if you use the date or timestamp functions, the modified rows might contain different values. And finally, use batch DML to send multiple DMLs in one single request. So how do we design our schema, and what are some of the schema design best practices? First and foremost, you want to choose a primary key to prevent hotspots. And be careful when choosing the primary key. Don't create hotspots in your database. Right? A hotspot is a column whose value is constantly increasing as the first key part, and that's due to all the inserts occurring. That's not good because Cloud Spanner will divide data amongst servers by key ranges, and as a result, all of your inserts are going to be on one single server. You want to swap the order of the keys, so that'll allow you to spread writes over the key space, and hash key and spread writes. So another common technique for spreading load is to create a column that contains the hash of the actual unique key, then use that hash column as the primary key. That'll help you avoid hotspots because new rows are then going to be spread amongst different servers. Some more best practices. Use a universally unique identifier. So you can use a UUID as the primary key. Bit reversal sequential values. So when you generate unique primary keys that are in numerical order, the high order of bits of subsequent numbers should be distributed roughly equally over the entire number space. Use a descending order for timestamp-based keys. So if you've got any table for your history that's keyed by a timestamp, you want to go in descending order, and you want to use an interleaved index. So similar to previous primary keys, it's a bad idea to create non-interleaved indexes on columns whose values are always increasing or decreasing, even if they aren't primary key columns. Now let's look at SQL best practices. So as we describe in the query execution plans, Cloud Spanner's SQL compiler transforms a SQL statement into a query execution plan, which is then used to obtain the results of a query. And that's the best practice that you want to implement. You want to use query parameters to speed up the frequently executed queries, and these will give you pre-optimized plans and very simplified query composition. If your application needs more security, and these query parameters give you security because it protects you from various SQL injection attacks. And this protection is really good for queries that you construct from user input. Some more SQL best practices. Use secondary indexes to speed up your common queries. Write efficient queries for range key lookup. So common use of an SQL query is to read multiple rows based on a list of known keys. There are best practices for writing efficient queries when you're dealing with joins as well. You want to avoid large reads. These read-write transactions can allow a sequence of 0 or more reads or SQL queries and will include a set of mutations before a call to commit. So in order to maintain the consistency of your data, Cloud Spanner is going to acquire locks when reading and writing rows in your table and indexes. You want to use the order by query to order your SQL results and use starts with instead of like to speed up your parameterized SQL queries. Cloud Spanner don't evaluate like patterns until execution. In this video, I want to talk about Cloud Bigtable and some of the key advantages it'll offer you. So Cloud Bigtable is a sparsely populated table, and it can scale to billions of rows and thousands of columns. You can even store up to petabytes of data. So Cloud Bigtable is exposed to applications through client library. As a result, you can easily integrate it into your open source big data software like Apache. Some of the big key advantages of Cloud Bigtable over a self-managed HBase installation would be the incredible scalability. So Cloud Bigtable will scale in proportion to the number of machines in your cluster. If you were running a self-managed HBase installation, a design bottleneck could limit the performance after a certain threshold is reached, but Cloud Bigtable does not have that bottleneck. It offers simple administration, so upgrades and restarts are all transparent. You don't even see it, and it'll automatically maintain your high data availability. It'll replicate your data just by simply adding a second cluster to your instance. So that's not something you could easily do in an HBase installation that you self-manage. And it offers cluster resizing without downtime. So you can increase your Bigtable cluster for a few hours to handle big load and then scale it back down. And all that comes without downtime. So what would we use Cloud Bigtable for? Cloud Bigtable is built for applications that need the high throughput and scalability to store key value data. The key being here is that this key value data is not larger than 10 megabytes. This is great for financial data like transaction histories, currency rates, graph data, so how users are connected to one another, Internet of Things data, so any sensor data that we may have coming in, great to store it in Cloud Bigtable. Marketing data, so our application can track purchase histories. We can store that as well. And time series data. So all this is available to us and is great for Cloud Bigtable. So the Cloud Bigtable storage model. Cloud Bigtable stores data in scalable tables, and they're all sorted by a key value map. The table is composed of rows and columns, and each individual values for each row. And each row is indexed by a single row key, and columns that are related to one another are grouped in a column family. Each column is identified by a combination of the column family and the column qualifier, and that's a unique name within the column family. The Cloud Bigtable architecture. So how do we implement the Cloud Bigtable on what architecture? So it's made up of nodes. Each node in a cluster handles a subset of the requests. Each time you add nodes to a cluster, you increase the simultaneous requests that the cluster can handle, so therefore you're scaling up. A Cloud Bigtable is sharded into a block of contiguous rows called tablets, and that'll allow us to balance our workload of our queries. So if you compare this back to HBase, these are similar to HBase regions. And tablets are stored on Colossus, and that's the Google Cloud Platform file system. In Colossus, they're stored in an SST table. So these type of tables provide a persistent, ordered, immutable map from keys to values. So each tablet is associated with a specific Cloud Bigtable node. And in addition to the SST table files, all writes are also stored in Colossus's shared log, and that'll give you increased durability. right? We've got that data replication. Now let's take a look at Cloud Bigtable load balancing. So each Cloud Bigtable zone is managed by one primary process, and that balances the workload and the data volume within its cluster. So it's in control over the workload and data and giving that out, distributing it amongst the cluster. This process will split busier and larger tablets in half and will merge less accessed and smaller tablets together. As a result, this will redistribute them between nodes as possible. And if a certain tablet gets a spike of traffic, Cloud Bigtable will split the tablet in two, move one of the new tablets to another node, and then Cloud Bigtable will manage all of this splitting and merging and rebalancing automatically, and you don't have to do it. Cloud Bigtable memory and disk usage. So some things that we need to take a look at that affect the memory and disk usage of our instance. One of these are unused columns. They do not take up actual space. So columns that are not used don't take up the space in the row. Each row is just a collection of key value entries, where the key is a combination of the column family, column qualifier, and the timestamp. So don't be too worried about unused columns. Column qualifiers do take up space in a row because each column qualifier is used in a row that's stored in that row. Compactions, so Cloud Bigtable will from time to time rewrite and reorganize your deleted entries. This is known as compaction. There's no configuration settings for this. It's done automatically. Mutations and deletions, so any changes, mutations, to a row will take up extra storage space. When Cloud Table compacts a table, it'll remove values that are no longer needed. So if you update the value in a cell, both the original value and the new value will be stored. So you can see how this can take up some extra storage space along the way. And data compression. So Bigtable will compress your data automatically, and you can't configure the compression settings for your table, but you should know that random data can't be compressed as efficiently as patterned data. Compression works best if the identical values are near each other, and you should compress values larger than 1 megabyte before storing them in Bigtable. So when you use Cloud Bigtable, your data is stored on Colossus, right? That's Google's cloud platform file system. You don't need to run any HDFS cluster or any other file system. You can take advantage of Colossus. Some of the main advantages of this is the data durability, right? Because our instances will use replication, Cloud Bigtable will maintain one copy of our data in Colossus for each cluster in the instance, and each copy is located in a different zone or region, so that gives us much higher durability. We have a fantastic consistency model. Single cluster Cloud Bigtable instances have strong consistency. By default, instances that have more than one cluster provide eventual consistency, but for some use cases, you can configure them to provide read your writes consistency or strong consistency. Security. So access to your Cloud Bigtables is controlled using IAM roles, and that's done by you that you assign to your users. And you always get your backups. So Cloud Bigtable backups lets us save a copy of the table schema and data, then restore from that backup to a new table if we ever need to. So Cloud Bigtable is a fantastic solution if you really need high throughput, high scalable key value storage. Now let's discuss Dataproc. So what is Dataproc? Dataproc is a managed Spark and Hadoop service and allow you to take advantage of open source data tools for processing, querying, streaming, and machine learning. So Dataproc helps you create clusters. You can manage these clusters and you can turn them off when you're not using them. So it's great for our big data applications and big data workloads. Some advantages of Dataproc. So if you are running this on premise, it's going to be a lot more expensive than it would be in the cloud. And that's one of the unique advantages of Dataproc. We also have the fact that it's integrated. So Dataproc is built in with a lot of the other Google Cloud Platform services like BigQuery, Cloud Bigtable. So you have everything at your hands to be able to do big data workloads and transactions. It's low cost, so it's priced at only 1 cent per virtual CPU, and that's an economy of scale that you can't replicate on premise. It's managed, so the Spark and Hadoop clusters will run without any administrator or special software. So you don't have to worry about that. It's all done for you. And when you're done with the cluster, you can just turn it off, and you don't have to spend any money on idling hardware. It's simple and familiar, right? It looks like a lot of the other services that you used in the Google Cloud Platform, and it's super fast. It's using the Google internal network, and it's very fast and efficient to get your big data workloads complete. So what component advantages do Dataproc offer you? So when you create a cluster, as standard Apache Hadoop ecosystem components are automatically installed. You can install additional components or optional components when you create your cluster. Adding these additional components is similar to adding components through the use of initialization actions, but you have much faster cluster startup times. You have tested compatibility with specific Dataproc versions, a use of cluster parameters instead of initialization action script, and you get optional components for integration. So if you use Anaconda and Zeppelin and they're installed on the cluster, Zeppelin will automatically make use of Anaconda's Python interpreter and libraries. So what makes up Dataproc clusters? Dataproc clusters are just built on the compute instances. Machine types are virtualized hardware resources, and they're available to every instance. So Compute Engine offers you both predefined machine images that are already created by other people and are used for a lot of Dataproc, big data, analytics, transactions, and workloads, these type of things. Or you can create a custom machine image for your master or worker nodes, but you may find something predefined that will fit your needs beforehand. The Dataproc Hadoop data storage. So Dataproc integrates with the Apache Hadoop and the Hadoop distributed file system with cloud storage. So Dataproc will automatically install the HDFS compatible connector, and it'll enable the use of cloud storage. So you don't have to have any additional storage. If you already have cloud storage resources, you can bring those in. And you also have VM disks. So by default, when there's no local solid-state drives, HDFS data and intermediate shuffle data is stored on the VM boot disks. If you're using local SSDs, HDFS and intermediate shuffle data is stored on those SSDs. VM boot disks are deleted when the cluster is deleted, so something to remember. Some Dataproc permissions. So how do we deal with Dataproc permissions, security, IAM, all those type of things? So identity and access management allow us to control users and group access to our project's resources. Right? So we want to control permissions to clusters themselves, the jobs that are currently running or can be running, like who can create jobs, any of the operations, and our workflow template. So the Dataproc clusters create permission API will allow a user to create Dataproc clusters. You don't directly give users permission, but you grant them roles. Ideally, the role of least privilege, right? You want them just to have enough privileges to do their job. Now let's discuss the Google Cloud Marketplace. So what is the Google Cloud Marketplace? Google Cloud Marketplace allows you to easily deploy functional software packages, and you don't have to worry about manually configuring software, VM instances, storage, or network settings. It's already set up for you as a complete package, and you just deploy it. It can be free, it can be paid, but the thing is, you don't have to worry about any of the underlying configuration. Cloud Marketplace deployments. So you can select and deploy packages from the Cloud Marketplace page, and you can choose from many different products. as well as variations of the same products. So you can have different types of firewalls, for example, and it could be just variations of that firewall, different versions, different subscription types, right? You can ensure your product meets your needs. You can view reviews, you can look at the documentation, and you can align that with everything that you need. So you look at your details page and see, does this product have what I need? And should I deploy it? And then after choosing a package, you need to look at the default configurations. Will the default configurations work for you, or should you put in some custom configurations, which you can quickly and easily do? So how do we deploy in the Google Cloud Marketplace? So after you launch deployments from the Cloud Marketplace, you can use Google Cloud Tools. And using the Google Cloud Tools, you can view and modify and monitor your deployment. If you want to look at everything you deployed, you can come back to the Cloud Marketplace. You'll see a drop-down that shows all your previous deployments. And from here, you can update any service options directly from the Cloud Marketplace product page. If your deployment is running a VM instance, you can use Deployment Manager. It'll display in a tree view, and it'll show you all your Google Cloud resources that make up your deployment, as well as letting you SSH into your VM instance to manage the instance. And finally, cloud monitoring can be used to track your performance and availability of your applications. If you deploy your application and integrate it with cloud monitoring, these instances that are deployed with the product already include the monitoring agents that provide you data into your dashboards. So how do we manage, change, or cancel our billing for Cloud Marketplace? So before we begin, we should have a correct identity and access management roles or permissions for cloud billing. So if you're a billing administrator, you already have these permissions. If you have other billing administrators in your organization, you'll have to identify roles and apply them to their user accounts. Depending on the product, say Kubernetes app, for example, you may need to specify additional IAM roles for your users. All users of the Kubernetes app must have these IAM roles: viewer, editor, service account user, and service account key administrator. So these are roles that the users who will deploy the product need to have in Kubernetes. They also need to be able to create a service account. So that's used to report usage data. So depending on how you're rolling this out, you may need to grant additional IAM roles. So if you're deploying another Kubernetes application, or if you want to add additional roles to allow users to just be able to create service accounts and key administration, then you may have to grant additional IAM roles as well, depending on that product. So the cloud billing account. Cloud billing accounts can be linked to multiple projects. So you may have two projects that are linked to one billing account because they're somewhat tied together, or they're done by the same team, or they come out of the same budget. So a project can only have one cloud billing account, but a cloud billing account can be linked to multiple projects. If you want to change cloud billing accounts, you should always verify the new account purchased all the resources required, and it has all the APIs enabled that you need to run your application. Cloud Marketplace access control. So how do we set roles and permissions so that our administrators or people who need to be able to purchase and manage these commercial products can do so? So with IAM, we can manage the access control by defining the who and what access they have. So their identity and their role. We can do this via gcloud. So we can do it with the command line. We can also do this with the Cloud SDK and the Cloud Console. And these are our three main tools to be able to perform access control over the Cloud Marketplace and who has what permissions to be able to do what inside the marketplace. In this video, I'm going to demonstrate how to deploy a Google Cloud Marketplace solution. So as you know, Google Cloud lets you quickly deploy software packages that run on Google Cloud. So even if you're not familiar with how the compute engine runs or storage works, You can just start up these software packages without having to manually configure the software. You don't have to worry about the VMs, network settings, security. All this is done for you as a software package. So you can select and deploy software packages from the Cloud Marketplace page. So once you're in the console, up under Products and Services, we can just type in Marketplace. And you'll see a products page called Marketplace. It's also over here. If you come over to the navigational menu, it's your first option on the drop-down. So let's go ahead and click Marketplace. And you'll be brought right into the Marketplace console. Here's where you can see some of the solutions that we can deploy. So you can filter by free trial solutions. There's solutions that involve virtual machines. There's API services, Kubernetes applications, container images. There's data sets and operations. So if we type in operating systems, you'll see there's a Server 2016, there's a Red Hat Linux, right? These are all ready to go and can be deployed with just a couple clicks. You can also come down under price and you can filter by free trial. You can filter by straight up free. So if we got rid of the free trial filter, we can just click free and we can see there's 41 free operating systems here in the Marketplace. So if I come back to Marketplace and I want to look at a few more solutions, I'm going to come under free trial. So I'm going to click free trial solution and I'm going to look at what's here. So there's a Barracuda Cloud Gen Firewall solution that I can just deploy. There's Citrix solutions that I can deploy. But let's say I wanted to fire up an Nginx web server, but I want the Nginx premium version. There's a solution for that here as well. So I'll just keep scrolling down and I will find the Nginx Plus Basic that's deployed on a CentOS 7. So this is what I want to deploy. So I'm going to go ahead and click the Nginx Plus and I'm brought into a configuration screen. So you'll see it gives you load balancing, acceleration, and high availability for web apps. It's a 30-day trial. I can launch it. I can view past deployments. There's also an overview here. So it tells you what you're installing, what it provides. There's load balancing, there's reverse proxy, there's a web server and an API gateway. We can click under pricing and we can see the pricing. So right now we've got a free trial, but afterwards you're getting into roughly $311 a month once this trial runs out. So if you deploy this, make sure you undeploy it within the free tier range or you could get charged for it. There's also documentation here and some support documentation in terms of service. And then I come back up under overview. So as I scroll up, you can see it changing the tabs. And I'm going to go ahead and click launch. So it brings me into a new configuration window, gives me a deployment name, gives me my zone and a machine type. So from here, I can change my machine types if I wish. I'm going to leave it on the very small one. I check my boot disk. So I want a standard persistent disk at 20 gigabytes. And it shows me my networking interface. So I can come down here. I can change this if I wanted to. I'm going to click cancel and I'm going to deploy. So once I click deploy, you'll see it's being deployed and it gives you a full overview of everything that it is deploying and every step along the way. So we can expand these nodes and we can see exactly what's running. The instance is now being created. You see the instance has now been created and it's finally been deployed. Everything is done. You see your green check marks. Now they say, what's your suggested next steps? Assign a static external IP. So let's actually go into the instance itself. So we can click the Nginx Plus instance and you're brought into your instance. So here's where we need to make a couple changes so that this web solution will work. So if I scroll down, you'll see I want to be able to allow HTTP and HTTP traffic. So let's go ahead and click edit. Let's scroll down and we want to allow HTTP traffic and HTTPS traffic. We also want to edit our network interface. so that we have an external IP type. So I'm going to create the IP address. I'm just going to call it web app IP and click reserve. Now I'm reserving this new static IP address. That way it won't change and it will stay there forever for the lifetime of this deployment. So I'm going to go ahead and click done at this point. It should save my changes. And now you'll see that I am allowing HTTP traffic and I have an external IP. So I click save. It updates these settings to this instance. And when it's complete, we should see the green check mark up on the top, and we should get some buttons to be able to press back up on top. So right now it's still changing. As you can scroll down, you can see that the dots are still going on the save. So we just had to update the firewall rules and an IP. Once that changes, we should have a fully working web service that we deployed via the marketplace. Once it's saved, you can see the equivalent REST commands here. So let's come up. Let's take a look at the IP address. So let's copy the public IP address, open up a new tab, put it in our browser bar, and you can see we've got an Nginx Plus on the Google Cloud Platform. So we didn't provision any instances ourselves. We didn't set up the network ourselves or the load balancing, but we employed the Google Marketplace to fire up this full solution for us. So I hope this video showed you how to use the Google Marketplace, how to look around and find solutions that may fit your needs. So in this course, we've examined the Google Cloud Shell. We did this by exploring how to use the Google Cloud Shell and the gcloud CLI, cloud tools for PowerShell, and installing the Google Cloud SDK and enabling it in Visual Studio. We also took a look at Cloud SQL features, BigQuery, Cloud Spanner, Cloud Bigtable, and Dataproc, and we looked at the Cloud Marketplace and how to deploy it. In our next course, we'll move on to examine the Google Cloud Resource Manager. Let's start by discussing the Google Cloud Resource Manager. So the Google Cloud Resource Manager is going to be used to hierarchically manage resources by project, folder, and organization. So Google Cloud allows you to use resource containers such as organizations, folders, and projects, and as a result, you can then group and hierarchically organize other GCP resources. The Google Cloud Resource Manager is great for organizing resources. So resources that are organized in Google Cloud Resource Manager are organized hierarchically. Folders in a resource manager are for Google Cloud accounts with an organization node associated. So the organization is the root node in the hierarchy, and its children are lower level projects and folders. And these folders can contain projects or subsequently other folders. All resources are the children of projects, and each resource has exactly one parent. You can also manage your IAM across your organization. So create an organization that contains all of your projects and resources. This is great for simplicity of billing and tracking resource provisioning. And you can create folders to group projects by department or team or application or environment. So staging environment or a development environment or a production environment. Any change made in the policies for your organization and folders will apply across all the projects and resources. And it's also great for tracking projects, so you can programmatically create, manage, delete projects and folders that belong to your organization. And you have the added benefit of being able to delete or recover projects that you didn't mean to delete in the first place. Some features of the Google Cloud Resource Manager are asset inventory. So using the Google Cloud Asset Inventory, this is a fully managed inventory service. You can use this to gain visibility and monitor all of your Google Cloud Platform resources and policies. Cloud IAM policies. So create and manage IAM access control policies for your whole organization and all your projects. So you can control what access members of the project have. Right? You can make it so some can manage virtual machines, some can't, some can view logs, and so on. The level of granularity is incredible. You can create an organization. So the organization resource represents an organization such as your company. And this is the root node in the Google Cloud Platform hierarchy. And finally, organizational policies allow you to centrally control your organization's resources. You can restrict what configurations are across your entire cloud resource programmatically. So we can incorporate organizational policies into our organization. Some other features we should talk about are cloud folders. So you should use cloud folders to organize your resources and configure IAM policies so that they'll be inherited by all the child resources underneath that folder. You can access the resource manager in the Cloud Console and by using API access. You can create, update, and delete projects that belong to your organization, and you can gather a full list of all the projects that align under your organization. Organization Policy Service Benefits. So first, what is the Organization Policy Service? This gives you a centralized and programmatic control over your organization's cloud resources. So as the organization policy administrator, you will configure constraints across the entire hierarchy. Some of the benefits this gives us is centralized control. So you have a central area where you can apply and configure restrictions. You can define and establish guardrails for your development teams. This makes sure that they stay within compliance boundaries, and it helps project owners and their teams move quickly without worrying of breaking compliance because these policies are set for them. They can't break the compliance. Now let's take a look at some Google Cloud Resource Manager concepts. First is the organization policy. So this policy is set on a resource hierarchy node, and all descendants of that node inherit the organizational policy. So you can see how easy it is to push out policies throughout your full organization. Next, we have inheritance. So resources inherit the policies of the parent node. So whatever policy is set at the organization level is then inherited by all its children and all the folders and projects. And if a policy is set at the project level, it is inherited by all of its child resources. It's important to note that the most permissive parent policy always overrules a more restrictive child policy. So there's no way to explicitly remove permission for a lower level resource that's granted at a higher level in the resource hierarchy. So the effective policy of a resource is the union of the policy set on the resource and the policy inherited from its ancestors. We also have the ability for constraints. So organizational policies can use this constraint to limit resource sharing to a specific set of one or more Google Workspace domains. And violations. So if a violation occurs when a Google Cloud service acts or is in a state that it's counter to the policy created, Google Cloud services will enforce constraints to prevent these violations. Now let's discuss the resource hierarchy. So the purpose of the Google Cloud resource hierarchy is kind of twofold. It allows us to attach points and inheritance for access control and organization policies, and it gives us a hierarchy of ownership. So it'll bind the lifecycle of resource to its immediate parent. And if you think about it in the way it resembles a kind of a file system that we used to find in traditional operating systems, each resource has exactly one parent, and this hierarchical organization of resources enables you to set access control policies and configuration settings on a parent resource, and the policies and identity and access management settings are then inherited by the child resource. So this sounds a lot like a regular operating system file system. So at the lowest level, resources are what make up all Google Cloud services. Some of these resources could be cloud storage buckets, could be App Engine instances, could be pub subtopics, or compute engine VMs. But these resources are all organized hierarchically. Starting from the bottom of the hierarchy, projects are at first level. They contain other resources. All resources, except for organizations, only have one parent. The organization resource is the root node of the Google Cloud resource hierarchy, and all resources that belong to an organization are grouped under that organization node. So the organization resource, the organization represents an organization or a company, and it's the root node in the Google Cloud resource hierarchy. The organization resource is the hierarchical ancestor of project folders and resources, and the IAM access control policies that are applied to an organization will then apply through all of the resources in that organization. So as a regular user, Google Cloud users aren't required to have an organization resource. But if you want to use all the features of Resource Manager, you will want to have an organization. In order to have that organization, you need to set up a Google Workspace or a Google Cloud Identity account. When a user with a Google Workspace or Cloud Identity account creates a Google Cloud project, the organization that they set up in Workspace or Cloud Identity is automatically provisioned for them. So you need a domain name, and that's one of the main ways to set up a Cloud Identity. And then that way they can configure and provision your organization in Google Cloud Platform. So Google Workspace and Cloud Identity accounts. So the Google Workspace or Cloud Identity account represents the company, and this is a prerequisite to have an organization resource. You can't have an organization resource without a Google Workspace or a Cloud Identity account. This will provide you identity management, ownership and lifecycle management, and recovery mechanisms. So the Google Workspace superadmin is the individual who sets up the domain ownership verification and sets up contact cases for recovery and sets up users, right? So for this reason, this superadmin is granted the ability to assign IAM roles by default. The Google Workspace superadmin's main duty with respect to Google Cloud is to assign the organization's administrator IAM role to the appropriate users in the domain. As a result, then we get our separation of duties between Google Workspace and the Google Cloud Platform administration responsibilities. With an organizational resource, we get a lot of benefits. So projects belong to our organization instead of the employee who created a project. So projects are no longer deleted when an organization removes an employee from their system, whether they leave or for whatever reason, right? That project will now follow the organization's lifecycle on Google Cloud. In addition to that, organization administrators have central control of all resources. They can view and manage all the projects in the company, and this enforcement makes sure that can no longer be shadow projects or rogue administrators. So a key benefit to the organization resource is that you can use the API and you can pool all the information about your projects and your organizations, and you can integrate the Resource Manager API with your organization. So you will always be able to pull back an organization ID. So that's a unique identifier for your organization. A display name. So that's generated from the primary domain name in the Google Workspace or Cloud Identity. The creation time of the organization, the last time the organization was modified, and the owner of the organization. So these are all the things that we can get from the Resource Manager API. Now let's take a look at the folder resource. So folders provide additional grouping mechanism and isolation boundaries between projects. You can almost view them as sub-organizations within the organization. Folders can be used to model different entities, different departments, different teams within the company. If folder resources exist and you have appropriate viewing permissions, you can view them from the Google Cloud Console. Like organizations and projects, folders act as a policy inheritance point for IAM and organization policies. IAM roles granted on a folder are automatically inherited by all projects and folders that are included in that folder. The project resource. So the project resource is the base level organization entity. Organizations and folders may contain and usually do contain multiple projects, and a project is needed in order to use Google Cloud. The project is the basis for creating, enabling, and using all the Google Cloud services. All projects consist of two identifiers, a project ID and a project number. You get a display name, the lifecycle state of the project, so is it in active state, is it in delete requested state? You get a collection of labels that you can use for filtering projects. So you can label them maybe by environment, like dev, production, and you get the time when the project was created. IAM policy inheritance. So Google Cloud offers IAM, and that allows you to set granular access to specific cloud resources and prevents unwanted access to other resources. So you can set an IAM policy at the organization level, the project level, the folder level, and the resource level. The effective policy for a resource is the union of the policy set on the resource and the policy inherited from its ancestors. This inheritance is transitive, so resources inherit policies from the project, which inherit policies from the organization. Therefore, the organization level policies also apply at the resource level. In this video, I'm going to demonstrate how to tie in an organization into your Google Cloud platform. So the organization resource is the root node in the Google Cloud resource hierarchy, and it is the hierarchical ancestor of project resources and folders. So we can group all of our projects and folders under an organization. The reason we want to do this is because now when we do this, we're not actually using a user account to assign all of our projects. So previously, when we created projects, it was tied to our user account. And in a real world situation, these projects will be tied to an employee who created the project. So if that employee were to leave and we deleted the employee's user account, the project would be gone as well. So now by using organizations, we can follow the organization's lifecycle instead of the user account. So some prerequisites for using organizations is you do need a domain name. So it assumes that your organization has a domain name and you need to use that to bring it into Google Cloud Platform. So once I'm in Google Cloud Platform, if I come over to the left-hand side on the navigation menu, and I come into IAM and Admin, and I come up and click Identity and Organization. So here's where you see the option to set up Google Cloud for your organization. It gives you a checklist for your administrator. So I'm acting as the administrator right now. So I can look at the checklist and see what I need to do. So this checklist helps you set up Google Cloud for your organization. So if I scroll down, the first thing I need to do, and the most important for our need, is to set up our cloud identity, our domain, and our organization resource. So I'm going to go ahead and click Open, and you see it pop up to the left-hand side. You'll see here that it's telling us we have to set up a Google Identity service, either using Cloud Identity or Workspace. So I'm going to come down, and I'm going to select an option. So I'm a new customer. And this will allow me to set up Cloud Identity, verify my domain, and create my organization. So I'm going to come down, and in option 1, I'm going to click Sign Up for Cloud Identity. That gives me a new window, and it'll guide you through the account creation process. So I click Next. It asks you about your business name. So I'm just going to say Richard K. Spencer, and the number of employees is just me. So I go ahead and click Next. Where's my business located? So I have to specify my country, and I have to specify my email. So I put in my email so that I can be reached. I go ahead and click Next. Now comes the part where you have to specify our business's domain name. So I have a domain name, and it's called richardkspencer.com. So if I go ahead and click Next, this now needs to be verified. So it's asking me, do you want to use this domain to set up the account? I do. I get a warning that this domain hasn't configured to send and receive email. That's fine for now. I don't need to receive emails. I go ahead and click next. Now it's asking me the name. So whatever we put in here is going to be the account administrator. So I'm going to say Richard Spencer. Click next. It asks me how I'm going to sign in. So I'm going to go with rspencer@richardkspencer.com. This could be your name at your company's domain and my password. And I go ahead and click next. It's going to ask me, do I want to get some occasional email? I'm going to say no, thank you. It can send users information about G Suite apps. Again, no thanks right now. Now it said you've almost finished creating your cloud identity account. I check off the I'm not a robot and click agree and create account. This process may take a few minutes. You may need to verify your domain name. In this case, my cloud account has been created. So now I'm going to click the Go to Setup button. So you'll see I get a welcome. Now it wants me to verify that I own this domain. So I'm going to go ahead and click verify. You'll see it comes up. It's a GoDaddy. It's my domain host. Now I can sign in to GoDaddy to verify I own that domain. And there's also some different verification methods resolving creating CNAMEs and TXT records in the DNS. I'm going to click sign in to verify. I get a domain manager pop up. It's integrated with Google Cloud. I click connect, and this authorizes the verification for Richard K. Spencer. Once it's done, they verify the domain. This can take somewhere up to 5 minutes. Once it's over and completed, you'll be brought back to your main page where you can see that richardkspencer.com is now a verified domain name. So you have an optional step here to create new users. In this case, I don't need to. I'm the only user. So now we're back at the main Google Cloud Console page. I'm going to go in the console and I'm going to come back into I am an organization. So I'm going to come over to the navigation bar. I'm going to choose I am an admin and I'm going to come into identity and organization, just where we were before. And I'm going to click go to the checklist. So this is where we originally verified our domain name. So I'm going to come down and I'm going to click open again. So set up our cloud identity, domain, and organization resource. I have this done. So I'm just going to click continue and I'm going to sign into my new account. So right now I'm signed in as richspencer@gmail.com. If I click switch accounts, you'll now see that I have my richardkspencer.com account. So I'm going to go ahead and click select. It brings me into the Google Cloud Platform as that user. And right away, you can see it says we've detected an organizational resource for your account. This resource was created when you set up your Google Identity account. So if you come down now, we've got everything done. We can mark the task as complete. And at this point now, you can see our organization is set up here. So now if I want to create a new project, I can click create new project. And now my organization is richardkspencer.com. So I can expand this by adding more users to this organization. And every time a user created a resource, it would be tied to this organization instead of the user account. So I hope this video showed you how to tie your organization and domain name to the Google Cloud Platform and to be able to start using organizations to bring in an efficient hierarchical resource management system to your Google Cloud Platform. Now let's dig in further to Google Cloud projects. So a project organizes all your cloud resources. A project consists of a set of users, a set of APIs, billing, authentication, and monitoring. So for example, if you have a cloud storage bucket and objects, you'll have user permissions, so these users can access these, and these will all reside in one project. One thing to note about a Google project is that you cannot access another project's resources in another VPC unless you use a shared VPC or VPC network peering. So how can we interact with our cloud projects and create and manage our cloud projects? First of all, we can use the console. So if we're using cloud storage inside the console, it's automatically associated with a project. You can then change these projects using the drop-down menu at the top where you can specify different projects. You can use the JSON API. So the list buckets and insert bucket methods require that you specify a project. So that project then is sent as a parameter in the request URL. And the gsutil. So the gsutil MB, gsutil ls, and gsutil KMS commands require that you specify a project, unless you have a default project already set. And if you don't have that default project already set, or if you want to change projects, you can specify the -p flag to specify a project. So these are some caveats that when you use projects, whether you're in the console, using API calls, or gsutil, there are some commands that do need a project specified. Projects and permissions. So for each project, we're going to take advantage of identity and access management to be able to grant ability to users to manage a project. A member would obtain permissions. Usually they're probably part of a group, and that group has a role assigned to them. And that member gets permissions granted at the project level. Alternatively, you could grant a role just for an individual bucket as well. Right, so it's a really granular setup when you're using identity and access management. Now let's look at the Google Cloud Project service accounts. So service accounts allow applications to authenticate and access all your Google Cloud resources on your behalf. So you can create a service account that lets your compute instances access objects in your cloud storage bucket. There's also other things that we can do that need to use. Some other examples of service accounts in use are to perform storage transfer service transfers, to move data to and from Cloud SQL instances, and to create signed URLs. Our application needs permission to interact with Google Cloud and its resources to perform these duties. Service agents are a special type of service account that acts on behalf of a Google Cloud service. So Google Cloud will use a service agent for pub/sub notifications for things like cloud storage and customer managed encrypted keys. So the cloud storage service agent, including its email address, is not initially available when you make a project. It's automatically activated the first time it's accessed, either by one of the features above, right, customer managed encrypted keys or pub/sub notifications, or if you request the service agent's name. The service agent must be activated prior to you performing any permission assignments to it. Google Cloud projects follow an organizational policy. So there are some organization policy constraints that are applied to enforce things like bucket settings across the entire project or the entire organization. You can use cloud storage constraints. So you can set retention policies. You can set who can access what cloud storage devices, who can read, who can edit. And when you apply the retention policy seconds constraint, you specify one or more durations as part of the constraint. So once we set that retention policy, it's now set in the bucket, and it must include one of the specified durations. This retention policy is going to be enforced when a new bucket creation or when adding or updating the retention period of a pre-existing bucket. Let's talk about enforcing uniform bucket level access. So when you apply the uniform bucket level access constraint, all new buckets that are created must enable the uniform bucket level access feature, and pre-existing buckets with this feature enabled cannot disable it. Pre-existing buckets with uniform bucket level access disabled are not required to enable it. And the detailed audit logging mode. So if we apply the detailed audit logging mode constraint, Cloud Audit logs associated with our storage accounts and storage operations will be sent, and they will contain detailed request and response information. So it gives us a way to pull back logs from our cloud storage account, and it includes things like query parameters, request body parameters, credentials, raw object data, so we can get a good look at our storage and what's actually happening inside. So these are just some of the constraints that you can add to a Google Cloud project to make sure that everything stays compliant within the whole project, other sub-projects that may be associated with it, because again, all this is inherited down through child projects and folders. In this video, I'm going to demonstrate how to set up a new project and assign it to your organization. So once you come into the Google Cloud platform, your first project is created automatically for you, and it's part of your organization. So my first project is the name, and it's part of the richardkspencer.com organization. But what if we want to create a new project? So once we're in under projects and folders, we can just click new project. I go ahead and click new project, and I give it a project name. So maybe it's a web app that we want to deploy. So I'll call it my web app. I'll make sure my organization is set to Richard K. Spencer, because this is where I want all the hierarchical rules to come into play. I want all my folders and everything created for my web app under this project name to be associated with this organization. And I want the location to be in the parent organization. If I had specific folders here, I could browse and I could see multiple folders under my organization, and I could launch my folder in there as well. I'm going to leave it at the root or the parent organization. I'm going to go ahead and click create, and you'll see that it starts to spin up my web app. And once this is finished, you'll see a green check box. Now it's done, and you can just click select project, and it'll bring you right into your newly created project. Once we're inside that project, now you'll see that our drop-down menu has changed. This is not called my first project anymore, it's my web app. I can move back and forth between projects, and I can change it to my first project if I wish. I'm going to leave it on my web app, but you'll notice that I do have two projects under this organization. So I'm going to go ahead and click cancel and come back to my project dashboard. So here's where I see my project, the project ID, project number. I can go to the project settings here, make any changes to this project. I can move this project to a different organization if I had one. I can move it to a different subfolder under my organization if I wanted to. Once I'm finished, I can come back to my home menu again. You'll see that this didn't change. I'm still under my web app, and it's important to recognize that you should always be under the appropriate project for when you're doing any work. I can set APIs and turn on and off different APIs in my project. I can see my Google Cloud Platform status. I have options to monitor. I can look and view all the resources in my project, any trace data, any error reporting, and there's even a Get Started guide here. So a Get Started guide can allow me to deploy a pre-built solution, add dynamic logging, or install the Cloud SDK. But the main thing to get out of this is that I can create projects under my organization. So the hierarchy will flow through all of my folders. So if I had subfolders, I could set up subfolders in my organization, and I can put projects in there as well. But for now, we have our project, my web app. We can view by clicking down, and we can see that I'm selecting it from richardkspencer.com. If I had other organizations here, I could find those too. Or I can click no organization to find projects that do not have any organization. I'm going to go back to Richard K. Spencer again, double check to make sure that yes, here's my organization. Here are the projects that I created underneath it. This one was created by default. This one was created by me, and they both fall under the Richard K. Spencer hierarchy and the organization that we set up using Cloud Identity. So I hope this video showed you, once you already set up your Cloud Identity and brought in an organization in the Google Cloud, how to go ahead and create new projects and assign them to that organization. In this video, I'm going to show you how to manage, delete, and restore a project in the Google Cloud Platform. So once I'm logged into the console, you'll see my organization up at the top. It's richardkspencer.com. And under that organization, I have two projects. One's called My Web App. The other is my first project. This was the default project that was created for me. You'll notice the organization for both are tied to richardkspencer.com. So I'm going to go ahead and I'm going to make some changes to My Web App. So I'm going to go ahead and I'm going to click the My Web App link. And now you're brought into the My Web App project console. So here's where we can enable APIs for the project. We can add resources for the project. I can monitor resources in my project. And I can add people to this project. So I'm going to modify the project. I'm going to click Go to Project Settings. And here's the project settings. So I can change the name. So I can call this My Web Application. You'll notice I cannot change the project ID, nor can I change the project number. The location is here, so I can navigate to my organization from here as well. I can also move this project by clicking the Move, and if I had multiple organizations, I can move them to a different organization or a different folder. So I'm going to go ahead and click Cancel. I'm going to save, so I save my new project name. And now I want to add people to this project. So I'm going to go to IAM, and you'll see the permissions for the project My Web Application. Right now, R. Spencer at richardkspencer.com is the owner and the organization administrator, and that's who I'm currently logged in as. But what if I want to add another person to manage this project? I can come up to Add and click the Add button. And now you need to add a new member. So I'm going to add a member, richspencer@gmail.com. It picks it up. It's a valid Google account. And I'm going to give this person a role. So I can give them a basic role. I can give them an access approval role. If we're doing stuff with APIs, I can give them an API role. Right? So in this case, I'm going to give richspencer@gmail.com. I'm going to come all the way down. And I'm going to make richspencer@gmail.com a VMware Engine Service Admin. So I have full access to the VMware Engine Service. So I go ahead and click OK. I can also add a condition here if I wanted to. So this condition builder will allow me to only let this person assume this role under a specific time. And I can expire that access, or it could be specific resources. So it gives you that extra level of granularity. I'm going to go ahead and click Save. It updates the policy. Now you'll see that richspencer@gmail.com is here with the role. I could delete this role. I could delete the member. I could edit the member if I wish. So the last thing I want to show you, and we'll go back to our Manage Resources down on the bottom here. And I'm going to go back to My Web App again. And I'm going to delete the web app. So I come up and I click Delete. And it says, this project will be scheduled to be deleted after 30 days. So it schedules it for delete. It shuts down your resources. And that 30 days gives you a buffer that you can restore it. So I'm going to go ahead and shut down the project. So to shut down the project, type in the project ID. I'll copy it, paste it in, and I'll click Shut Down. Now you can see it's shutting down my project. Project is pending deletion, and it will be deleted after June 16th, 2021. So it gives me 1 month from today. So now I'm back to my screen. Under my organization, you only see my first project because we deleted the other. But what happens if we deleted something by accident? Because it can happen. So you want to come down and click the Resources Pending Deletion link. So once I click that, you can see my web application is here. It's pending deletion. So if I go ahead and select this application, come up and click Restore, it's telling you You're going to restore a project. It'll be no longer deleted, but it does not re-enable billing, and some VM instances will not be automatically restarted. So you can go ahead and click restore. It restores the project. Now we have nothing pending deletion. We've returned back to our main resources page, and now our web application project is back under the organization. So I hope this video showed you how to manage your projects, how to add users to your projects, how to delete your projects, and how to restore your projects. In this video, I'm going to show you how to add an organization to your Google Cloud platform. So right now, you'll notice I already have an organization. It's called richardkspencer.com. But a lot of times, your organization may have multiple Google Workspace accounts, and you'll have multiple organizational nodes by default. Or you may have multiple projects, and each project aligns differently with an organization. You want to manage it all at one central level. So one thing you want to do is make sure you have an organization administrator, so someone who can administer all the organizations in your Google Cloud platform. So I'm going to go ahead and add a new organization. You'll notice I'm up under my web application. There's absolutely no organization tied to this, and yours may be just like this. You may not have an organization like I do right now. All of yours may be from no organization. So you'll see my web application has no organization. I'm going to click cancel so I can come back into my web application. And at this point, we want to come over to the navigational menu. We want to come down to IAM and admin. And we want to choose identity and organization. Once we're under identity and organization, it says manage Google Cloud setup for your organization. So I'm going to go to the checklist. You'll notice that it says I already have mine set up. It's because it defaulted back to the richardkspencer.com organization. If I click here and then select from no organization and choose my web application, you'll see that I have to set up this whole resource again. And this is what we're looking for. We want to add a new identity and domain and organization. So I'm going to go ahead and on the checklist, I'm going to click open. It tells me it's detected an organizational resource, but I'm going to come down, all the way down, and I'm going to say I'm a new customer. We want to set up that new organization. So it tells me you should sign up for Cloud Identity. So I'll click the blue button that says sign up for Cloud Identity. It tells me, this is the guide that's going to use to set you up for Cloud Identity. I'm going to go ahead and click next. Tell us about your business. In this case, it's just me, and it's called Learn the Cloud. I click next. Where's my business located? It's in Canada. And my email address, so I'll give the email address. Click next. Now what's our business domain name? So this is the key component to setting up the organization. So the domain name is learnthecloudnl.com. Yours will be different. I'll go ahead and click next. Now it asks you to set everything up and verify that you own it. So this is my domain, learnthecloudnl.com. Do you want to use this domain? I do, so I click next. Asks me for my name, so I'm going to give it Richard Spencer. Click next. Asking me how I'm going to sign in. So just like the previous organization, where it created rspencer@richardkspencer.com, now it's going to create rspencer@learnthecloudnl.com. It'll even use the same password as my previous user, which is not great. I'm going to set a new one. And I click next. Asking me if I want emails. Click no thank you. And no thanks. We're almost done. I confirm I'm not a robot. I agree and create account. And now it says our Cloud Identity account has been created. So at this point, I can click Go to Setup. Brings me into the Google Admin Console. And this is your Google Workspace. So Now we have to verify that we own this domain name. So I'm going to click the verify button, and this can take up to 5 minutes. So I click verify. I click sign in to verify, and I get a pop-up that belongs to my domain name provider. I put in my password. I can save my password if I wish. I can go ahead and click connect. And now it's asking me, do I want to connect this domain to Google? I'm going to click allow. Now it's into the verification stage, and it can take upwards of 5 minutes. Once it's finished, it'll come back that it verified learnthecloudnl.com. And now I can click the Setup GCP Cloud Console button, which will bring me into my console. You'll notice that my user has changed again, and now I'm logged in as rspencer at learnthecloudnl.com. So I have two organizations, learnthecloudnl.com and richardkspencer.com, and I have richspencer@gmail.com, who's going to be the organizational admin for both of these organizations. So if I come back into the Google Cloud Console, you'll see I'm still logged in as a Google admin. But if I change my account to rspencer at learnthecloud.com, it brings me in. And now I can get started with this organization. So I just agree to the terms of service. And now I'm set up for rspencer at learnthecloud. So I hope this video showed you how to add another organization to your Google Cloud platform and then be able to run the multiple organizations for multiple projects. In this video, I'm going to demonstrate how to apply labels and tags to an instance in your Google Cloud platform. Before we do this, though, it's important to recognize the difference between a label and a tag. So labels are used to organize your resources for billing and reporting. You can roll up all your resources and money you spend across multiple projects, and then slice and dice that data to help you understand and better manage what you're doing. So you may want to label resources by environment, say production versus staging, or by project cost center, or by whatever microservices in your system. However you want to slice it up, you can use labels just for that. Labels take advantage of the metadata, and metadata is sent across multiple Google Cloud platform resources, and it can all read it. So really, what you're doing is having your applications send and receive that metadata. Network tags are used to activate different firewall rules and routing entries for a particular instance. So these are used to make your VPC do almost whatever you want. You can rewire this software-defined networking by setting various network tags on instances and network rules. So now we've got that out of the way, let's come into a project, launch an instance, and apply some labels and tags. I'm under my workload application project. I'm going to come down to Compute Engine and click Compute Engine. You'll see I already have one instance running. Now I'm going to run another instance. So if I come up and I click Create Instance, I'll leave the default value of instance 2, but you'll see right away labels. So I can optionally add some labels here. So I'm going to click the Add Label button. And it says labels entered here will be assigned at the time of instance creation. Labels for an existing instance may be edited after the fact. So I'm going to add a label, and I'm going to say created by Richard Spencer. Environment is going to be development, and the cost center is going to be marketing. So the reason behind this now is that using this metadata, we can pull back everything that's been created by Richard Spencer or everything that has a cost center of marketing. So I'm going to go ahead and click Save. You'll see the labels are here now, created by Richard Spencer, environment is development, and the cost center is marketing. I come down, I can leave all this for the purposes of this demonstration the same. We've taken care of the label side of things. Now we need to look at our network tagging. So I'm going to say allow add HTTP traffic and allow HTTPS traffic. And I'm going to expand the management, security, disks, networking, and sole tenancy options. So I expand it. I come down, and to the far right you see networking. Let's go ahead and click networking. So here's where I can add some network tags. So I'm allowing HTTP and I'm allowing HTTPS traffic. So I'm going to call that dev HTTP. These are my development boxes that allow HTTP traffic. Now every time if I apply this network tag to another instance, it'll pick up these firewall settings. I'm going to leave the host name the same, the default network interface the same, and go ahead and click create. So it's creating my instance. While this instance is firing up, let's take a look at the first instance. So if I just highlight this instance and click the name, I'm brought into my VM instance details. I can come down and see right away, there's labels here. If I want to come up, I can click edit. I can come down, I can add more labels to this instance. So I can say cost center, marketing. I can apply different network tags, same as before. I'm going to leave that the same. I'm going to come down and save my access. Now it updates the instance, it updates the tags, and it updates the labels. Once it's completed, we'll be brought back to our main instance page, and we can see what has changed. It's spinning up here in the top right hand corner. So our notifications are just updating what we wanted it to update. So once it's complete, I can come back up to the top, come back out to VM instances. And at this point now, our second instance should be fired up. And it is. We can see it. And if we click this instance now, and we take a look at some of the data here, you can see cost center is marketing, created by is Richard Spencer, and environment is development. So I hope this video showed you not only the difference between a label and a tag, but how to implement those when you launch any resources on your Google Cloud Platform console. In this video, I'm going to demonstrate how to move around projects within folders in your organization. So I'm logged in as richspencer@gmail.com. I'm a super user. I have access to both of my organizations, richardkspencer.com and learnthecloudnl.com. So I'm going to go into learnthecloudnl.com. And from here, I want to create folders and I want to create a new hierarchical resource. So from here, I'm going to just cancel. I just wanted to show you that part. And I'm going to come back over to the navigational menu. I'm going to come out to IAM and admin. And I'm going to come down to manage resources. So I'll click manage resources. You can see here are both my organizations. I'm going to collapse the richardkspencer.com. And we're just going to use the learnthecloudnl.com organization. So I'm going to come up and I'm going to click create folder. And I'm going to give this folder a name. I'm going to call it the dev team. My organization is going to be in learnthecloud.com. And the location is the parent organization because it's my first folder. So I go ahead and click create. It creates the folder dev team. So now you can see if I do a refresh, you can see my newly created folders right here. And now I'm going to create two more folders. Team 1. Make sure I change the organization to Learn the Cloud. And now I change my location because I want this to be a child folder. So I click Browse. And instead of putting it at the root, I'm putting it right at Dev Team. And I click Create. I'm going to repeat this process for Team 2. I'll create a new folder. I'll call it Team 2. Ensure it's in the proper organization. And I click Browse because I don't want it at the root. I want it here at Dev Team. I click Create. And now you can see, once I get back to my main screen and do a refresh, I've got learnthecloudnl.com as my organization. I have a folder called Dev Team. Inside that folder is Team 2. and Team 1. So now I'm going to go ahead and click Create a Project. I'm going to call it Team 1 Project. I'm going to select the billing account for development. Make sure my organization is learnthecloudnl.com. And now I choose my location. So I'm going to click Browse because I want to make sure that I put this project for Team 1 under the Team 1 folder. So I go ahead and click Create. You'll see the projects being created. Once this is complete, we should be able to do a drop down on Learn the Cloud, and we'll see that project under the appropriate folder. So I'm going to come back out. I'm going to expand the Learn the Cloud NL node, look at my Dev Team folder, look under Team 1, and you'll see there's a Team 1 project under the Team 1 folder. So what if I did that by accident? What if I put it in the wrong folder? So I can click the box next to Team 1 project, come up and click Move, and it's asking me where do I want to move this. So I'm going to move it into the Team 2 folder. So I highlight Team 2, click Move. It's moving the Team 1 project to the Team 2 folder, and there it is. So I hope this video showed you how to create that resource hierarchy, how to create projects in folders, and then how to move projects amongst different folders in your organization. In this video, I'm going to demonstrate how to migrate a project from no organization to your new organization. Or if this was a real-world situation, how can I migrate a project from one organization to another? So if you had a client who wanted to migrate all their GCP projects to another organization, how can we do that? So the key to moving a project from one organization to another is to move all the projects out of any folders and into the top level. So normally Google support, if you send them a list of projects that you want to move from the current organization to another organization, Google support will move the projects out of those organizations so they have no parent organization. So in order to kind of simulate that today, and for you to migrate your first application into your new organization, I'm going to come up and I'm going to come in and I'm going to use the drop down and I'm going to choose a project that has no organization. So if I select from, here are my two organizations, but I'm also going to choose no organization. From here you'll see I have starter project. Yours may be called my first project. Right, but the key is here, we want to move this from having no organization into an organization. So I'm going to go ahead and click Starter Project. And now you can see that my starter project is here. I have nothing going on, I have nothing spun up. So if I come over to the navigation menu and under IAM and Admin, I can come down and choose Settings. So if I choose Settings, here you see my project, the project ID, the project number. Now I'm going to go ahead and click Migrate. So I'm going to migrate a project into an organization. So migrating a project will permanently attach that project to an organization. Projects cannot be detached once they have been migrated. So you'll have to contact Google support to move them out of that organization. So I'm going to come over to select an organization under the drop down, and I'm going to put this one in learnthecloudnl.com. So I click learnthecloudnl.com, come over, and I click Migrate. That's now migrating that starter project into learnthecloud.com, and now it's successful. It's done. So if I come back up under my starter project now, you'll see that it is under the learnthecloudnl.com organization. And if I choose the drop down for no organization, you'll see that even though that still says starter project, if I do a refresh and I come back into my drop down again under no organization, you'll see that there are no projects that do not have an organization assigned to it. So if I come back to Learn the Cloud, you will see your starter project here. So now you've got your project into your organization. So now when you want to do any changes, always make sure you come up to your project, make sure you select from the organization. From here, you can create new projects in the organization. You can move projects around within the organization, but you'll always need to double check and make sure that you're selecting from the proper organization. So I'm going to go ahead and click cancel now. I'm happy with how everything looks. I can come back out and I can start to actually spin up resources in this project. And that project now is tied to my organization, and which is tied to the billing account, and everything is manageable and in a way that we can view it from an organizational perspective. So I hope this video showed you what you need to do from a Google support point of view to get your projects out of one organization if they're already there. And if they're not already there, like your starter project, how to migrate it into your brand new organization. In this video, I'm going to show you how to enable a Cloud API for your Google Cloud Platform project. So we know that Google Cloud projects are equivalent to a developer account. It's your resource container and your isolation boundary for the usage of all your Google Cloud services. In order to use these APIs, they have to be enabled individually for each service you want to use. So there's a lot of different APIs. There's compute APIs such as App Engine API, Compute Engine API. There's storage and database APIs for Cloud Spanner, Cloud Bigtable. There's Cloud DNS APIs, and there's data analytics APIs like Cloud Composer API and BigQuery API. These are just some of the APIs that you can enable for your project. So I'm in my project. It's my web app. It's a brand new project. I do not have any resources, as you can see here. So I want to use the compute engine. So I'm going to come up to the navigation menu, and I'm going to come down to compute. And under compute engine, I'm going to click VM instances. So I want to fire up a VM instance for my web app. First thing it tells me is that I need to enable the compute engine API. So these APIs give you a full overview, give you links to tutorials and support in terms of service. You can come over to documentation. You can click these documentation links to find more documentation about the Compute Engine API, and there's also support areas for you as well. So I know that I want to use the Compute Engine API. I'm going to click to enable the API. There's also a button to try the API in API Explorer to see if that's the API that you want. And it's the API that is going to fulfill the needs for your project. It takes a couple minutes for the API to enable. You can see the spinning circle here. You can also see it up under your notification section. Once it's complete, you'll be brought into the Compute Engine console, where here now I can create instances, import VMs. I have full control and reign over the Compute Engine area. But in order to do that, I had to enable that Compute Engine API. So what if I wanted to use another service? So I come up to the navigation menu. I come down under storage, and I want to create a file store. So I click instances, and I get that familiar page again where it tells me that in order to use this, I need to enable the Cloud File Store API. And this API is used for creating and managing cloud file servers. So I'm going to go ahead. It has all the same documentation. I'm going to enable this API and wait. Once this is enabled, now I'll be able to create my Cloud File Store. Once it's created, you'll see I'm brought into my file store where I can go ahead and create my file store instances. I can also come up to products and services, and I can type in APIs, and it'll bring me to the APIs and services product page. From here, I can look at all the APIs that's happening in my environment. I can come down to library. I can search the API library. I can find different APIs. And if I find one that I want to implement, say Cloud Vision, I can click it, and I can enable that as well. So I can go back to the API library, and the API library is a good place to see all the available APIs that you can integrate with your project. So I hope this video showed you how to implement an API into your project, why we enable these APIs, and where to go look for the huge assortment of APIs that you can integrate into your project. In this video, I'm going to demonstrate how to manage your project folders. So you'll notice I'm under my web application project. I'm right on the dashboard. I can see everything that's going on, which consequently is not much. I have nothing running right now. But I want to show you the folder structure, how to manage the folders, and look at permissions on the folders. So in order to view my folder structure, I'm going to go to Project Settings. I'm going to click the Go to Project Settings button, and I'm going to come down to Manage Resources. So I'm going to go ahead and click Manage Resources. So from here, you can see all your resources. I have my organization, I have my web application, and I also have folders called the Dev Team. So when I expand these folders, I have Team 2 and I have Team 1. So anything on these folders for permission-wise will be inherited from the parent Dev Team folder. So if I click Team 2 and I look at permissions, I can toggle the Show Inherited Permissions toggle button. And when I do that, I can see the permissions that have been inherited from my top level hierarchy, which has been inherited from my organization. So if I look at the folder admin, it's richspencer@gmail.com, folder creator, richspencer@gmail.com. Okay, so this is picking up inherited permissions from Learn the Cloud. I can turn this off, and you'll only see permissions I explicitly set. So let's go ahead and add a member. Now, some of the best practices we want to look at is to use groups as much as possible. We want to minimize the use of basic roles, so owner, editor, and viewer. We want to try to use more predefined roles for principle of least privilege. So I'm going to go ahead and for Team 2, I'm going to click Add Member. When I add member, I'm going to paste in the email address of the network admins group. So you can see it picks it up. It's gcp-network-admins@learnthecloudnl.com. So when you set up your groups, you get these predefined groups for you. And they already have roles and permissions. So whoever is applied to the network admins group will only have the roles that are assigned to that group. So they can only do what they need to do. And in this case, it would be network administration. So I'm going to set that group. And then I'm going to select a role, and I'm going to come down, and I want to look for the networking. So I come down, I find network connectivity, network management. These people are going to be network admins. So I'm going to give them network admins role on this folder. I go ahead and click Save, and it updates the policy. So now I can collapse these folders. When I toggle off the inherited permissions, you'll see under Network and Management Admin, if I expand the node, there's a group called GCP Network Admins. In that group, I have multiple users, right? And that's the best practice. I also have a compute admin, kduff@learnthecloud.com. So I added that member just individually, right? And I can also add this member as a different role. So maybe kduff@learnthecloudnl.com is also a project billing manager. So I click Save. She is now the project billing manager for this folder. But if I wanted to come to Team 1 and make someone else a project billing manager for Team 1, I can do that as well. So if I wanted to say dloman@learnthecloudnl.com, and I come down and I make them a billing manager, and click Save. Now you'll see that D. Lohman is a project billing manager on Team 1, and K. Duff is a project billing manager on Team 2. So I hope this video showed you how to use your folders, how to set permissions on the folders using groups and individual users. Now let's dive into Google Cloud Folders, roles, and permissions. So you will use identity and access management to give you a little bit more granular access to specific cloud resources, and that'll prevent that unwanted access to your resources. IAM lets you adopt the security principle of least privilege. So you want to give your users the least amount of privilege possible in order for them to do their job. So when you look at implementing IAM roles for folders, there are some things that we need to take into mind. First one of these would be the types of actions, required roles, and the resource level. So things like types of actions could be to administer folders. Right now, what required role would we need to administer folders? That would be a folder admin. And at what resource level are we going to set it? So in this case, it would be across the organization. Now, if we wanted someone just to create a new folder, that would be a type of action. That required role would be a folder creator. And the resource level would be the parent resource for the location of the new folders. So as you can see, it gives you a lot of different options and provides increased granularity for permissions. Some best practices for using these IAM roles. So when assigning IAM roles and permissions, you want to use groups. Groups are a great way to manage members. You just add a member to the group. The group already has the role assigned, and you don't have to keep adding roles to individual users. When users leave, you just remove them from the group, and their roles go away with it. You want to minimize the usage of the basic roles, these roles like owner, editor, and viewer. And you should try to customize your roles or use some of the predefined roles for principle of least privilege. You want to assign permissions at the folder level because that project inherits them automatically. So you could assign a department administrator group the folder admin role on the folder, and the network administrators that need to have department-wide permissions can have the network admin role for the folder. You want to carefully consider what permissions may change before moving a resource out of a folder and into, say, a different folder. And you want to plan and test resource hierarchy. So before you start moving production projects in and out of folders and in different folders, you want to plan and test that. So you can create a test folder under your organization resource, then create a prototype of your intended hierarchy ahead of time, and just do a little dry run to see how things behave. Some default folder roles and permissions. So when you create a folder, you're automatically granted the folder admin role and the folder editor roles. That'll provide you full control as a creator. The folder admin role is used to manage folders for the entire organization. It'll grant the user permissions to create, edit, delete, move, and change IAM permissions on the folder. All viewer permissions, plus permissions for actions that, say, modify state, such as changing existing resources, are included in the folder editor role. So while these roles, the editor role, contains permissions to create and delete resources, it doesn't contain permissions to perform all actions for all services. So that's the separation there between a folder admin role and a folder editor. Some other folder roles that we have are folder creator role. So that grants permissions needed to browse the hierarchy and create folders. Folder editor role grants permission to modify folders as well as to view the IAM policy for specific folders. The folder mover role allows users to move projects and folders in and out of a parent organization. And the folder viewer role grants permissions to get a folder, list the folder, and view the projects below a resource. Google Cloud custom roles. So in addition to the roles that already come defined with Google Cloud, you can create your own roles. It is important to note a few caveats when creating custom roles. So the list and get permissions should always be granted as a pair. You're not going to give someone list without get and vice versa. Folders.list and folders.get permissions should always include projects.list and projects.get. And you should be aware of the set LAM policy permission for organizations, folders, and projects that allow the users to grant all other permissions. So be careful when you're using the set IAM policy permissions. So now you get into actually granting the role. So in order to grant roles to enable folder browsing, you need to add the resource manager.folders.list and the resource manager.projects.list. Right? All of these types of permissions typically need to be granted to allow users to list folders under resource. So that's important to know. If someone can't see everything that they're supposed to see, make sure they have both the resource manager.folders.list and the resource manager.projects.list roles. In this video, I'm going to show you how to create users in Google Cloud Identity, both manually and automatic using a CSV file. So you'll notice I'm under my project, my web application, and I'm logged in as R. Spencer at learnthecloudnl.com, which is my organization. And I'm going to come to the navigation bar. I'm going to click the navigation bar. I'm going to come down to IAM and admin. Then I'm going to come up to identity and organization. So I click identity and organization. It asks me to select an organization. I'm going to select learnthecloudnl.com. You can select yours. I click select. So I'm going to go ahead and click the checklist. You'll see that I have set up the organizational resource. Now I need to add users and groups to the organization. So I'm going to go ahead and click open. Now it tells me exactly what I need to do, and that's why I like this checklist, because it walks you through everything that you need to do to set up your projects and your identity platform as a whole. So now we need to add users and groups. So if we come down, it tells us exactly where to add users. So to add users in the Google Admin Console, let's go ahead and click the blue button. You can see now that I have some users already set up, but I can go ahead and add more. So if I want to add an individual user, I just come up and click Add New User. And now I can type in the name. So it's going to be Travis Spencer and the email tspencer@learnthecloudnl.com. I go ahead and add the new user. You'll see that the license is assigned for my Google Workspace. Here's my user. I can copy the password. I can email that user's sign-in info. I can add that user to a group now. So I'm going to go ahead and click Add to Groups. You'll see that right now it doesn't belong to any groups. If I go ahead and click Add the user to a group, you'll see all these predefined groups. So Travis is a developer. I'm going to add him to the GCP developers group. I click Add. Travis has been added to the group. Now I can come back over to users, click users, and now you'll see the users there. But what if I have like 100 users and they're all in a CSV? I can bulk update the users. So if I click bulk update users, I'm given a pop-up. Here I can download the user info in a CSV file, which is good if I want to make any changes to it. Say if we had 500 users and we're changing our domain name or how our email addresses are displayed, I could download all those users, make the change in CSV very quickly, and upload it back. I'm going to download a blank CSV template. Once it downloads, it's called users.csv. So I'll click Save. I'll open up the users.csv file. It'll open up in Microsoft Excel. So you'll see the users.csv. I can expand some fields and find out what's required. So first name, last name, email address, password, and the organizational unit path are required. So I'm going to go ahead and give a first name of Paul and a last name of Clark. Going to be pclark@learnthecloudnl.com. Password I'm going to set as a random password. I can leave the password hash alone, but the organizational unit path needs to be a /. I need to ensure that this user is at the base root level of the hierarchy. So once I'm happy, I click Save, and now I'm going to close the Excel spreadsheet. Now we're back to our bulk update users page. I simply attach the CSV file, find the users.csv, come down, click Upload, and you'll see the progress window. So it's processing a bulk upload. An email will be sent. The bulk upload user info has completed successfully. So now if I do a refresh on this page, you'll see Paul Clark is now here. So I hope this video showed you how to add users manually using the Add New User button, and how to add bulk update users via an Excel spreadsheet or CSV file. In this video, I'm going to demonstrate how to enable and view your audit logs in Resource Manager. So your Google Cloud services will write audit logs, and it'll help you figure out who did things in your environment. Who did what, where did they do it, and when did they do it. So it only contains audit logs for resources that are directly within a project. Things like folders, organizations, and cloud billing accounts contain the audit log for the entity itself. So once you're in the Google Cloud Platform, you're in your project. What we want to do is come over to the navigation menu, click the navigation menu, and come in under IAM and Admin. Under IAM and Admin, you will find Audit Logs. Let's go ahead and click Audit Logs, and you're brought into the Audit Logs console. So here you'll see all the audit logs that you can turn on individually. So we've got audit logs for Certificate Authority Service. We have Cloud Asset API logs. Everything right on down to Machine Learning Engine. And we have things like Cloud Retail API, Cloud SQL. So if we turn on the Cloud SQL audit log, and at any time someone did anything with Cloud SQL in this project, there will be audit logs written. So if I wanted to, say, turn on the Cloud PubSub API, you see automatically to the right, it selects the log type for you, and then you can turn on and off the audit logging. So I can make it admin write, admin read, data read, and data write. And I can also implement some exempted users. So that allows us to control which users generate audit logs. So if I didn't want to generate any audit logs myself, I could just type in my username, and I'll exempt the audit logs for my user. And I can go ahead and click Save. It's telling me that the logs are turned off for Cloud PubSub API for my user. I click Confirm. Once it's complete, I do have the Cloud PubSub API log turned on for everybody except me. You can see that it also turned on because you have the green checkboxes in your Cloud PubSub API column. These columns are admin read, and data write. So it's good to kind of differences between these. So these admin activity logs will include things like admin write operations, and then data access logs, so who's reading the data and who's writing the data. There's also an option to default audit configuration. So Google gives you an option to quickly implement the default auditing configuration. So if I click default audit config, it says set a default audit logging configuration for all Google Cloud Platform services. So I want to turn on all the admin reads, all the data reads, and all the data writes. So I'm going to go ahead and click Save. It updates my configuration. Now when I come back, you'll see that they're all turned on, and they're all enabled as part of the default audit configuration. So at this point, I'm auditing everything, every resource, every admin read, every admin write, every data read, and every data write. So that's a lot going on. I may want to just configure that for services that I'm running itself. So I can come back to default audit log. I can turn these all off. I can click Save. come back, and then proceed to turn them on individually again. So it really depends. Do you want to log everything? Do you want to log individual APIs? It's really up to you, and it gives you a great granularity because you can select your log type by service, and then you could exempt users so you don't have to see all their logs if you don't want to. So once we're happy with everything, we can come into the Logs Explorer, and we can view our logs in the Logs Explorer. Now, right now, I don't have a lot. I just turned it on. So right now, I have nothing because I only turned it on for one service, which I'm not using. But if I was, this is where you would find it in the Logs Explorer. So I hope this video showed you how to turn on audit logs for individual services, for all services, and where to go to view your logs once those logs start to populate. So in this course, we've examined the Google Cloud Resource Manager. We did this by exploring resource hierarchy and setting up an organization resource on Google Cloud, creating Google Cloud projects and managing them, and creating and managing an organization using labels and tags. We also looked at moving and migrating projects and enabling APIs in a project, managing Google Cloud folders and their roles and permissions, and using Cloud Identity and enabling and viewing Resource Manager audit logs. In our next course, we'll look at Google Cloud Load Balancing. Now let's dive right into Google Cloud Load Balancer. The concept of load balancing is one of my favorite topics. So what does Load Balancer do for you? Your load balancer is going to distribute your traffic across all of your instances in your application. So it's spreading the load across 1, 2, 3, 4, 5, as many instances as you want. And that helps us avoid performance issues and overloading some target instances. So in addition to that, it can also help as a way to serve content close to your users on a system closer to them to avoid some latency issues. And you can get 1 million plus queries per second. So the performance measure is very high with the Google Cloud Load Balancer. The Google Cloud Load Balancer is a managed service. So you don't have to worry about the hardware. You don't have to worry about any updates or patching. It's distributed. So it's distributed fully across all the infrastructure in Google Cloud. And it's software based. So it's using a software defined networking service. Some of the Google Cloud Load Balancer features. First, you get a single IP address. If you have 4 instances serving as your front-end web server, you need one single IP address to give users and to set up for your DNS. So using a load balancer will provide you with that single IP address as your front end. It does automatic intelligent auto scaling. So it can scale up and scale down your servers as needed. You do external load balancing for when your users reach your applications from the internet. But you can also do internal load balancing when your clients are inside of the Google Cloud platform. Some other Google Cloud Load Balancer features include regional load balancing. So if your applications are all available in a single region, you can take advantage of regional load balancing. There's global load balancing when your applications are deployed all over the world. And you have pass-through load balancing. So this is more like direct routing or direct server return. Continuing on with some more load balancer features, you have proxy-based load balancing. So this can be used as an alternative to pass-through load balancing. We have layer 4 load balancing. So we can direct traffic based on data from network and transport layer protocols. So it could be TCP or UDP ports. We have layer 7 load balancing. So this is content-based routing decisions based on attributes. And these attributes are found in the HTTP headers. And we have integration with the Cloud CDN. So the Cloud CDN is Google's content distribution network, and that uses a series of edge locations to cache content for fast delivery. Now let's take a look at some of the Google Cloud Load Balancer types. So you'll see we have two types. It's broken down between internal and external. So let's look at our internal load balancers. These are for users who exist in the cloud and they're connecting from inside the cloud. You can have regional internal load balancers only, supported in the premium tiers. You have an option of pass-through or proxy. Your traffic can be TCP or UDP if you're using the pass-through method, and HTTP or HTTPS if you're using the proxy method. Then you have your external load balancers. So you have your regional external load balancers in the premium and standard tiers. It uses a pass-through with a TCP or UDP network. And in the premium tier, you have your global. So this is effectively the regional in the standard tier. Here you all have proxy, and you can use TCP, SSL, or HTTPS. So what load balancer should you use? And it really comes down to what type of traffic you plan on serving through your load balancer. And that's a huge factor in determining what load balancer you will implement. So for HTTP and HTTPS traffic, you want to use external HTTP or HTTPS load balancing and the internal version. If you have TCP traffic, you may want to use TCP proxy load balancing, network load balancing, or internal TCP UDP load balancing. With regards to UDP traffic, you should use network load balancing or internal TCP UDP load balancing. So what is the difference between internal and external load balancing? So your internal load balancing distributes traffic to Google Cloud instances. So it's all based on your users are from within the Google Cloud and the endpoints are in the Google Cloud and all the traffic is inside that Google Cloud. And you also have the external load balancer, which will distribute your traffic to the Google Cloud Virtual Private Cloud Network. So that's if you have users on the internet who want to hit your instances in your VPC. You need to opt for the external load balancer. So when should we use global load balancing? We want to use global load balancing when our backends are in multiple regions. So really, we've got a global application. We want to make sure that we only use it if users require access to the same content. Right? All content has to be the same. And we can use it to provide access with a single anycast IP address. But in order to use this, IPv6 termination is required. When do we use regional load balancing? Well, you guessed it, when our backends are in the same region and only IP version 4 termination is required. So it's good to understand the caveats and the differences when to use a global load balancer versus a regional load balancer. In this video, I'm going to show you how to get to the load balancing part of the Google Cloud Platform and look at all the various components that make up a load balancer. So once you're in the Google Cloud Platform, you're under a project, come up to Search Products and Resources and just type in Load Balancer. You will get a products page called Load Balancing, and it's part of the Network Services page. So go ahead and click Load Balancing. You're brought into the Network Services console. So the Network Services console has a lot of different options from load balancing to DNS to CDNs. Right now we're more concerned about load balancing. So we can create a load balancer here, but I want to look at some of the resources at a more of an advanced level. So I'm going to come down to the advanced menu, and we're going to look at some of the components of the load balancer. So go ahead and click Advanced Menu. Now you'll see a different screen, and this screen shows you all the components of the load balancer that gets set up. So you have forwarding rules, target proxies, backend services, backend buckets. certificates, and target pools. So what are all these? And right now we have nothing set up. We have to decide which load balancer is best for us before we begin to create our load balancer. But it's good to look at all the various components that go into the load balancing process. So forwarding rules, a forwarding rule and the IP address that corresponds with it, it represents the front-end configuration of your Google Cloud load balancer. Each forwarding rule will reference an IP address and one or more ports on which the load balancer accepts traffic. So normally, some Google Cloud load balancers will limit you to a predefined set of ports. Others will let you specify arbitrary ports. Next, we have target proxies. So what is a target proxy? Target proxies are referenced by one or more of the forwarding rules. So in the case of an external HTTP load balancer and internal HTTP load balancers, proxies are used to route incoming requests to a URL map. In the case of SSL and TCP proxy load balancers, target proxies route incoming requests directly to backend services. Speaking of backend services, if we click backend services, you'll see another section. So a backend service defines how the load balancer distributes traffic. This configuration will have a bunch of values like the protocol used to connect to the various backends, session settings, health checks, and timeout settings. These settings give you that fine-grained control over how your load balancer is going to behave. You have backend buckets, so much like backend services, you can now use backend buckets with Google Cloud load balancing on the HTTP load balancer. So an external HTTP load balancer will use a URL map to direct your traffic from specified URLs to a backend bucket in this case. It can also be a backend service. Certificates. So SSL certificates are created and stored here, and that's what allows us to load balance on the HTTPS protocol or port 443. And we have target pools. So target pools are used for external TCP and UDP network load balancing. They can use a backend service or a target pool, and that target pool will define a group of backend instances to receive the incoming traffic. So if a network load balancer forwards directly to a target pool, the load balancer will choose an instance from the target pool based on a hash of the source IP addresses, the source port, the destination IP, and the destination port. Now, if you intend to use target pools and it only contains a single VM, you should probably use the protocol forwarding feature instead of load balancing. Load balancing is for multiple VMs and multiple backend services. So I hope this video showed you the components of a load balancer, and stay tuned because in subsequent videos we're going to choose a load balancer and create our load balancer. In this video, I'm going to show you how to choose the best load balancer to suit your implementation. So once you're inside the Google Cloud Platform, if you come up under Search Products and Resources and type in Load Balancer, it'll bring us to the Load Balancing page. So go ahead and click Load Balancing. Now we're in the Load Balancer page. So I already have one load balancer created, but first I'm going to show you how to choose the appropriate one. So let's come up and click Create Load Balancer so we can look at our options. So I click Create Load Balancer and we're presented with 3 different options here. So decide which load balancer best suits your implementation. You got to think about whether you need global load balancing or do you need regional load balancing. Global load balancing means backend endpoints are in multiple regions. Regional load balancing means backend endpoints are in one single region. Are we going to be serving external or internal traffic? And is that traffic going to be HTTP, HTTPS, SSL, TCP, or UDP? These are the questions we need to answer before we can find out what load balancer is best for us. So let's take a look at HTTP and HTTPS load balancing. This is a layer 7 load balancer. it can be external, it can be internal. So Google pushed load balancing out to the edge network on front-end servers as opposed to using the traditional DNS-based approach. Therefore, global load balancing capacity can be behind any single Anycast address. So you're load balancing globally, but you're still using one IP address. So it's clear that with the global HTTPS load balancer, you get cross-region failover and overflow. So that's something to take note of. If I click Start Configuration, you can see that it is internet facing or internet only. So I can choose between my VMs or from the internet and the other VMs. So let's go back and take a look at TCP load balancing. So unlike HTTP, which worked on layer 7, TCP and UDP both work on layer 4. So Google Cloud offers proxy-based load balancers for TCP and SSL traffic, and they also use UDP load balancers as well. So if we use the TCP load balancer, then we're dealing with TCP traffic and we don't need SSL offload. So generally speaking, our decision to use these would depend whether we want to require SSL offload or not. So you can use the SSL proxy load balancer when you're dealing with TCP traffic and you need SSL offload. So we've got the TCP load balancer, the SSL proxy, and the TCP proxy. And we also have the UDP option. And this is another layer 4 load balancer that rely on the UDP protocol. So these are your three options. Now let me show you a nice flow chart that kind of brings it all together and it'll help you choose your load balancer if you have any questions which one you should really deploy. So you'll see in this flow chart, we have two starting points, external and internal. So if we want an external load balancer and we're serving external clients, whether IPv6 or IP4, if it's external, then is it going to be HTTP or HTTPS traffic? If so, we should take the HTTPS load balancing. Are we using TCP traffic? If yes, then are we going to offload our SSL traffic? If that's yes, then we want to use the SSL proxy. If it's no, then we can use a global load balancer or IPv6. So if that's the case, then we can use a TCP proxy. Otherwise, no. And do we need to preserve client IPs? If we do, then we use a network TCP and UDP load balancing. If we don't, we have a TCP proxy. So this should cover all your bases. If we're using an internal load balancer, it's a little bit simpler. If it's TCP or UDP traffic, we want to use the internal TCP and UDP load balancing. If it's HTTP or HTTPS traffic, we're going to use the internal HTTPS load balancing. So I hope showing you the different options in the Google Cloud Platform and showing you this flow chart that this video showed you how to choose the best load balancer to suit your implementation. In this video, I'm going to show you how to control access to your load balancers, and I'm going to do this by creating a new user and assigning that user the appropriate roles to manage load balancers. So I need to come up under Search Products and Resources, and I want to search for IAM, or Identity and Access Management. So I go ahead and I click IAM and Admin, and that should bring me into the main IAM page. So I'm working on my permissions for my project, but I'm also bringing in a new user. So I just hired a new user who's going to run my load balancers and all my networking. So the first thing I want to do is come down to IAM and click Add by the Add User button. So I'm going to go ahead and click Add. You don't have to add new users. You can assign these roles to the user you currently have. I'm going to add my new hire, danielleclark@gmail.com. And now I have to set the appropriate roles. So I'm going to click Select a Role. It gives me the drop-down role, and there's 4 roles we need to add. We need to add the Compute Load Balancer Admin, the Compute Network Admin, the Compute Security Admin, and the Compute Instance Admin. So here are all the roles. We can also just type in the role that we're looking for. So I can type in compute load balancer admin, and I'll add that role. I can click to add another role, and I want to type in compute network admin. So it's right here. That gives us full control of the compute engine networking resources. Now I need to add another role. So I'm going to add the compute security administrator role. So that gives you full control of the compute engine security resources. And finally, we add one more role, and this is the compute instance admin. So full control over the compute instances. So this user now is going to be our network administrator, and they got full control of load balancer, the network, any security for compute engines, and pretty much all compute instance administration tasks are available to them. I can add conditions here if I wish. I can send the user a notification email to also let them know that they've been added. I'm going to go ahead and click Save. It updates my policy. You'll see my new user has been created now, and you can see their roles. So compute instance admin, compute load balancer admin, compute network admin, and compute security admin. Now let's take a look at those roles individually. So if I come over to the left-hand side and I come down to roles, let's take a look at the compute load balancer admin role. So I look for compute load balancer admin. I go ahead and click it. Here's the compute load balancer admin role. So let's go ahead and click the role itself, and let's take a look at the assigned permissions. So this role has a lot of compute permissions. It can create addresses, internal addresses. It can delete them because, again, the load balancer, especially when you're using scaling, is going to be creating new instances and shutting down new instances for you. So it needs these permissions to do that. You also have global addresses, all these compute instances, because your load balancer is going to be interacting with the compute engine a lot. Its main goal is to distribute traffic, scale up as needed, and scale down. So it needs all of these permissions inside that role. So I hope this video showed you how to create a new user, assign the appropriate roles, the load balancer admin role, the network admin role, security admin, and instance admin roles, so that you or your users have the appropriate roles and permissions to administer a load balancer in the Google Cloud Platform. In this video, I'm going to show you how to create and scale resources behind an internal load balancer. So you'll see I have two instances running. They're just a basic Apache default website. So if I copy the external IP and I bring it in and put it in a new window, you'll see it's just the Apache 2 Debian default page. It says you've reached instance 1. So I'm going to close that. I'm going to come back into the Google Cloud Platform, and I'm going to come over to load balancer. So we want to load balance these instances behind an internal IP address for use internally. So the first thing I'm going to do is click Create Load Balancer. So once I create Load Balancer, it asks me, which do I want? Do I want the HTTPS? Do I want the TCP or the UDP load balancers? We want to do internal load balancing for HTTP traffic. So I'm going to choose the HTTPS load balancer and click Start Configuration. So the first thing it asks me, is this internet facing or internal? I'm going to click only between my VMs, so this is internal, and I'm going to click Continue. So now I have to give the load balancer a name. I'm going to call it internal LB. Now I have to choose a region. So my instances are deployed in US East, so I'm going to choose US East 1. My network will remain the default network. So you have to create a proxy-only subnet and reserve an IP space. Once that's created, now we have to configure the load balancer. So we have to create a backend configuration. So let's click Create Backend Configuration. Over here in the dropdown, you'll see Create or Select backend services. I have no backend services, so the only option I have is to create one. So I'm going to go ahead and click Create a Backend Service. It brings me into a pop-up. I'm going to call it Internal Instances. My backend type is going to be Instance Groups. It's going to be on port 80, so the protocol is going to be HTTP. Now we specify our backend. So we need Instance Group. I have no instance groups available, so I'm going to go ahead and click Create More Instance Groups in the region. So I click Create Instance Groups. I get a new pop-up. From here, I got to group those instances together, so the load balancer knows where to direct that traffic. So I'm going to call it Instance Group 1. I'm going to choose multiple zones, but I want my region to be US East 1. My target distribution shape is going to be even. I have an instance template here, or I can create a new instance template. So I'll go ahead and click Create New Instance Template. I can create an instance template 2 that uses an E2 micro. I can choose my boot disk should I want to, so I can change this. If you have any custom images, you can choose those custom images. I have a custom image that I created, and it's just a basic web server that you just looked at. So I'm going to use that image. I'm going to click Select. I'm going to allow default access. I want to allow HTTP traffic and HTTPS traffic. So this template basically tells the load balancer if you need to scale up resources, use this template. So I'm going to click Save and Continue. Now you'll see the instance template has been filled in. You come down to auto scaling mode. We can auto scale, we can turn off auto scale, or we can only scale up. I'm going to turn on auto scaling to add and remove instances in the group. And my policy is going to be on CPU utilization. So at 60%, if it gets over 60%, scale up. If it goes below 60%, scale down. We can also add new metrics as well, should we want, like load balancing utilization and the stack driver monitoring metric. We're going to stick with just CPU utilization. We'll leave predictive auto scaling off for now, and we'll scale between 1 and 10 instances. We can go ahead and click Create. Once this gets created, we can continue with our load balancer creation. Once it's been created, you get your green checkbox, shows you the name, the group type, and your auto scaling. So at this point, we want to come back to our load balancer. So now I can come back to my load balancer, create a backend service. We'll call it Instances Backend. It's going to be on port 80. Here's our instance group that before there was none. Now we have one. Port numbers are going to be 80. Our balancing mode is going to be utilization, and the maximum backend utilization is 80. Then we come down to health check. We want to create that health check. We'll call it LB health check. Protocol is TCP. We're going to check port 80. We want to make sure we check every 10 seconds with a timeout of 5 seconds. If we get 2 successes in a row, it's healthy, and 3, it's unhealthy. So I'm going to go ahead and click Save and Continue, and click Create. So I have the backend configuration created. Now we need to create the routing rules. So our routing rule is going to be a simple host and path rule. There's nothing advanced going on. So really, we can leave it all our hosts, our paths default. We just have to click a service. So that instances backend that we created is now our routing rules. So we're saying any traffic route to this backend that we just created. Our front end configuration, here's our new front end. So we can call it LB front. It's the HTTP protocol. Our subnetwork is our default network, and it's on port 80. So once we see the blue check mark there, that's finished. We can click Review and Finalize. It shows us that our backend services is sending stuff to instance group 1, and our front end is the load balancer. So I'm going to go ahead and click Create. the load balancer starts to create. And once it's finished, you'll see that we can hit both those instances internally from that internal load balancer. Now you can see the load balancer is up. All backend services are healthy. So if I click the load balancer, I can see a little bit more info about it. I can see the port. So let me copy this port. I'm going to come over to a compute engine. I'm going to SSH in. And I'm going to do a curl on that internal IP and then try and pull back that Debian default page. So let me SSH into instance 1. Once I'm logged in, I should be able to do a curl and pull back the Debian default page. So now that I'm in, if I do a curl and I paste in, this is the load balancer IP address internally. So if I do a curl, I hit it and I get the Debian page back. So that goes to show that these two instances can reach that internal IP for the load balancer and then get routed to maybe itself in this case or the other instance, right? But this would be used on a wide scale level with a big internet with multiple servers, and a lot of times these servers are using different paths because they're accomplishing different things. So I hope this video showed you how to create that internal load balancer and load balance internally behind a private IP address. In this video, I'm going to show you how to run and scale your applications behind an external load balancer. So this process, much the same as an internal load balancer. I have two instances here. Both of these instances, I'll copy the external IP just to show you what these instances are, and they're just an Apache 2 Debian default page. So 104.196.217.44, and I also have the 35.196.99.116. So you'll see I've reached instance 1 and I've reached instance 2. So let's put these instances behind an external load balancer. Now this one's in US East 1B, this one's in US East 1C. So let's come up to Load Balancer and click on Load Balancing. And this time we're going to click Create Load Balancer. It's going to be an HTTPS load balancing. So we're going to click Start Configuration. But this time we're going to choose from the internet to my VM. So this is an external load balancer. So go ahead and click Continue. Now let's give it a name. So I'm going to call this one External LB. Now I need to create a backend configuration. Where am I going to send this traffic? So it can be a backend service. It can be a backend bucket. I'm going to create a backend service. So I click Create a backend service. It pops up the backend service. I'm going to call this External Service. My backend type is going to be an instance group. My protocol is going to be port 80. Now I need to have an instance group. I don't have an instance group right now. So I'm going to click Create More Instance Groups. That pops up a new window where now I can create the instance group. So I'm going to call it Instance Group 1. It's going to be spread over one zone in the US East 1. Because remember, my instances are in US East 1B and 1C. So I put it in US East 1. I specify my instance template. So we created an instance template that tells the load balancer that each time you have to scale up, use this template. So I can use templates I already have created, or I can create a new instance template. We can go ahead and choose instance template 1. It's the same instances from the load balancer. If you had new instances, you could create a new one. So here comes the scaling. So the number of instances. Do we want to turn auto scaling on? We do. We want the utilization to be at 60%. So any higher than 60%, we scale up. Any less than 60%, we scale down. Predictive auto scaling is off by default. It needs to run for 3 days before it can actually do the predictive auto scale. We set a cooldown period of 60 seconds. So how long for our app to initialize from boot time until it's ready to serve traffic. We'll scale from 1 to 10 instances. We can enable some scaling controls. It'll help prevent that sudden drop in running VMs by controlling the process of scaling in. So we can turn that on. We can say don't scale by more than 10% of the instances over 10 minutes. We can change that 30 minutes, 60 minutes, and so on. And our health check is here. So we're going to create a health check. We're going to call it health check external. Our port is 80. If we were doing HTTPS traffic, we could change this to 443. We want to have a health check every 10 seconds. A timeout is 5 seconds. If we get 2 healthy responses in a row, it's a healthy instance. If we have 3 consecutive failures, it's a non-healthy instance. So we'll go ahead and click save, and those health checks allow the load balancer to know what instances are healthy and where to direct traffic. So once we've got everything set up, I'm going to go ahead and click create. It creates the instance group for me. So while we're waiting for that instance group to create, let's just look at some of the things we created. So we created that instance group, which holds the instances that we want to direct traffic to. We created a template that tells the load balancer every time you need to scale up, use this template. And we created the health check. So the load balancer can tell which instances are healthy, which ones to send traffic to, and which ones to not send traffic to. Now you'll see the instance group is transforming. Soon, when it's done, you'll get the green checkbox to say everything is ready to go. So at this point now, let's come back to our load balancer. In this case, we may have to do an F5 and refresh the whole page so we can see that instance group created. We'll see something like this. So let's go ahead and create that backend again, external backend, still on port 80, HTTP, but this time under instance group, you have a drop down and you can choose the instance group we just created. Our port is going to be port 80. Our balancing mode is going to be utilization, so our maximum backend utilization is 80%. I'm going to go ahead, I can enable the Cloud CDN at this point if we want to push things out to the content distribution network. I'm going to select the health check we just created here, and I'm going to click create. So I created the backend. The host path and rules are fine, right? We're just using a simple host and path to the external backend. My front end configuration, so I need to give it a name. I'm going to call it external LB on port 80. I review and finalize. I see my backend services are fine. My host path and rules are fine. My front end is fine. So I'm going to go ahead and click create that load balancer. Once it's created, I should be able to copy the URL of that load balancer and hit both of those Debian web pages, whether it's instance 1 or instance 2. Now we can copy the IP and port of the load balancer, bring it up into a new window, and you'll see we hit an Apache 2 Debian default page. So I hope this video showed you how you can deploy an external load balancer with one external IP and hit both of your instances or multiple instances and be able to scale up and down those instances based upon demand. In this video, I'm going to show you how to deploy an internal load balancer for TCP and UDP requests. So I'm inside my Google Cloud Platform console. First thing I want to do is come up to the search bar and I'm going to type in load balancing. So I'll click the load balancing link and it'll bring me into my network services console where I can create my load balancer. So I'm going to go ahead and click create load balancer. And now we'll see our 3 options again. So we have HTTPS load balancing, TCP load balancing, and UDP load balancing. So I'm going to go ahead and choose TCP load balancing. So I'm going to click Start Configuration. Here's where I get to choose if it's an internet facing, so we'll have a single external public IP, or we'll have one single internal IP. I want internal, so I'm going to click only between my VMs, and it's going to be in a single region. So I click Continue. Now I need to give it a name and set up the configuration. So I'm going to call it Internal Load Balancer. And now I have to set up the back-end configuration and the front-end configuration. So my backend configuration, I'm going to set my region. So my region is in US East 1. My network is the default network. And here's where you see the protocol. So this is different from an HTTPS load balancer because now we have protocols. This is going to be a TCP protocol. Now we have to set our instance groups. If you're starting from scratch, you may not have any instance groups. So let's go ahead and create our instance group. So I navigate back over to the compute engine side, and then I come down to instance groups. So I go ahead and click instance groups, and I'm going to create an instance group. So that allows us to organize our VMs to use in load balancing, and it's great for scaling. So I'm going to call it instance group 1. It's going to be in a single zone. And remember, our load balancer is in US East 1, so we will set this in US East 1. An instant template. I have an instance template created. Basically, it's just a sample web server that I created a snapshot of. So if you don't have an instance template, you may have to go ahead and click Create a new instance template. You'll get a little pop-up here. And basically, it'll give you all your options to use a E2 medium, an E2 micro. If you have any boot disks, you can change your boot disks here. So I have some custom images, so I could use those if I wish. And I can click Select, allow HTTP traffic, and then go ahead and click Save and Continue. So you just created your instance template. Here's where the scaling comes in. So do we want to use auto scaling? We can have auto scaling on, auto scaling off, or auto scale only up. So we're going to turn on auto scaling to add and remove instances at 60% utilization. So if it gets above 60%, scale up. If it gets less than 60%, scale down. Predictive auto scaling is nice, but we need to run scaling for at least 3 days before it gets that historical CPU load that it can do the predictive auto scaling on. Our cooldown period is 60 seconds. We're going to go from a minimum of 1 to a maximum of 10 instances. And we have to create a health check. So let's go ahead and call this health check. We're using port 80, so we want to run the health check on port 80. We want to check every 10 seconds. A timeout is considered after 5 seconds of no response. If we get 2 consecutive successes in a row, it's a healthy threshold, and 3 consecutive failures is a non-healthy threshold. So I click Save and Continue. I click Create, and now that has created our instance group. So at this point now we have to go back to our load balancer, and once this is complete, select this instance group to be used in our load balancer. So once we see the green check mark, our instance group is ready. Now let's pop back over to the load balancer and put that instance group in. So now I'm back at my load balancer. Now it's time to get the backend configuration up. The thing is, you may have to do an F5 or refresh the page so it picks up that new instance group we created. So we'll refresh the load balancing page. We might have to put the name back in again. So I'll call it internal load balancer, and then I'll click backend configuration. I'll choose my region as US East 1, my default network. And for instance group, you'll see now I've got a drop down that says instance group 1. So I'll go ahead and click instance group 1. I'll choose the health check, which we created of port 80. And I can turn on session affinity. So do I want to keep the client IP, the IP and the protocol, or the IP port and the protocol? I'm going to choose client IP and protocol. Under advanced connections, we've got connection draining and a failover policy. So I'm happy with this back end. I'm going to click Done. Now my front end configuration. So front end load balancer. The protocol is TCP. My subnetwork is still going to be my default network. But my internal IP, here now it can be non-shared or shared. So shared can be used on a front end up to 50 times. Okay, so if I click shared, that means that I have to reserve a static shared internal IP address. So go ahead and click reserve static shared IP address. Let's call it load balancer IP static. It tells you to assign it automatically and click reserve. So now we can put this internal IP address on upwards of 50 front end. What ports do we want to use? We want to use port 80, but this is the beauty of the TCP UDP load balancers that operates on layer 4 and not the application layer. So if I wanted to load balance on port 80, port 3000, port 5539, I could do it here. I could just click multiple and use commas. In our case, we only need one single port. That's going to be port 80. We don't have global access. It's in one region. Going to go ahead and click done. And now our front end is configured. So we click review and finalize. We can take one last look and see if everything is the way we want it. Here's our back end. Here's our front end. Go ahead and click create. Now our load balancer should fire up. We should have one internal IP address for the load balancer, which routes to our instances. Those instances can scale between 1 and 10 instances as needed. So if I go ahead and click my internal load balancer now, it brings me in. I can see it. Right now it's firing up the instances, but I do have an IP and I do have a port. So 10.142.0.17 will now load balance over all my compute instances that are contained in my backend instance group. So I hope this video showed you how to set up that load balancer, how to use for multiple ports, whether you want to use it for port 80, port 443, or any other port that your systems may be sending information. In this video, I'm going to show you how to set up a network load balancer to distribute traffic to your VMs in the same region. Google Cloud's external TCP and UDP network load balancing is referred to as just a network load balancer, is used as a regional pass-through load balancer. So it'll distribute TCP or UDP traffic amongst your VMs. So the first thing we need to do is set up our appropriate compute VM engines. So we need to set up our backend instances. So I'm going to come to Compute Engine and I'm going to go to Compute Engine. So once I'm in the Compute Engine platform, we want to create some instances. So I'm going to go ahead and I'm going to click Create Instance. And I'm going to set the name of my instance to www1. I'm going to set the region to US Central 1 and the zone to US Central 1B. From here, I'm going to choose my machine. So it's going to be an E2 micro. And under boot disk, we want to make sure that we change our boot disk and it always has Debian GNU Linux 10. Now we come down and we select our management, security, disk, networking, and sole tenancy options. And here's where we want to include our startup script. So under management, we come down to our startup script field and we can paste in our startup script field. So let's take a look at it. It's just a bin bash statement with a sudo apt-get update. We're doing a sudo apt-get install Apache 2. We're restarting the Apache 2 service and we're creating a simple index.html web page. Now we come back up under networking and we want to have a network tag. So we want to populate the tags field here. We want to make sure we allow HTTP traffic. And we want to populate our network tags field with network-lb-tag. And that's our tag that we'll use to know that this is our firewall rule for network load balancing. We can come down, leave everything else the same, and click Create. And now we have our first instance coming up. Now we want to create another instance. So we're going to create another instance just like that called ww2. We're going to make sure it's in US Central 1 and US Central 1B. It's of the E2 micro. And we have our boot disk is the same. We want to come down to firewall, allow HTTP traffic, expand our management settings. And in this time, under our startup script, we're going to paste in a little bit different of a startup script. So this startup script basically just has ww2 in the header. And we're only using 2 different startup scripts so we can see which instance we're hitting. Are we hitting ww1 or are we hitting ww2? Under networking, we'll give it the exact same tag. We'll call it the network LB tag. So let's type in network LB tag. Come down and we click create. And now we have 2 instances set up. At this point now we need to create the firewall rule to allow external traffic to these VM instances. So I'm going to come up and I'm going to type in firewall. And I'm going to click the firewall page. And I'm going to click create a firewall rule. I'm going to give that firewall rule a name of www-firewall-network-lb. I'm going to select my default network. I'm going to come down under targets. And I'm going to select specified target tags. And here's where we put in the target tags that we specified earlier when we create our instances. So this will tell Google to apply this firewall rule to any instance that has this network tag. We come down under source IP ranges. We want 0.0.0.0/0 because we're going to accept traffic from the internet. And under protocols and ports, we're going to specify our protocols and ports. We're going to check TCP and we're going to open up port 80. Let's go ahead and click create. Creates the firewall rule. Now let's come back to our compute engine and let's get the external IPs of these compute instances. So I have ww1, its compute instances here. So if I go to that website, you can see it says ww1, and if I go to the ww2 website, it says ww2. So we have 2 working VMs here now. So now let's configure the load balancer. So I'm going to type in load balancing, come up to my load balancing networking services, and I'm going to click create load balancer. Under TCP load balancing, I'll click start configuration. And we want an internet facing. So from the internet to my VMs to a single region only. And we want to choose a target pool or target instance in this case. Let's go ahead and click continue. Now we have to give it a name. So I'm going to give it a name of www-network-lb. I'm going to click backend configuration. I'm going to select my region. So make sure we select the same region our instances are in. So US Central 1. Under backends, I'm going to click select existing instances. And I'm going to add instance 1. And I'm going to add instance 2. So www1 and www2. We're not going to have any backup pool. Our health check, we can go ahead and click create a health check. We'll call it basic-check. It's on port 80. We check every 10 seconds with a timeout of 5. 2 consecutive successes is a healthy instance, while 3 consecutive failures is unhealthy. So I go ahead and click save and continue. Now we need to select our front end configuration. So we give it a name. I'm going to go ahead and call it LB-IP-1. Our protocol is still going to be TCP. Under IP address here, we're going to click create IP address because we want to reserve a new static IP address. So I'm going to call this LB-IP and click reserve. It's now reserving my external IP address. Here it is, 35.223.42.191. And under port, we want port 80. So I'm going to go ahead and click done. I review and finalize. Everything looks fine. Here's my front end, routing to my back ends. I click create, and it goes ahead and starts to create my network load balancer. Once it's complete, you'll see the green check mark. I'm going to go ahead and click the name. I'm going to come in. You can see my backends are up. I'm going to go ahead and I'm going to copy my IP address and my port, and I'm going to paste it into a browser window. And you can see this time it worked. I hit ww1. Now this time when I refreshed, I got www2. So I hope this video showed you how to create that network load balancer and using a single external IP address, route your traffic to your internal instances using layer 4. In this video, I'm going to demonstrate how to set up SSL proxy load balancing under a single external IP address. So some prerequisites here, you'll see I have 4 instances created. I have 2 created in Central 1B. They're named Central 1-1 and 1-2. And I have 2 instances in US East 1B. And they're called East 1-1 and East 1-2. They all have external IPs. And when you navigate through their external IPs, a web page displays just their name. So it's just a way for us to see which instances we're hitting on our load balancer. Right, so that's a little bit of a prerequisite to setting up this proxy load balancing. Once we have our 4 instances created, we need to create an instance group. We need to create 2 instance groups. So come down to the left and create instance group. We need to have 2 instance groups, one for each zone that we're in. So I'm going to click create instance group, and I'm going to scroll down to a new onManage instance group. And I'm going to call this instance group East IG1. I'm going to change my location to US East 1. And the zone is US East 1B. I specify my port mapping name. So I give it a port mapping name of SSL-LB. And the port is going to be 443. I come down under VM instances and I choose my 2 East instances. So East 1-1 and East 1-2. So now I have this instance group set up with port 443 and both of my instances. So I'll go ahead and click create. Next, we need to create another instance group for the instances in Central. So I'll go ahead and click create instance group and I'll follow the exact same steps as before. New onManage instance group. I'm going to call this US Central IG. The region is in US Central 1. The zone is in US Central 1B. I specify my port mapping name, SSL-LB. Port number is 443. I leave my network, my default, my subnetwork is default, and then I add my 2 central instances. So I've added 1-1 and 1-2. So I go ahead and click create, and my 2 instance groups are set up. We now have an instance group in each of the regions. Each of these instance groups have 2 instances. So once these are finished, and we can see both of these instance groups, they're ready. They have the green check mark. Let's configure our load balancer. So I'm going to go ahead and select load balancing. I usually search for it. I click load balancing. I click create load balancer. And under TCP load balancing, I want to click start configuration because this offers us the SSL proxy. So I click start configuration. Under the internet facing or internal only, I want to choose from the internet to my VMs. And for multi-regions or single region, we want multiple regions. So I'm going to go ahead and click continue. I'm going to give my load balancer a name. So I'm going to call it my SSL-LB. Now I have to set up my backend configuration. So my backend configuration, I'm going to set as an instance group. Our protocol needs to be changed to SSL, and the timeout can be left as 30 seconds. So now we have to choose our backends. So I'm going to come down for the backend. I'm going to choose the East 1G instance group. The instance group has a name port for 443. I'm going to use the existing port name. The balancing mode is going to be utilization. and the maximum backend utilization is going to be 80%. So from here, I'm going to go ahead and click Add Backend so I can add the second backend. And this backend is going to be Central. So I'll click Central. Port numbers are 443. Everything stays the same. I can go ahead and click Done. Now I have two backends, East 1 and Central, and they're both using port 443. So now I want to configure my front end. So my new front end, I'm going to give it a name. I'm going to call it my SSL forwarding rule. I'm going to set the protocol to SSL. Under my IP versioning, I'm going to set the IP address to IP4, and the IP address itself, I want to create a static address. So I'm going to call it SSL IP, and I click reserve, and it reserves a static external IP address for me. I want to leave the port to 443, and here would be any certificates. So in this case, I need to create a new certificate, and I'm going to call it my LB certificate. I'm going to create a Google Managed certificate, and I'm going to put my domain, richardkspencer.com. So I go ahead and click Create. It creates my certificate for me, and I can apply it to this load balancer right away. So I click OK. My certificate is there. My SSL policy is set to GCP. I can change this if I want, or I can leave it as it is. I'm going to go ahead and click Create a Policy. I'm going to give it a name of my SSL policy. I'm going to make sure the TLS 1.0 is the minimum. And under Profiles, I'm going to select Modern. And this gives us all our enabled features. So I'll go ahead and click Save. I'll review and finalize. Everything looks fine. I'll click Create, and it will create my load balancer now. So it's in progress. The wheel's spinning. When it's done, you'll see your green check mark. Now we've got our green check mark. I'm going to click my SSL LB, go in, take a look. I can see my port, so I can just copy my port and the IP here. So now when your domain provisions and your certificate provisions, which can take some time, you can copy your IP and your port in your web browser, and you can hit those web pages on a secure web browser through the SSL load balancer. In this video, I'm going to show you how to deploy an external TCP load balancer for traffic into your VMs. So this external TCP load balancer is a managed external pass-through layer 4 load balancer, and it'll distribute your TCP or UDP traffic from the internet amongst your virtual machines. So they pass through, meaning that load balance packets are received by the backend VMs with their source IP unchanged. Load balance connections are terminated by the backend VMs, and TCP responses use the direct server return. It's important to note that the scope of a network load balancer is regional and not global. So let's take a look. I'm going to come in right now under my compute. I have under instance groups, I have two instance groups. These instance groups are named East IG1 and US Central IG1. So I have two instances in an instance group in the US East region and two instances in an instance group in the US Central region. So now I'm going to create my load balancer. So I'm going to type in load balancing up in the search bar. Go ahead and click load balancer. Now I can create a load balancer. So any load balancers I've already created will be here. I'm going to go ahead and create a load balancer. So I'm going to go ahead and click create load balancer, and it brings me into my options. So I got an HTTP, TCP, and UDP. We're going to use the TCP load balancing TCP proxy. So I'm going to go ahead and click start configuration. It's going to ask me, is it internet facing or internal only? It is internet facing from the internet to my VMs. It's a single region only, and we're going to route it to a target pool or a target instance. So I'm going to go ahead and click continue. And I'm going to call my load balancer TCP-LB. Now I have to set up my backend configuration. So I know my backend configuration is located in US East 1. And I'm going to select existing instances. So I could select instance groups, or I could select existing instances. So I click select existing instances, and I add my 2 instances that are in East 1. So I add East 1-1 and 1-2. My health check, I can create a health check. We'll call it TCP HC, and it's going to check on port 80 with the health criteria to check every 10 seconds. A timeout is 5 seconds. 2 consecutive successes is healthy, and 3 consecutive failures is unhealthy. So I'm going to go ahead and click save and continue. Now I'm going to check session affinity, and I want to preserve the client IP. I go ahead now and click front end configuration. Here's my front end. So I'll say TCP-front end. It's going to be a TCP protocol. My IP, I want to create a static IP address. So I'm going to call it TCP IP1 and reserve that static IP address. And I leave it on port 80. So I go ahead, review and finalize. Everything looks fine here. I go ahead and click create, and it creates my load balancer. So that load balancer now will load balance over those 2 VMs that are in the US East region. And now you're wondering, why didn't we load balance over the ones that were in US Central? Well, the reason being is that this is a regional, not a global load balancer. So if I'm in the US East region, then I can load balance to my US East instances. But if I want to load balance to my US Central instances, I have to create another load balancer in the US Central region. So we have our TCP load balancer in US East 1. I can go ahead and click it. You'll see I have my IP and my port here. So I can copy my IP. I can paste it into a browser window, and I get one of my instances back. So it load balanced, and it sent me to instance 2. The next time, it may send me to East 1-1, right? It's all dependent on how the load is going and how it wants to distribute the traffic. Right now, very low traffic, so I seem to be hitting East 1-2 more. If I had more traffic, I'd eventually hit East 1-1. So I'm going to come back to my load balancer again and just take one quick look over it and make sure everything is fine. It looks to be going fine. It's directing traffic to my VMs. So I hope this video showed you how to create that external TCP load balancer and to understand how different it is from an HTTP external load balancer. Even though we're both using port 80, the load balancer for the TCP operates on layer 4, right? So it terminates the connection at the back end. The responses from the back end go directly to the clients and not back through the load balancer. So there is some differences when you're looking at the proper load balancer to use for your implementation. In this video, I'm going to show you how to distribute traffic to applications running on backend instances using a network endpoint group. So a network endpoint group, or a NEG, is a configuration object, and it specifies a group of backend endpoints or services. One major use of this configuration is when you deploy services in containers. You can use NEGs as backends for some load balancers, which we'll do right now in this demonstration. We're going to use a zonal NEG, and that'll contain one endpoint, and that's a compute engine VM with a container deployed. So if I look under my VM instances, you'll see I have one instance running. So if I copy the external IP and paste it in a different browser window, you'll see I get the Nginx default web page. This was deployed as a container on my VM instance. So I'm going to come back now to VM instances, and I'm going to create a network endpoint group from this containerized instance. So under Compute Engine, I'm going to come down and I'm going to find Network Endpoint Groups, and I'm going to click it. That brings me into the Network Endpoint Group console page where I can go ahead and create this network endpoint group. So I'm going to click Create Network Endpoint Group. And the first thing I need to do is give it a name. So I'm going to call it LB-NEG. So Load Balancer Network Endpoint Group. I'm going to use this network endpoint group behind the load balancer. The network endpoint group type is going to be zonal. And the network itself is going to be my default network. My subnetwork needs to be in the same network and region that my instance is, which is US Central. So I'm going to come down, I'm going to find US Central 1, and I'm going to click my zone, which is going to be US Central 1A. My default port in this case is going to be 80, but if I was serving traffic on that container on any other port, say port 8080 or 3000, I could put that in here as well. So I'm going to go ahead and click Create, and that creates my network endpoint group. Now I have to add the network endpoints to it. So I'm going to click the LB-NEG name, and I'm going to come down to Add Network Endpoint, and I'm going to click Add Network Endpoint. Now I need to add the VM instance. So under the drop-down, you'll see I have instance 1. This is my containerized instance. I click it. You can see it's here. Now I need to add the network endpoint. So here's where you can check your primary IP address. So I'm going to click the drop-down arrows. I see my primary IP is 10.128.0.9. So I'm going to add a new network endpoint on this instance at 10.128.0.9, and the port is going to be port 80. But if I was also serving traffic on port 3000, I could add that here as well. I'm going to leave it at port 80. My container is only serving instances on port 80. I'm going to go ahead and click Create. It now creates my network endpoint group. So the last thing I need to do at this point is to put a load balancer in front of it. So I'm going to come up to Search. I'm going to type in Load Balancing, and I'm going to go to the Load Balancing page. From here, I'm going to click Create Load Balancer. I'm going to choose an HTTPS load balancer. So I click Start Configuration. It's going to be from the internet to my VMs. So I'm going to click Continue. Now I need to give it a name. So I'm going to call it Load Balancer. It's a simple generic name for now. And set up my backend configuration. So my backend service is in buckets. I click the drop down. I go to Backend Services. It asks me to create a backend service. So I'm going to go ahead and click Create a Backend Service, and it brings me in to my backend service page. I need to give it a name, so I'm going to call it LB Backend, and the backend type in this case is going to be a zonal network endpoint group like we just created. So I'm going to click Zonal Endpoint Network Group. My protocol is HTTP. Now I have to choose the actual network endpoint group we created. So I hit the drop-down box. I select our network endpoint group. I have to give it a maximum number of requests per second. So I'm going to give it 10 requests per second per endpoint. When I come down, I'm going to come down to health check. I need to create a health check. So I'm going to call it LBHC. And it's going to check for the health on the serving port, which in this case is port 80. With the regular health criteria, check every 10 seconds. A timeout is 5 seconds. 2 consecutive successes is healthy, and 3 consecutive failures is unhealthy. I'll click Save and Continue, and then I'll create my front end. Then I'll create my back end. My host path and rules, you'll see they're already created. I could make it more advanced if I had multiple containers running. I'm going to leave it simple host and path rule. Anything unmatched for any path sent to that backend. In my front end configuration, I'm going to call it LB front. The protocol is going to be HTTP. My IPv4 could be ephemeral, or I could take a static public IP I already had or create a new static public IP. I'm going to click Create IP Address. I want to call this NEG-IP. So I click Reserve. You'll see now it gives me a static public IP address, and it'll populate it for me. I want to serve it on port 80. I'm going to click Done. My front end is configured. I click Review and Finalize. Make sure everything looks fine. The back end services look fine. Host path and rules, and the front end. I go ahead and click Create. And now I wait for the load balancer to create. After that, I should be able to paste the address of the load balancer and hit the Nginx container on my VM instance. So now I can go ahead and click my load balancer, find my public IP, and I can paste this in a new browser window, and I should hit my Nginx container. So this containerized version of Nginx is accessible from my VM instance and from my load balancer instance, all through an NEG. So I hope this video showed you how to create a network endpoint group and place it behind a load balancer. And this is great, especially if you're using containers, and these containers are serving traffic on multiple ports. So get in, create a network endpoint group from your containerized instance, and check out this load balancing feature. So in this course, we've examined the Google Cloud load balancing. We did this by exploring how to identify load balancing components, choosing a load balancer for your implementation, managing access control for cloud load balancing using IAM, and running and scaling services behind internal and external HTTPS and internal VM instances. We also looked at distributing traffic to VMs using a network load balancer, distributing SSL and TCP traffic to VMs, and distributing traffic to applications running on back-end instances. In our next video, we'll look at implementing the Google Compute Engine. So let's jump right into virtual machine instances. What are virtual machine instances? Well, you'll hear instance a lot. An instance is just a virtual machine hosted in the Google Cloud. We can create these virtual machines using the Google Cloud Console, the gcloud command line, or the Compute Engine API. Compute Engine instances. So we can create Compute Engine instances. They can run on Linux and Windows Server public images. So things like Ubuntu or Windows Server 2016. We can create an instance, fine-tune it to exactly how we want it, and create custom images from that. We can also use Docker containers. So if we want to containerize our application, we have that opportunity with the Compute Engine instances. And of course, container optimized operating systems in the public image space. So we can deploy Docker containers, and they're automatically launched on instances when we use the container optimized operating system public image. So how do we decide which machine is best for us to deploy our virtual machine on? So we can choose a lot of different machine properties. Some of these are the number of virtual CPUs, how much RAM or memory does your machine going to have, predefined machine types, and custom machine types. So there's predefined machine types for things like big data, but there's also custom machine types. If we want to create a custom machine type that'll fit our workflow, then we have that option as well. So we have to take into account number of virtual CPUs, the number of RAM, and really what our workload is going to be on these machines. Right? We don't want to over provision, but yet we don't want to under provision. So a machine type is a set of virtualized hardware resources, and they're available to a virtual machine. In the Compute Engine, machine types are grouped and curated by families for different workloads. So we have workloads like the E2 type machines. These E2 type machines are cost optimized VMs. They offer up to 32 virtual CPUs and up to 128 gigabytes of memory, with a maximum of 8 gigabytes per virtual CPU. So these are your cost optimized VMs. They can be done and used on a lot of different resources. You also have your N2 machines. So these offer up to 80 virtual CPUs, 8 gigs of memory per virtual CPU. These are higher level machines. Maybe you're using it for some form of data engineering or machine learning. You also have N2D machines. These offer up to 224 virtual CPUs, 8 gigabytes of memory per virtual CPU, and they're available on a second generation AMD. And you also have N1 machines. So N1 machines offer up to 96 virtual CPUs and 6.5 gigabytes of memory per virtual CPU. So there's a lot of different machine families for you to choose from, and it really all depends upon what you're trying to accomplish. We can also break down machine types by usage. So things like memory optimized machine types. They're great for memory intensive workloads. Compute optimized. So these give you the most highest performance per core on a compute engine, and they're optimized for compute intensive workloads. Accelerator optimized machine types. These are ideal for massively parallelized compute workloads, such as machine learning, and shared core machine types. These are available in the E2 and the N1 families. These machine types timeshare a physical core. So this can be a cost-effective method for running small, non-resource intensive applications. So how do we integrate our instances? Right? So each instance belongs to a project. A project can have one or more instances. Storage options. So by default, each compute engine instance has a small boot persistent disk that contains the operating system. When applications are running on your instance and you require more storage space, you can add additional storage options to your instances. We can take advantage of containers. So the compute engine instances support a declarative method for launching your applications using containers. You can create a VM or an instance template and provide a Docker image name and launch configuration. And networking capability. So each network interface of your instance is associated with a subnet of a unique VPC network. So they can all speak to each other, and they all have to be integrated with root tables and the like so they can speak to each other, but they are completely networkable virtual machines. Instances and access management. So we can manage access to our instance using one of the following methods. So if we're dealing with a Linux machine, we can manage instances using the operating system login. So that allows us to associate our SSH keys with our Google account or our Google Workspace account. And then we can manage the admin or non-admin access to instances through the IAM role. We can also manage our SSH keys in a project or in the instance metadata. And that'll grant admin access to instances with metadata access that don't use operating system login. And with Windows Server, we only have one option, and that is to create a password for a Windows Server instance. So depending on what flavor you're deploying to your virtual machine, your instance management and your access management may look a little different. Now let's discuss the virtual machine instance lifecycle. So a virtual machine has a lifecycle from the beginning of its creation right through the end of its potential deletion. And that VM that you create will transition through many states as a part of its lifecycle. So when you create a VM, our first initial stage is a creation stage. Next, after those resources are provisioned, the VM will move into a staging stage where it prepares to boot for the first time. During and after startup, your VM is then in the running stage. During its lifetime, a running VM can be stopped and restarted, or eventually suspended and resumed. A VM can be in one of the following states. It can be provisioning, so resources are being allocated for the VM, but the VM is not quite running. Staging, resources are acquired and the VM is preparing to boot for the first time. Running is when the VM is booted and up and running. Stopped is when the VM is stopped. You requested a stop or some type of failure occurred. This is a temporary status after which the VM will enter the terminated status. Repairing. So the VM is being repaired. This will happen when the VM encounters an internal error or the underlying hardware is unavailable due to maintenance. Terminated is when the VM is stopped. You can leave it stopped and restart it later. Suspending is when the VM is in the process of being suspended and you suspended the VM yourself. And suspended is when it actually reaches that suspended state. From there, you can resume the VM or delete it. Some considerations for stopping or suspending a VM. So you can stop or suspend a VM if you don't need it, but if you want to keep the VM for future use. When you suspend or stop a VM, you must consider the following. It doesn't cost anything to suspend or stop a VM. Costs are incurred for any attached resources. That may be static IPs, that may be persistent disk data. Ephemeral or temporary external IPs will be released. When you restart or resume the VM, Google will assign these new temporary external IPs for your instances, but your static external IPs are retained. So if you create and provision a static external IP, that will be retained after a reboot or after a stopping or suspending of the VM. Stopping a VM. So when you stop a VM, it'll cause the compute engine to send that shutdown signal to your virtual machine. Most modern operating systems will perform a clean shutdown before powering off, and the compute engine in Google Cloud will send the ACPI shutdown signal to the virtual machine. Once this happens, the compute engine will wait briefly for the guest to finish shutting down and then transitions the VM into the terminated state. Suspending a VM. So when you suspend a VM, it's similar to putting the system to sleep. The compute engine will send the ACPI S3 suspend command, and then the VM will transition into a suspended state. You also have an opportunity to reset a VM. So you can reset a VM to wipe the memory clean and reset it back to its initial state. Resetting a VM causes an immediate hard reset. However, the VM properties are maintained and the VM retains the disk data. The VM will also remain in the running state throughout the reset, so you're avoiding a lot of downtime. And finally, checking the VM status. So every VM will report its status as part of their VM properties. So check a VM status in the following circumstances, such as you're experiencing some issues with the VMs, or you just started the VM and you want to confirm that it's running. So if you're using the command line and you want to list all VMs and statuses, you can just use the gcloud compute instances list command. Or if you want to list status of a specific VM, you can use the gcloud compute instances describe and then input the instance name that you want to see the status of. In this video, I'm going to demonstrate how to create and start a VM instance from an image or a snapshot. So in this case, we're in our Google Cloud platform. We're on the main console page for my web app, I want to come in and type in compute. We want to go to the compute engine. So I'm going to go ahead and click compute engine. And this is where we create our virtual machines. So you'll see right now I have none running. If I did, you would see them here with the name, what zone they were in, any IP addresses. So I can come down here on the blue button and click Create Instance. Or I can come up here on the ribbon and click Create Instance. They both bring us to the same page. I'm going to go ahead and click Create Instance. Brings me to a new page where I have to specify things like labels, machine types, okay? So the first thing we have to do is give it a name. It defaults to instance 1. I'm going to leave it as instance 1. It's fine. Next, we choose a region. So what region do I want to launch this virtual machine? So in the drop-down, I'm going to pick the one closest to me, which is US East. You can pick the one closest to you, and you'll see the zone gets set by default, but you can change this as well. So I'm going to leave it in US 1B. Then I come down to my machine configuration. So here's where we decide what machine family we want. So we have the E2 series, the N2, and the N2D. These are all our second generation machines. There are first generation N1s, but you want to stick to the second generation. So I'm going to take E2. E2 is a general all-purpose machine. And I'm going to take a machine type of E2 Micro, just for this demonstration. So E2 Micro gives us 2 virtual CPUs and 1 GB of memory. So I go ahead and click E2 Micro. I can come down and expand the CPU platform and GPU. So here it asks me, what CPU platform do you want? I need automatic. That's the only option we have with this machine type. Do I have any GPUs I want to add? We don't. Can I turn on a display device? All right, if we want to do some screen capturing on the VM. Here's where we can enable the confidential computing service, or we can deploy a container image to this VM instance. Both of these we'll get into a little later. Next, you have your boot disk. So this is your boot image. What do you want to use as an image to boot this VM instance? So right now we're using Debian GNU Linux 10. I could change this. I could change my operating system to Windows, Ubuntu. I can use custom images, snapshots, or existing disks. Since we have nothing, I'm just going to use a public image. I'm going to use Debian. It's going to be Debian Linux 10 with a balanced persistent disk type of 10 gigabytes. So I go ahead and click select. I come down. Here's some security, so identity and API access. What service account do we want to apply to this VM? So the Compute Engine default service account. Service accounts allow the VMs to contact and interact with other services in your Google Cloud platform. All default access scopes for the Compute Engine default service account. We can allow HTTP traffic or HTTPS traffic if we wish. And if I click Management, Security, Disk, Networking, and Sole Tenancy, I get a little drop down here where I can set more options. So, do I want to enable deletion protection? Do I want to use reservations? Do I want to use a startup script? So I can put a startup script here that will automatically install Nginx, for example. And, of course, any metadata. So I can create a metadata, said created by, and the value as Richard. And it's a good idea to set metadata so you can see who's creating what resources. We have preemptive. So if you want to use a preemptive VM, they're much cheaper, but they only last you 24 hours, and it can be terminated sooner than 24 hours if Google needs that infrastructure back. On-host maintenance. When the Compute Engine performs periodic infrastructure, it can migrate your VM instances to other hardware, right? So we can migrate it or we can terminate it. We want to migrate it. We don't want to lose anything. And the automatic restart is turned on. So if the machine gets terminated and it wasn't a user-initiated action, then it'll restart. So I'm going to go ahead. I'm going to click Create. You'll see it starts creating my instance 1. Now it brings me back to my VM instances page, and you can see I now have one instance, and it's now spinning up. Now it has my green checkbox. My instance is up and complete. I have an internal IP of 10.142.0.21, and I have an external IP of 35.196.184.70. So I hope this video showed you how to go in, create your first VM instance, and use it for whatever you may need, whether it's a web server application or if it's doing some type of workload, right? I hope this video kind of gave you some insight on how to get into the Google Cloud Platform and set up your virtual machines. In this video, I'm going to show you how to create a virtual machine using gcloud. So when you use gcloud, generally they'll be used in cases where you want to create instances using scripts. Right? For this video, we're just going to use a simple demonstration to create a simple instance with the default values. Then I'll show you a command that can give you all the additional values that you can add when you create your instance. So the gcloud is a command line tool. It's available from Google. We installed it on our systems, or we can use the Google command shell, right, which may have many packages pre-installed. For our purpose, we're using the Google command shell or the gcloud. So I open up the Google Cloud SDK shell, and now I want to create a virtual machine. So all I need to do is type in gcloud compute instances, create, and I'm going to say instance 2 in this case, and then I specify a zone of US Central 1C. So we're just saying gcloud is that needs to be before every command. Compute instances, create instance 2 in the zone of US Central 1C. So I go ahead and I hit enter. We wait a few minutes because it is indeed firing up an instance in the background for us. And you can see now, just being able to do this via script, we can really scale this up and create a ton of instances easily by just running one script. So you can see it came back, instance 2, US Central 1. My machine type is the default because I didn't specify it. So it's N1-standard 1. I have an internal IP, I have my external IP, and it is running. So now that we created an instance using gcloud, let's look at a few more commands I can run to, view what instances I'm running, display a VM instance details, and so on. So let's say I want to see, for example, all the instances I'm running. I could type in gcloud compute instances list, and it'll give me a full list of all my instances. I can take it even a step further and say gcloud compute instances describe, and then I put in the name of my instance. So in this case, I can say instance 2. I hit enter, and it brings me back all the information about this instance. Now finally, let's look at all the different commands we can run for compute instance. So I'm going to type in gcloud compute instances -- help. Once I hit enter, I get the help page back. So this is your go-to area to find all the commands that you need to customize your instances. So you'll see down the bottom, our commands have started. We're only at 23%. So if I hit space, I get a new page. These are all the commands. So we've used create, right? We've used gcloud compute instances create. We could use create with container. We can delete our images. We can attach disks. So gcloud compute instances attach disk. We can detach disks. We can describe, which we did. We can list. We can move instances. We can remove the metadata. We can update a virtual machine. So all of these are available from the command line itself. So if you plan to use gcloud and compute instances, it's a great idea to familiarize yourself with all the additional commands when creating a compute instance in gcloud. So I hope this video showed you how to create a VM using gcloud, how to view all your VMs, and then take it a step further and get a little bit more descriptive information about the VMs, all using gcloud. In this video, I'm going to demonstrate how to create and start a preemptible VM instance. So it's important to know that these preemptible VM instances should only be used for fault-tolerant applications that can withstand instance preemptions. So it should be able to shut down, spin up a new instance, and just continue working. So it needs to be a part of a fault-tolerant application design. So you have to make sure your application can handle these preemptions before you create this preemptible instance and save yourself some money. So first thing we want to do is come into Compute Engine. So we're going to type in Compute Engine at the top, click Compute Engine, and it's going to bring us into the regular screen that we used before to create a VM instance. Preemptible instances require available CPU quotas, just like regular instances. So to avoid these preemptible instances consuming the CPU quotas for your regular instances, you can request a special preemptible CPU quota. After your compute engine will grant you that preemptible CPU quota in your regions, any preemptible instances you create will count against that one CPU quota. This does not include your regular instances. They will continue to count against your regular CPU quota. So we're going to go ahead and click Create Instance. We're going to go ahead and call this one Preemptive. So I'm just going to type in Preemptive, and I'm going to leave it in US Central 1, and it's going to be in US Central 1A. I'm going to choose an E2 series, the machine type of E2-micro, and I'm going to come all the way down to Management, Security, Disks, and Networking. So once I click there, you'll see Management. And here's where it allows us to set our preemption. So if I come down to preemptibility, right now it's turned off. I'm going to turn it on. So now this VM is a preemptible VM. It can be shut down at any time. And that's why it's important that your application do have fault tolerance. But we're also going to add instance metadata or a startup script. So it's a shutdown script that we can add to our running preemptible instances that will add a new preemptible instance when you create it. So this script runs when the instance starts to shut down. So once that preemptible instance is shut down, the script we're going to paste in now will begin to run before the operating system's kill command. After gracefully stopping that program, the script performs a parallel upload of a checkpoint file to a cloud storage bucket. So I'm going to paste in this script, very large script available on the Google's website. But you'll see it sets your program, your user, your checkpoint. It echoes as shutting down. Then you can find the newest copy of your program and spin it up on a new preemptible instance. So right now, everything seems to be fine. I'm happy with how everything looks. I'm going to go ahead and click Create. So it creates my preemptive instance. We can see that it's named Preemptive, and it'll spin up within a minute. So now it is spun up. It says Preemptive. How can we check just to be sure that this is a preemptive instance? I'm going to click the SSH button. I'm going to SSH into this instance. And I'm going to run a command. It's just going to be a curl command on the instance metadata to see if the preemptible value is set to true. If it is, then the instance is preemptible. So once I connect to my SSH server, I paste in my curl command, and you see it comes back true. So as soon as I pasted it in, it ran it, and it said true. So that means that this instance is a preemptible instance. So I'm going to go ahead and come out of the SSH window, leave. I'm going to highlight my preemptive instance. I'm going to come over to the three dots, and I'm going to click delete. Once I click delete, that should remove my preemptive instance. So I hope this video showed you not only how to create that preemptive instance, but why it's important to understand that you need a fault-tolerant application before you start to take advantage of these preemptible instances. In this video, I'm going to demonstrate how to create a Windows Server VM instance in the Google Cloud Platform. So once I'm on the dashboard for my project, I can come down to Compute Engine, and I can click the Go to Compute Engine button. So I'm going to go ahead and click it. It brings me into my VM instances. So you'll see I already have one instance. I'm going to go ahead and create the Windows instance. So up on our top bar, you'll see the Create Instance button. Go ahead and click that Create Instance button, and we'll be brought into our Create Instance console. So first thing we need to do is give it a name. I'm going to call it Instance-2-Windows, just so I can easily identify the Windows Server. You'll notice there is a monthly cost to the Windows instances. They do not come with any free trial. I'm going to choose my region. I'm going to leave it in US Central 1, and my zone is going to be in US Central 1A. My series is going to remain E2, and my machine type is going to be an E2 small, so 2 virtual CPUs, 2 gigabytes of memory. So now I can come down. I have options here to enable confidential computing or deploy a container. But here's where we make our changes. So you'll see a big change button. Let's go ahead and click the change button under boot disk. And here's where we can choose between public images, custom images, snapshots, or existing disks. We want to launch a Windows Server, so we're going to use a public image. And we'll use the operating system drop down to come all the way down and select Windows Server. And now our version drop-down changes with a list of available options of Windows Server. So if I click the drop-down, you'll see I can have Windows Server 2004 all the way up to 2019. I'm going to go ahead and choose Windows Server 2016 Data Center. So I choose my version. My boot disk type is a balanced persistent disk. If I click the drop-down, I can have an SSD persistent disk or a standard persistent disk. I'm going to leave it on balanced persistent disk with a size of 50 gigabytes. I'll come all the way down and select the big blue select button. Now we can see that our boot disk has changed to a Windows Server 2016 boot disk. So I'm going to come down. My service account is going to be the same. I'm not going to allow HTTP or HTTPS traffic. I'm not going to use this as a web server. I can expand management, security, disks, networking, and sole tenancy. I can look at some things in management. So if I want to enable delete protection to make sure this instance can't be deleted, I can go ahead and click Enable Deletion Protection. And if I wanted a preemptible instance, I can come down on the availability policy and choose preemptibility, and I can turn it on. So in this case, I'm going to leave it off, and I'm going to leave all the other default settings the same. I'm going to come down, and I'm going to click the blue Create button. So once I click Create, you'll see it's creating my instance, and now you'll see Instance-2-Windows now has a status of spinning, so it's actually in the process of acquiring the resources and provisioning my Windows instance on this virtual machine. Just like that, the instance is now running. Its zone is in US Central 1A. It has an internal IP of 10.128.0.3 and an external IP of 34.136.8.221. So I can go ahead and click the name of the instance if I want to view more details about this instance. So it shows me, here's my remote access, it's RDP. When I want to connect, I have to set the Windows password. My instance ID is here. The machine type that it was deployed on is specified. My CPU platform is Intel Haswell. If I scroll down further, it shows me my zone, and it shows me my creation time and my network interfaces. So I can come all the way up now. I can also click monitoring. And when I go into monitoring, I can see things like CPU utilization and network bytes. Nothing is available right now because these metrics take some time to actually build and send it off to the monitoring service itself. So if I come back to details and click the details link, here's where I can edit my VM. I can reset the VM, or I can create a machine image from this Windows VM. So I hope this video showed you how to go about creating a Windows virtual machine in the Google Cloud Compute Engine. In this video, I'm going to demonstrate how to provision a virtual machine on a sole tenant node. So we know that sole tenant nodes are physical servers that run VMs from one project only. So we want to go under the Compute Engine and go into the Compute Engine console. First thing we need to do is create a sole tenant node template. They're regional resources and they specify properties for our sole tenant node groups. So we want to come over to, on the left hand side, sole tenant nodes. Click sole tenant nodes. Then come up to the top and click create node group. So I'm going to specify a name for my node group. I'm going to leave it as node group 1. We have to specify a region. So I'm going to use US East 1. And my zone is US East 1B. So we have to remember that it will be necessary down the road. Now we come down and click continue. And now we're under the node template properties. So right now we have no node templates, so we have to create one. So click the create node template link. You'll get a pop-up on your side where we create our node template. So our node template, we'll just leave the default name as node template 1. For node type, we're just going to choose an N1 node, 96 virtual CPUs, 624 gigs of RAM. For local SSD, we'll leave it at GPU Accelerator. Then we come down and we click Create to create our node template. So our node template creates, and now it's visible once it's created under the node template drop-down. Once it's created, you can see it here. We go ahead and click Continue. And here's where we can do auto scaling. So I'm going to turn auto scaling on to add and remove nodes. So the minimum number of nodes will be 1. The maximum number of nodes will be 2. And they'll resize during periods of high and low load. Next, I click Continue. I figure out my maintenance settings. I want to leave my maintenance policy as default. And my maintenance window, I can set at any or from 0 to 400 hours. So I'm going to go with 0 to 400 hours. And I'm going to click Create to create my node group. Once the node group is created, now we can provision a sole tenant virtual machine. So you'll be back into the sole tenant nodes console. We want to click on the name of the node group that we want to provision a VM instance on. So I'm going to click the node group. You'll see all the details about the node group we created. Come up and click Create Instance. So here we go through the normal instance creation process, but it's tied to this sole tenant node group that we just created. So I'm going to leave the name as Instance 3, but I'm going to append it with node group just so I know which one. My region is populated, US East 1, and I'm in US East 1B. My general purpose, it's already filled in because it's based on my node group. So I can come down and leave everything the same. You'll see under sole tenancy, it's filled in with your node affinity label. So I'm going to go ahead and click create, and this will create my instance in a sole tenant virtual machine. So you can see it's spinning up. It may take a little while to spin up. It was a big instance. Once it's spun up, you can go ahead and delete it. But I hope this video showed you how to provision that sole tenant virtual machine so you can have virtual machines that run on dedicated hardware for your project. In this video, I'm going to show you how to create and upload your public key to the Google Cloud platform. So if you want to be able to use a public key for every instance on a project, here's a great way of doing this. So you can share that key, or you can put it in the metadata fields so that every instance in the project will use that key. So the first thing that we need to do is to create a new key. So I'm going to paste in my command to create the new key. So the command is ssh-keygen-t rsa-f, then the directory where we're going to save the file name and the file name itself. So it's the root directory.ssh/dev team key. So this dev team key is going to be the name of the key, -c and username. So the username is going to be dev team user, and that's the name of the user connecting to the VM. So I go ahead and I hit enter. It's generating my public and private RSA key pair. Now, do I want to enter a passphrase? In this case, I'm going to leave it empty. So I just hit enter twice, and you'll see we get words back that say our identification has been saved. Your public key has been saved in home richspencer.ssh/dev team key. So let's go and take a look at these keys. So I'm going to go cd/home/richspencer/.ssh. Once I'm in my SSH directory, I'm going to type in ls to view the contents of this directory. So you see I have the dev team key, which is my private key, and the dev team key.pub, which is my public key. So let's take a look at both of these keys. So if I go cat dev team key, I get an output of my private key. So you can see the begin, the open SSH private key, the big long private key. And I can also do the same for dev team key.pub. And now you can see this is my public key. So these keys always have to have a format of SSH-RSA, the key itself, followed by the user. So what we want to do now is to take this public key and bring it into our console and add it to our metadata. So go ahead and copy your public key. And let's go back to the Google Cloud console. Once I'm in the Google Cloud console, you'll see I'm in the compute engine under my project. So if I come down to the navigation bar on the left-hand side and I scroll all the way down, you'll see under settings, metadata. Go ahead and click metadata and you'll get a new window to your right, which then gives you the opportunity to put these public keys in. So you have two tabs. You have metadata and you have SSH keys up at the top on the title bar. So if we come and click SSH keys, here's where we can add our keys. So you'll see here, all instances in this project will inherit these SSH keys. So if I add a new SSH key here, then all instances in that project is going to inherit this SSH key as well. So I'm going to go ahead and click edit, and I'm going to go ahead and click add item. So here's where we enter our public SSH key. So I go ahead and I paste it in. You'll see that it starts with SSH-RSA. It has the full key and then the username. So I go ahead and click save. It saves my new SSH key. And I can also use this key now for every VM on the project. So I hope this video showed you how to create your SSH keys, how to locate them on your workstations, and how to upload these keys into Google Cloud Platform in the form of SSH key metadata. In this video, I'm going to show you how to connect to Linux and Windows VM instances. So you'll see that I'm in the Compute Engine console of my project, and I'm looking at all my VM instances. I have an instance 1 that's Linux, and instance 2 that's Windows. So let me demonstrate how to connect to both flavors of these VMs that you can launch. So for Linux, your method of connection is going to be SSH. So if I come over all the way over on the toolbar and under Connect, you'll see SSH. I'm going to go ahead and click the arrow for a drop-down menu. So once I click the SSH drop-down menu, I'm giving 5 options here on how I want to SSH into this machine. My first option would be to click the Open in Browser Window option. This is my simplest option. So when I click Open in Browser Window, you see I get a new pop-up, and it transfers my SSH keys into the VM, and I'll be prompted with a terminal window, just as I was using PuTTY or some other SSH client. Now you can see I'm logged in to the instance. I can run commands. I have full reign of this instance. When I'm done, I can just come up to the X and exit out that window. It asks me if I want to leave the site. I go ahead and click the Leave button. Now let's come back and look at a few more options. So if I click the drop-down arrow by SSH again, I can also open in a browser window on a custom port. So if I click that option, it's saying you can open SSH from the browser on a custom port. I get a pop-up window, and I can put in my custom port. So I can put in a custom port of 255. I can go down now and click Open, and it opens this SSH instance under port 255. And you see you get a little warning that says consider adding a firewall rule to allow ingress for port 255 in my case, because that's the one that I used. So once you're done, we can come up and exit out this button, and we can come back and look at our options again. So come back down to the triangle and click, and you can see we can open in a browser window using a provided SSH key. So I have an option here of open in a browser window using a provided private SSH key. So if I click this option, I get another pop-up window, and now I have to connect with an SSH key file that I would have generated earlier on one of my machines. So I'm going to go ahead and click Cancel. I'm going to come back, and there's another really interesting option. So if I click the drop down by Connect again, you'll see an option called View gcloud Command. If I click View gcloud Command, I get a pop-up window, and it gives me the command that I need to run in gcloud to connect to this instance. And it goes a step further and gives me an option right on bottom, Run in Cloud Shell, that if I click Run in Cloud Shell, my shell terminal window will provision, and I'll connect to my Google Cloud machine. As you can see on the bottom of the screen right now, I have a terminal window coming up, and it's provisioning the shell, and then I can connect to the instance automatically. So I'm going to go ahead and exit out of the Cloud Shell. I'm going to come back up now and look at our Windows instance. So unlike Linux, where you had to use SSH, Windows uses Remote Desktop Protocol, or RDP. So I'm going to go by RDP, and I'm going to click the drop-down arrow, and I'm going to look at what options we have for connecting to a Windows instance. So first thing we need to do is set a Windows password. So I'm going to go ahead and click Set Windows Password. It tells me if an account already exists, resetting this password can cause a loss of encrypted data. So the first thing I need to do is give it a username. What username do I want to connect to this Windows instance with? So I'm going to use Rich Spencer. I'll go ahead down on the bottom and click Set. It'll set your username, and then it'll give you your automatic password. So it generates your password for you, as you can see here in the pop-up bar. If you come all the way to the right, you see the 2 squares. Click Copy, and you can copy your password. So at this point, we set our password. I can go ahead and click Close. I can come back to my instance. On the drop down, I can now choose View gcloud command to reset a password if I ever wish to, or I can download the RDP file. So I want to connect. I'm going to click download the RDP file. I'll get a download. It's an RDP file for Windows. I go ahead and click save. I let it download, and you'll see it now. It's complete down in my downloads bar. I'm going to double click it. Now you'll see remote desktop opens. It says the publisher of the remote connection cannot be identified. Do you want to connect anyway? We do. So I'm going to go ahead and click connect. It autofills in my username. So Rich Spencer is my username. Now I paste in the password that I copied in a previous step. Now I click OK. You get another certificate error. So it just says there's no certificate and it's not from a trusted certificate authority. I'm going to go ahead and click yes, I want to connect despite these errors. So I click yes, configures my remote setting, and it brings me into my Windows Server 2016 instance. So I hope this video showed you how to not only connect to a Linux instance via multiple different methods, but how to also connect to your Windows Server instances as well. Now let's discuss instance groups. So instance groups are a group of VM instances that are managed as one entity. The compute engine in the Google Cloud Platform will offer two kinds of VM instance groups, managed and unmanaged. But the beauty of these instance groups is that it allows us to group a bunch of VMs together and we can manage it all as one single entity. Unmanaged instance groups lets you do multiple things. First thing it allows you to do is load balance. So you can load balance across a fleet of virtual machines that you manage yourself, right? So none of this is what they call managed. You load balance across your self-managed group of virtual machines. Some of the disadvantage of unmanaged instance groups. So there's no automatic scaling involved. There's no automatic healing. So all these services are offered when you do managed instance groups. Just like a lot of the managed services offered in the cloud, right? There's a lot of things like scaling and healing that are built into these managed services. Things like automatic updates you won't have in an unmanaged instance group. There's no multi-zone support. And there's no instance templates. So if you only need it to apply load balancing to a group of, say, web servers, it's great and it's simple low management. But there is quite a few disadvantages of using unmanaged instance groups. Now that being said, let's talk about managed instance groups. So managed instance groups allow us to run our applications over multiple virtual machines. You can make your workload scalable, so they can scale up and scale down based upon your workload. And that's automatically done, right? It's a managed service. You don't have to go in and manually scale up your instances and manually fire up new instances. It's done for you automatically. It's high availability because you can use multiple zones. You can spread your virtual machines across multiple zones to take advantage of high availability, and you have the automated NEG services that you can take advantage of. So when you use these managed services, there's a lot of extras that you can really avail of. Managed instance groups. So a managed instance group creates each of its managed instances, and it's based on an instance template that you create and any optional stateful configuration that you specify upon type of creation. Right? So we're taking these instance templates and some optional stateful configuration, and we're creating our managed instances from them. Some advantages of managed instance groups are high availability. So you can keep your VM instances running. If a VM in the group stops or it fails for any reason, then the instance group can recreate that VM in accordance to the original instance's specification. It can fire up a brand new instance just like the one that failed. Application-based auto-healing can be set up. So what that really does is that it does a health check and it periodically verifies that your application responds on the ports that you specify. The regional or multi-zone coverage allows for automatic failovers, right? You have that extra high availability now, and you can spread the load across multiple zones. And if one zone goes down, then we have another zone that can take its place. And that goes hand in hand with load balancing itself. We have scalability. So when our apps need to add additional compute resources, we can scale up, we can scale down, right, to meet the demand. We're not paying for idled resources, nor are we not provisioning enough resources to meet our demand. It's a perfect happy medium. You have automatic updates. So your managed instance group automatic updater will let you deploy new versions of software to your instances and supports a wide range of rollout scenarios, so rolling updates or canary updates, and stateful workloads. So a managed instance group is great for building these highly available deployments and automating the operation of applications with stateful data or configuration. These things can be DNS servers, old monolithic applications, databases, right? And these stateful MIGs preserve each instance's unique state on a machine restart, recreation, auto-heal, and an update event. Automatic healing. So managed instance groups maintain high availability by proactively keeping your instance available. So instances are meant to be kept in the running state. However, relying only on VM state may not be sufficient. Right? The VM may be up, but the application may be froze. So what do we do in these cases? And that's where the automatic healing comes in. If you have an instance that is not running, it'll automatically recreate those instances. But it can also check your application as well. So if your application should respond on a specific port and it's not, then it determines that it needs to perform auto healing and then probably recreate those instances to get that application back up. So if the application was froze or non-responsive, that's a way for the Google Cloud Platform Managed Instance Group auto healing to go and check and see if everything is fine. You can create two types of managed instance groups, regional and zonal groups. So your regional managed instance group deploys instances to multiple zones across the same region, and a zonal managed instance group deploys instances to only one single zone. It's important to note regional managed instance groups add higher availability because, as we talked about, you can spread the load across multiple zones, and that'll protect your workload if one zone happens to go down. So when should we use managed instance groups? You can use an MIG when you have stateless serving workloads like a website front end, stateful applications like databases, legacy applications, batch computations, and stateless batch high performance or high throughput workloads, say for image processing, for example. These are times to use the managed instance groups. In this video, I'm going to demonstrate how to create an instance template. So an instance template allows you to specify a machine type, a boot disk image, network, and a bunch of other instance properties that you want to use when creating virtual machines. So you set it once, put it in a template, and reuse that template as needed. So once you're in the Compute Engine console of the Google Cloud Platform, you want to come under Virtual Machines, and you'll see Instance Templates. So if I go ahead and click Instance Templates, I'm brought into the Instance Templates console. If I had any instance templates here, they would be listed here. I don't have them. I need to create one. So I'm going to click Create Instance Template. And now it gives me a name. So Instance Template 1. I'm going to change this. I'm going to call it Web Server. And basically, I just want to have a template of a Linux machine with Apache running. So I'm going to choose an E2 series. And I'm going to go with the E2 Micro as a custom machine. So what this is saying is that every time I launch an instance from this template, it's going to be an E2 Micro. I can also set other things in my instance. So my boot disk, my service accounts, everything that I would normally set when I create an instance the first time is the same thing when we create an instance template. And that's the beauty behind it. We only have to do this once we use an instance template. I want to allow HTTP and HTTPS traffic. And once I'm happy with it, I'm going to come in under Startup Script, and I'm going to paste in my startup script just to install Apache at boot. So I don't have to do that manually every time too, right? This instance has the machine, it has the network rules, it even has Apache installed. So I can reuse this as needed. So I'm going to leave everything else the same, and I'm going to go ahead and click Create. So you'll see it's creating my web server instance template. It's spinning up in the top right-hand corner. Once it's done, you'll see it turn green, and you'll have all the details about a machine type, the image, and the disk type. So just like that, it's done. I have my instance template here. Its machine type is E2 Micro. It's a Debian 10 Buster image, and the disk type is a balanced persistent disk. So I can come over to Actions now. I can create a VM from this instance template. So if I click Create VM, it brings me in. It even appends the name with Web Server -1. Everything is the same from my instance template, everything that I selected. Even if I come under Management, my startup script is still the same. So I'm going to go ahead and click Create, and it's going to create my instance now. You'll see it's Web Server 1, and once it's up, I should have a web server up and created that was based upon my template. So I'm going to go ahead and I'm going to copy the public IP. I'm going to paste that public IP into my web browser. And we can see that the Apache default page is now on this instance. So I hope this video showed you how to create your launch template and even to go as far as creating your first VM based upon that launch template. So go in, create your launch template, play around with the settings and make it perfectly right for you. And from there, you can start creating your virtual machines based on that template. In this video, I'm going to demonstrate how to create a managed instance group. So as you can remember, a managed instance group is a group of virtual machine instances that allows you to be controlled as a single entity. So you have features such as auto healing, load balancing, auto scaling, auto updating, and stateful workloads. So let's create our managed instance group. So when we're under our project, we need to go into the compute engine. So let's click the compute engine and get brought into our compute engine console. Over on the left-hand side, you want to come down, all the way down under instance groups and click instance groups. Here's where we can create our instance groups. Right now we have none. If we did, we'd see them here. So I'm going to go ahead and click create instance group. It gives me a name. So I have three options. I can create a new managed instance group for stateless and batch workloads. That auto scaling, auto healing, auto updating, multi-zone, and load balancing is supported. I can have a new managed instance group for stateful workloads such as databases. That comes with disk and metadata preservation, auto healing and updating, multi-zone and load balancing, or a unmanaged instance group, which only supports load balancing. I'm going to leave it on the new managed instance group. My name here is instance group. I'm going to change this to web server instance group. Now, here's where I get to choose my location. Do I want a single zone or multiple zones? I want multiple zones. I want to take advantage of multiple zone deployment. So my region is set to US Central. I can hit the drop down here and configure my zones. So I'm using 1B, 1C, and 1F. So I can on-click 1 to use 2. But like they say, if you want to maximize your availability, you should select 3. That way you have, in case of a zonal failure, you have 2 zones going still at one time. Our target distribution shape. So we're going to leave it at even. We're going to distribute our instances evenly across zones. Next, we have to specify an instance template. So we have an instance template called web server that we created that has Apache already installed on it. So if we didn't have an instance template, I could just create a new instance template. I'm going to use the web server one that we created. So I'll click web server. Then it asks me, what's the number of instances? So it's already set to based on auto scale configuration. Because under auto scaling, I have auto scaling set to on. I can have it on, I can turn it off, or I can only scale up. I'm going to leave it on, and my auto scaling policy is going to be at 60% utilization. So scale up when the CPU utilization is above 60%, scale down when it's below 60%. Predictive auto scaling can be used, but auto scaling needs to be running on these instances for 3 days, just so the predictive auto scaling can kind of see the workload and how much traffic you actually serve it. Next, we have a cooldown period. So how long for our app to initialize from boot time until it's ready to serve. We set it to 60 seconds. We can set our minimum number of instances to 1 and our maximum number of instances to 10. I can come down now under auto healing. So I can hit the drop down. You'll see some health checks already created. I can leave it at no health check, or I can click create another health check. So I'm going to click and create another health check, and I'm going to call it managed instance group health check. I want it to check on TCP port 80. I want to know that port 80 is serving traffic. Right? The instance may be up, but Apache web server may have crashed. And without doing this port check on 80, we would never know. So our check interval is going to be 10 seconds. Timeout after 5 seconds. 2 consecutive successes is healthy, and 3 consecutive failures is unhealthy. So I'm going to click save and continue. The initial delay of 300 seconds is always set, right? Just to get everything up and make sure everything's stable. So I'm going to go ahead now and click create. My instance group is now created. Once it's finally done, you'll see how many instances are actually running and what the template is based on. So you can see it's going from 0 instances to 1 instance. The template is web server, and it's a managed instance group type. If I scroll over, I can see any auto scaling and the zones. So I'm in 3 of 4 zones. Once it's all completed, it'll change, and you should see some auto scaling configuration in there as well. So this time it takes a little while to spin up because it's looking at the template, bringing it in, provision your resources. But now, as you can see, I have 1 instance in my web server group. So if I come over to VM instances, I should see now that I do indeed have a new instance. It's the web server instance group. It named my instance for me, and it's in use by the web server instance group. So the in use column shows me which instances are being used by a managed instance group. So if traffic really goes high on this instance, it can scale upwards to 10 instances based on that instance group. So I hope this video showed you how to create an instance group and a health check and the value behind incorporating these instance groups and health checks into your VM infrastructure. So in this course, we've examined implementing the Google Compute Engine. We did this by exploring VM instances and the instance lifecycle, creating VM instances from an image, snapshot, or using gcloud, and VM preemptible instances and Windows Server instances. We also took a look at provisioning VMs on sole tenant nodes, generating custom SSH keys and connecting to VM instances, and creating managed instance groups and instance templates. In our next course, we'll move on to examine implementing Google Compute Engine.